everyone and welcome to the SQL Full Course, your complete guide to mastering structured query language from the ground up. This course starts with the basics of what SQL is, how to write queries, use operators, functions and joins. And as you progress, you will dive into more advanced topics like normalization, triggers, SQL versus NoSQL, PostgreSQL and SQL Server. You will also explore SQLAlchemy with Python and learn how to connect SQL with tools like Power BI for real-world data analysis. Whether you're preparing for interviews, working with data science or building back-end systems, this course provides the practical skills and knowledge you need to work confidently with databases. So before we get started, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's Microsoft SQL Server Training Certification course designed by top industry experts. This comprehensive course will teach you how to manage and work with databases using SQL Server. You will gain expertise in SQL commands, subqueries, joins, unions, indexes, and Azure SQL database. So enroll today to work on real-world industry projects and become a certified SQL Server database administrator with Edureka. Check out the course link given in the description box below. So now, let's get started with our first topic, that is, what is SQL?
In today's computing world, managing data is a huge task. For our convenience, we store the data and documents in different locations, and this is called file system. Without a file system, information placed in the storage medium would be one large body of data. We won't be able to tell where information stops and where it begins. Let's look at the formal definition. File system is one which controls how the data is stored and retrieved. It is nothing but information stored in different computer files. Usually, while storing a small amount of data, the file system is effective. But when it comes to storing the enormous amount of data, the file system fails. Let's look at some of the problems of file system. The first problem is data redundancy. When we store similar data in different locations of a computer, data gets duplicated, and this will lead to data redundancy. This will increase the storage size and also leads to failure of security features. Because of this, the file system is highly vulnerable in nature. Data redundancy will cost the user not only in terms of security, but also economically. The second problem is limited data sharing and lack of security. Data sharing and security are closely related. Sharing data among multiple users introduces a lot of security risk. In terms of spreadsheet data and other documents, the inbuilt file system programs provides only the basic security option, but they are not used most of the time. Because of this negligence, we might face some bigger problems in the near future. The third problem is the difficulty of getting quick answers. This is one of the major problems in file system because file system doesn't allow multiple users to access the same data at a given point of time. This means that multiple users at different work locations cannot access the same data simultaneously. This will limit the access to important data if multiple users search for the same data at a given point of time. The next problem is data dependence. In the file system, files and records are described by a specific physical format that is coded into the application by the programmers. If the format of any one record was changed, then we need to make sure that all the remaining records format is updated. This information has to be updated in the system also. Any changes in storage structure or access methods could greatly affect the process. This might result in failure of that particular application. So these were few problems that were faced using the file system, and the solution for this is SQL and database. Let's now look at the evolution of SQL. SQL was developed at IBM by Donald D. Chamberlain and Raymond F. Boyce in the early 1970s. It was initially called as SQL, that is, Structured English Query Language. But later it was changed to SQL because SQL was a trademark of UK-based engineering company. In the year 1986, American National Standard Institute, that is ANSI, and the International Standards Organization, that is ISO, have deemed the SQL language as a standard language in relational database communication. This is how SQL evolved. Since we have understood the evolution of SQL, let's head to the next topic, that is, what is SQL? People from technical background may find this silly, But for a beginner, it is really important to understand each and every aspect of this topic. The main focus of this entire session will be on this part. So now let's understand what is SQL. SQL is an abbreviation for Structured Query Language, which also goes by the name SQL even today. It is a language used by the database domain. SQL can be used only for relational type database and not for the others. A relational database is a database which has the tabular method of storing data. Usually, it consists of rows and columns. Let's now see what SQL can do. SQL is a core of relational database which is used for accessing and managing the database. With the help of SQL statements, you can add columns, update or delete rows of data. We can also retrieve information, modify database, and perform many more actions. The different subsets of SQL commands are as follows. DDL, that is Data Definition Language. It simply deals with the description of the database schema and used to create and modify the structure of database objects in the database. It allows you to perform various operations on the database such as create, alter, and delete objects. DDL is very popular and extensively used when compared to other commands. Moving on to the next command, DCL, that is Data Control Language. It allows you to control access to the database. Grant or revoke are the DCL commands. Grant gives user access privileges to the database, while revoke withdraws user access privileges given to the user with the help of grant command. So the next command is DML, that is Data Manipulation Language. It allows you to access and manipulate data. It helps you to insert, update, delete, and retrieve data from the database. So what does each of these commands do? So the insert command is used to insert data into the table, while update is used to update existing data within the table, and at last, delete is used to delete records from the database. The final command is TCL, that is Transaction Control Language. It allows you to deal with the transaction of the database. Few of the TCL commands are commit, rollback, save point, and set transaction. So these were the SQL commands. To understand SQL in a better way, let's use an analogy. If two people want to communicate with each other, then they have to use a language that is understood by both of them. Here, John wants to start a conversation with Dave, and he uses English language to start his conversation. This language is known to Dave as well, so they will continue their conversation. But what if one of them didn't understand what the other person spoke? There won't be any conversation at all. Relating this analogy, if we consider these two people, one as user and the other as database, then that language which is used to communicate between these two is called SQL. Similarly, how a language has the grammar and various rules on how it should be used, even the SQL has its own directives. I hope you have clearly understood what exactly SQL is. Let's now head to the next topic, that is advantages of SQL. So the first feature is SQL has well-defined standards. As it says, developers of SQL has clearly mentioned how exactly each and every query has to be written. There is no room for ambiguity when it comes to writing a query. The standards have to be followed. The second advantage is SQL is easy to learn. Yes, SQL is a language that is used to work with a database. Since SQL has a large user base as well as well-defined standard, for a beginner it is really easy to learn. The next one is, in SQL we can create multiple views. This is one of the unique and early feature that SQL came up with. View is nothing but creating a virtual table. A virtual table is a temporary table for certain use. By doing this, we can protect the integrity of the data. SQL has the ability to not only create a single view but can create multiple views. The fourth one is SQL queries are portable in nature. It means we can execute the SQL query in one system and execute the same query in another system without changing the format. But the condition is that the environment setup of these two systems has to be same, else the query won't be executed. The next advantage is interactive. The main purpose of SQL is to communicate with the database. We can write complex queries to fetch the results from the database, and these queries can be easily understood by anyone. So these were some of the advantages of SQL. Let's head to the next topic, that is SQL in real time. Since SQL is a language that is used to operate on the database, we need to look at the bigger picture of the data management industry. Here, if I say database, it includes SQL language as well. The database is used in different verticals like online stores, healthcare providers, libraries, financial industry, retail industry, government agencies, and many more. Now let's consider some real-time examples of the use of SQL and database. The first one is education sector. Database systems are frequently used in schools, colleges, and universities to store and retrieve the data. This data may be regarding student staff details, course detail, exam details, attendance details, and fees details. There's a lot of interrelated data that needs to be stored and retrieved efficiently. To understand the magnitude of impact that the database has made in this field, try to imagine the days when the results were only declared on the school notice board. Isn't it easier now to access your exam results with just one click? Who wouldn't say no to such a drastic change? Also nowadays, the online exams have increased significantly. This has increased the speed of assessment when compared to the olden days. All these are possible because of SQL and database technology. The next sector is healthcare sector. There were days when people used to stand in front of the clinics and hospitals to get an appointment with a doctor, but now the time has changed. In hospitals and medical institutions, maintaining data related to doctors, patients, and staff is a huge task. Effectively coordinating among these three has to be handled seamlessly. With the help of SQL and database, this industry has gained a lot. With the introduction of SQL and database, inventory management has been effective. The next one is retail industry. Every year, leading e-commerce giants come up with great offers, discounts based on your personalized shopping. To come up with all this, they use database and other technology. The industry utilizes the database and SQL technology extensively. In retail industry, customers' data has to be managed effectively. There's no scope of error when it comes to handling the data. With the instigation of SQL and database system, the retail industry can not only secure the data, but also can get the real-time analysis, which in turn helps them to make a lot of profit. And the final one is financial sector. When we speak about this sector, it's really hard to even imagine what goes behind the scene. Only the experts know how much data will be processed every second. Managing money, assets, shares, etc. in a real time is a tedious task. SQL and database technology is helping the financial sector to achieve its primary task. SQL queries can be also used to check the fraudulent activities. Looking at the issues of fraudulent activity, effective fraud detection requires a financial organization to process a huge amount of customer purchasing data. So these organizations have to store and retrieve data effectively without causing any burden on another branch of the same organization. These were the few sectors and industries where the SQL is used in day-to-day transaction. This brings us to the end of this session. I hope you have clearly understood what is SQL, its evolution, and its application. Do you know when SQL was born? Well, let me answer that question for you. SQL was developed at IBM by Donald D. Chamberlain and Raymond F. Boyce in the early 1970s. It was initially called as SQL, that is, Structured English Query Language. But later it was changed to SQL because SQL was a trademark of UK-based engineering company. SQL is said to be a powerful language. Reason for that is it uses very simple English sentences and also uses very few lines. It uses common words such as select, insert, update, and many more to perform its core functionalities. SQL is known to be a declarative language. When you write a query, you have to describe what needs to be done, and you don't have to worry regarding the flow of the query. It will be handled internally by the DBMS that you're using. Now, let's look at some of the features of SQL. So the first feature is SQL has well-defined standards. As it says, developers of SQL has clearly mentioned how exactly each and every query has to be written. There is no room for ambiguity when it comes to writing a query. The standards has to be followed. SQL is easy to learn. Yes, SQL is a language that is used to work with a database. Since SQL has a large user base as well as well-defined standards, for a beginner it is really easy to learn. Next one is, in SQL we can create multiple views. This is one of the unique and early features that SQL came up with. View is nothing but creating a virtual table. A virtual table is a temporary table for certain use. By doing this, we can protect the integrity of the data. SQL has the ability to not only create a single view but can create multiple views. Finally, SQL queries are portable in nature. It means we can execute the SQL query in one system and execute the same query in another system without changing the format. But the condition is the environment setup of these two systems has to be same, else the SQL query won't be executed. So these were some of the features of SQL. Now let's look at the next topic, that is data and database. Firstly, let's look at what is data. So the standard definition for a data is values from different source which has been translated for some purpose. And this purpose can be anything. Source for the data can be like temperature reading, financial data, videos, blogs, text, etc. It goes on. In the end, it should make a meaningful sense. Only then we can consider it as a data. This image clearly depicts the different source of data. So we can clearly understand that the data source can be anything. Since we are clear about what data is all about, let's head to the next topic, that is what is database. Firstly, let's look at the formal definition for a database. A database is an organized collection of data where the data is stored and accessed electronically from a computer system. To make you understand what it means, let me use an analogy to explain the concept of database. Consider a library. Usually, the library contains a huge collection of books of different genre. Here, library is a database, and these books are the data. In the image, we can see a person performing an action on the data, and those actions can be like create, store, update, etc. When the user sends the instruction as well as the data, it will be stored inside the database after a certain process. And this entire process is bidirectional. That is, control flows on both the sides. Next, I'm going to talk about different types of databases. There are different kinds of databases that are in use today. And these databases are classified based on capabilities, features, functionality, size, and performance. So few of them are distributed database, object-oriented database, centralized database, operational database, graph database, cloud database, NoSQL database, and finally, relational database. Among these databases, the two popular types that are widely used are, first one, relational database, and second one, NoSQL database. Relational databases generally uses SQL language, and we're going to learn more about it in the coming modules. Moving on, let's look at some of the popular databases that are widely used today. So they are MongoDB, Postgres, Microsoft Access, Microsoft SQL Server, MySQL, and Oracle DB. These are the few popular databases that are used today. Each one of them has its own pros and cons. Since we have already started the topic of database, it wouldn't be fair to drop this topic abruptly. So I shall discuss a few basic database related queries. The first query is how to create a database. To explain this, let me jump into MySQL Workbench. This is the interface of MySQL Workbench. On the left side of the screen, we can see the database. In the center area, we are going to write our queries. At the bottom part, we are going to get the status of the query that has been executed. So you might wonder why I'm using MySQL Workbench for executing SQL queries. Well, SQL is a language that is used to communicate with the database, whereas MySQL Workbench is a database management system. So MySQL Workbench allows us to use SQL queries to communicate with the database. Can't we use other DBMS? Yes, we can, but the syntax of the queries may slightly vary. So let me explain you the first topic, that is how to create a database. And the syntax for this is create database are the keywords used to create a database. Followed by that, we have to specify the name of the database. Here, I'm using Edureka as a name for my DBMS. So let me select this entire statement and click on the lightning icon. So I can see at the bottom that the database with the name Edureka has been created. So let me refresh it. So we can see that the database with the name Edureka has been created. So the next topic I'll be discussing is how to delete a database. And the syntax for this is drop database are the keyword used to delete a database, and followed by that will be the database name. So let me select this entire query and click on the lightning icon. So we can see that the database with the name Edureka has been deleted. So these were the few queries related to database. The next topic that we're going to learn is table. So what is a table? A table in a database is nothing but a collection of data in a tabular way. It consists of rows and columns. The table contains data elements also known as values using a model of vertical columns and horizontal rows. The point of intersection of a row and a column is called a cell. A table can have any number of rows but should have a specified number of columns. To understand the concept of a table in a better way, let's look at the image. So the name of the table here is person. When we create a table, it has to have a name. A table without a name doesn't exist. So what is tuples? A single row of a table which contains a single record for that relation. Here there are 6 tuples. Next is attributes. Features of an entity is called attribute. An attribute has a name and a data type. Here there are 4 attributes. Those are ID, first name, last name and date of birth. So I hope you have understood the concept of table. Let's now understand the table constraints. So what are table constraints? In simple words, it is a restriction that are specified by the user while creating a table. So you may wonder why these kinds of constraints are required. The answer for that is, even though a table stores the data, that data has to be of certain format. To ensure the data integrity, we use constraints. These constraints have to be decided during the creation of a table. If we want to change the constraint, then we have to delete the table and then we have to create a new table using the new constraints. Few of the constraints that are used most of the times while creating a table are check, default, primary key, foreign key, not null, index, and unique. Since we have understood what table is, let's look at some of SQL queries related to the table. The first one is how to create a table. To understand this, let's head to the MySQL workbench. To create a table, we need an active database. Since we had deleted the previously created database, let me create the database once again. So we can see that we have a database with the name Edureka. So now let me create the table. And the syntax for creating a table is create table is a keyword used to create a table. Followed by that, we have mentioned the table name. We need to make sure that the table name is unique. Keep in mind that in a database, there cannot be 2 tables with the same name. Inside the table, we have declared the columns along with the data type, and we have to end the query with a semicolon. So let me execute this query. So we can see that the table EMP has been created. So the next query I'm going to discuss is how to delete a table. And the syntax for this is we shall use drop table keywords to delete a table. And followed by that, we have to specify the table name. So let me select this entire query. And we can see that the table with the name EMP has been deleted. With all the basic introduction understood so far, let's now understand some SQL basic queries. Let me begin this by introducing the most basic and widely used query, that is select statement. And the syntax is select column name from the table name. We can specify the name of the columns that are present in the table. Also, note that if you want to display all the columns of a table, then use star operator. Now, let's jump into execution part. To explain the entire SQL queries, I'm using student table. And this student table has student ID, first name, last name, address, city, and marks as its columns. So the syntax for select statement is select star from student. Since we have to display all the columns, I'm using star operator. So let me select this entire query. So we can see that the entire table has been displayed. So this is one of the way in which we can use select statement. The another method is if we want to select a particular column, then we have to specify that column name. And the syntax for that is so we can see that from the table, we have selected only first name and last name. Usually, select statement is used to select the data from the database. So the next SQL query that I'm going to discuss is where clause. Where clause is used to filter records. Where clause is used to extract only those records that fulfill the specified condition. To demonstrate where clause, let me assume this scenario. If I want the name of the students who are from the city Goa, then my where clause query will be something like this. Select first name from student where city is equal to Goa. So let me select this query and execute it. So this is the output. Now Let's look into and or not statements. If we need to add two or more conditions in the where clause, then we can use the above mentioned operators. These keywords will add more complexity to the query. So the first operator is AND operator. This operator displays a record if all the conditions separated by the AND operator are true. Let's look at the syntax. Select columns from table where condition 1 and condition 2 has to be true. To understand the example, let's dive into the demo part. I want to display the details of the student who has the first name as Bharat and last name as Singh. To achieve this, I'm using AND operator. So let me execute this query. Yes, I got the output for the student name Bharat Singh. The next operator I'm going to discuss is OR operator. OR operator usually displays a record if any of the conditions separated by OR is true. And the syntax for this is select columns from table where condition 1 or condition 2 is true. To understand the example, let's dive into the demo. I want to display the details of a student who has the first name as Bhuvi or the last name as Kumar. To achieve this, I'm using OR operator. Here, any one of the condition has to be true. So this is the query to execute a scenario. So we have got the output for the student with the name Bhuvi Kumar. So let's head to the next operator, that is NOT operator. So this operator displays a record if the condition or conditions are not true. So the syntax is select columns from table where the condition is not true. Let's see how this example works. Here, I want to display the details of the student who does not have the first name as Ashok. To achieve this, I'm using NOT operator. In this, we can see the details of all the students except Ashok. So the next query I'm going to discuss is insert into. If we want to insert any record or data into a table, then we can use insert query. And the syntax for this is insert into is a keyword that is used in insert query. Followed by that, we have to specify the table name and columns. After that, we have to specify the values. Let's look at the example to clearly understand how exactly this query works. So this is the example for insert query. So we are going to insert first name as Manoj, last name as Sharma, address as 07 MG Road and city as Jaipur. Also the marks is 438. So let me execute this query. So we can see that the data has been inserted. To check whether the data has been inserted or not, let me use select query. So we can clearly see that Manoj Sharma details has been added to the table. Next, I'll be discussing few aggregate functions. An aggregate function is a function where the values of multiple rows are grouped together as input on certain criteria and a single value is returned. We often use aggregate functions with the group by and having clauses of the select statement. So we will be discussing group by having in the later part of the session. Some of the aggregate functions are count, sum, average, minimum, and maximum. So let's discuss each one by one. So the first one is count. This function returns the number of rows that match specified criteria. So the syntax is count of column name from table where the condition. So now let's try this example in MySQL workbench. Using this query, I will calculate the number of student ID that is present in the table. So let me select this query. In the output, we can see that the count of the student ID is 6. The next aggregate function is average. An average function returns the average value of a numeric column. So the syntax for this is select average of column from table where condition. Let's execute this example. Here, I'm trying to find the average marks scored by all the students. So let me select this query. So the average marks scored by all the students is 480.333. The next aggregate function is sum. Usually, sum function returns the total sum of that particular column. The syntax is select sum of column from table where condition. So let me execute this example. In this example, I'm trying to find the total marks scored by all the students. So let me select this query. The total marks scored by all the students is 2882. Moving on to the next aggregate function, that is minimum. Minimum function will return the smallest value of the selected column. And the syntax is select min of column from table where condition. So let me execute this example. If I want to know the student name who has scored minimum marks, I'll use this query. So let me select this query. Ashok Sinha has scored 385 marks, and this is the minimum marks in this entire table. And the last aggregate function that we're going to discuss is max. Max function returns the largest value from the selected column, and the syntax is select max of column from table where condition. Let's execute this example. So this is the example for maximum function. So let me execute this query. So we get the output, that is Bharat Singh has scored 580 marks. So 580 marks is a maximum marks in the entire table. Next SQL query is group by. Group by is the functionality used to arrange a similar type of data into a group. For instance, if the column in a table consists of similar data or values in different rows, then we can use group by function to group the data. The syntax is select column from table where condition group by the same column. Let me execute this example. I want to count the number of students who are from different cities. If there is any student from same city, then the count will be incremented. At the end, the output will have all the city name with the count of the students from that particular city. So let me execute this query. We got the count of students from different cities. Since all the students are from different city, we can see that the count is 1 in all the cases. If the data is large, we can clearly get to know how effective this query is. Next query is having. This clause is used to place condition where we need to decide which group will be part of the final result set. The having clause was added to SQL because the where keyword could not be used with aggregate functions such as sum, count, min, max, etc. So the syntax is select column from table where condition group by the column and having condition. So let me execute this example in MySQL workbench so that you'll get an idea about having clause. From the table, if I want to display the students who have scored more than 500, then I'll specify that condition after having keyword. So let me execute this query. So we can see that there are two students, Ashok and Bhuvi, who have scored more than 500 marks. Moving on to the next query, that is order by. Order by keyword is used to sort the result set in ascending or descending order. This keyword is used to sort the result set in ascending or descending order. The order by keyword shall sort the record in ascending order by default. If we want to sort the record in descending order, then we need to use the descending keyword. So let me explain the syntax. Select columns from table, order by columns, either by ascending or descending. Let me execute this example. In this example, we will get the count of students from different city, and we are arranging the city in descending order. So let me execute this query. We can see that the cities are arranged in descending order based on the starting alphabet. The next SQL query that we are going to learn is null values. In SQL, we use the null term to represent a missing value. A null value in a table is a value that appears to be blank. A field with a null value is a field with no value in SQL. Keep note that a null value doesn't mean that the value is equal to 0. To check the null value, we are not supposed to use the operators such as greater than, less than, equal to. These operators are not supported in SQL. We have special keywords. Those are is null and is not null. First, let's look at the is null operator. Is null operator is used to test the empty values. And the syntax for this is select columns from table where column is null. So let me execute this example. I want to display the student's name whose marks is null. So let me select this query and let me execute this. Since all the students have marks and none of them has null value, in the output we don't have any student names. The next query is not null. The is not null operator is used to test for non-empty values, and the syntax is select column from table where column is not null. So again, let me execute this example. I want to display the student names whose marks is not null. So let me execute this query. Since all the students have marks, all the student names are displayed. Let's move to the next query, that is update. Generally, the update command is used to modify rows in a table. The update command can be used to update a single field or multiple fields at the same time. Let's look at the syntax for update statement. Update, table, set column equal to value, where condition. Let's execute this example. Here, I want to change the name of the student with student ID 1. Previously, the student with student ID 1 was Ashok Sinha. Now, I want to change his name to Amar Kumar. So let me execute this query. So we can see that the student name has been updated. To check the student table, let me execute this query. And we can see that the name of student ID 1 has been changed from Ashok Sinha to Amar Kumar. The next query we are going to discuss is delete. The SQL delete command is used to delete rows that are no longer required from the database tables. It deletes the whole row from the table. The syntax is delete from table where condition. So let me execute this example. If we want to delete a record from student table where the city is Mumbai, let me execute this query. So we can see that the query has been executed. To check the table, let me execute this statement. And student with the ID 1 has been deleted. Next, let's discuss in and between operators. In operator is used to specify multiple values inside the where clause. It acts as multiple OR. Let's look at the syntax. Select column from table where column in value. Let me execute this example. If we want to display the record of a student who are from certain city, then we can use in operator. In the given example, let's display the name of the students along with their IDs who are from Delhi, Goa, Pune and Bengaluru. Let me execute this query. In the output, only those students from the specified city name are displayed. The next operator is between. Between operator will select a particular value within the specified range. It is compulsory to add the beginning and the end value. Let us look at the syntax. Select column from table where column name between value 1 and value 2. Let's execute this example. If we want to display the record of students whose marks are in certain range, then we can use between operator. In the given example, let's display the name of the student along with their ID who has scored in the range of 400 and 500. So let me execute this query. In the output, only those student records who have scored in the range of 400 and 500 has been displayed. So the next topic we're going to cover is aliases in SQL. Alias is a process of giving a table or a column a temporary name so that it helps when the query is complex. It increases the readability of the query. This renaming is temporary and the table name does not change in the original database. We can alias a column or a table. So the first concept is column aliasing, and the syntax is select column name as alias name from table. So let me execute this example. In the student table, the column name student ID is a bit long. When we write a nested query, we might face some trouble. In order to tackle such situation, let alias that student ID column as ID. So let me execute this query. And we can see that the column student ID has been aliased to ID. Next is table aliasing. Now, let's look at the syntax for table alias. And the syntax is select column from table as alias name. So let's execute this example. We generally use as keyword in aliasing. So let me execute this query. By using the technique of table aliasing, I have displayed the names of the students from the student table. So that was the basic concept of SQL.
Not in. So not keywords is basically logical operators, and it is used along with other operators like in and other. So we have just seen one example where we want to show the departments which are not in Hyderabad. So this is the repetition of the same example. In the previous example which I shown, I included only one locations, but we can use multiple keywords if you're using the in keywords. We'll see the example just now. In operator fetches values from a set of literals. So this condition is generally used when we want to fetch values from multiple values in a single statement. So it's not that I can use only in, I can use OR operators. So if there are only one or two conditions, I can either use OR operator or IN operator. But if the values are more, it is not a good idea to use so many OR operators or logical operators. Let's assume I want to see the results in 10 cities. So if I write like where location is equals to Mumbai or New Delhi or Hyderabad or Bangalore or Chennai, it is not readable. It's not good. So instead of writing so many OR operators, we can use IN operators. So the IN operator, we basically include all the values out of which we want to filter our results or we want to fetch our values. So let's see with an example. So let me open a new query window and write select from department. So if I want to see the results or see the departments which are either in Chennai or Bangalore, so I'll write select star from department where location in, it can be in any one of these locations. That's how we are Bangalore. Don't forget to include strings or characters in single quotes in SQL. So this will fetch the desired results. So we can use multiple values in the parenthesis if we use in comparison operator. So if I use not in, then this will go in a negation and will show the opposite of what in operator is doing. So we have discussed not in as well as in. So if there are multiple values, so instead of or, we have to use, it is good practice to use in keyword. Then basic comparison operators, we have greater than, equals to, less than, greater than, equals to. So this is pretty much self-explanatory. So if I want to select the employee whose salary is greater than 20,000, so let's see how we'll get the results. So I can use the previous window. So where salary, instead of this, I can write salary is greater than 20,000. So I'm getting 3 results. So I have 3 records or 3 rows or 3 employees whose salary is greater than 20,000. So if I include greater than or equals to, then I guess I'll get 4 results. Oh, I don't think so. We have a salary of 20,000 here. No, we don't have. So let's take the example of 30,000 here. So we'll get the 3 results. But if I remove the equals to keywords, then of course we'll get only 2 rows in the result set. And if I use the equals to, then we'll get the only single row which will satisfy the desired or required condition. So this is how we use a various operator: greater than, equals to, less than, greater than, equals to. Again, this example, we can use equal operator. It will satisfy the desired conditions, fetch the results. Comparison operator is the like, how we use the like keywords in comparison operator. So generally we use like operators to perform wildcard searches of valid search string values. As I mentioned earlier, that like keyword is generally used when we are filtering or fetching the strings. So it used with 2 wildcards. One is percentage. Percentage denotes 0 or many characters, and underscore denotes 1 characters. So let's see. So in the first example, as you can see, I'm getting the values from the department table whose locations starts with C or the C alphabets. Let's see how we can use it. So we'll first see how we use the percentage wildcard. So if I want to know that what are the different departments where the locations start with the alphabet C, so we'll write select star from department where LOC, I have to use the like keyword, like parenthesis, and then the keyword C with a percentage sign, that is wildcard, and get the results. So if I just change the order, if I write the wildcard first and then C, it means I have to show the departments whose location ends with C. So if I'll write it I here, then again I'll get the desired cell because I'm fetching the rows whose location ends with the I keyword or I alphabet. So if I use first wildcard and then alphabet, it means it ends with. If I'll first use the alphabet and then wildcard, means it's start with. If I'll write something like this, it's C, then wildcard and I. It means it starts with C and it ends with I. So fetch me the locations who start with C, because I'm using the C before the wildcard, and since I'm using I after the wildcard, so it ends with I. If I'll execute this query, again it will show me the same results. But if I change it, for example, I'm starting with H and ending with I, so there is no department with such a condition, so it'll get an empty result set. Now if I need to show that, show me the department who starts with H, in that case all I have to do is that we have to remove the I. So we have to use the keyword before the wildcard and it will show us the result. So along with percentage signs, we use underscores also as a wildcard. So in this example, as you can see, the second example, select department or location from department where locations like. So it means the first three words should be CHEN. Then we can use underscore. So we have to first satisfy the first keyword. So the first three should be this. So this is how we use the underscore wildcard. The last topic of this module is the case expression. So case expressions helps us to kind of simulate the if then else statement. Like in most of the programming language we use if else. So this helps us to write the same. Only point with a case statement is that, as you can see in the note, we cannot use null values in the case statement because it always uses the equals to operator. And we cannot use equals to operator with the null keyword. We have to use is null, that I'll show you after this example. So let's assume I'm fetching values from employee. So if I'm looking for the salary column, there are a few rows which are having null values and there are a few rows which are having values in it. So if I want to see that what are the different employees which have null values for the salary column. So if I'll try to write where salary equals to null, then I won't get any result here because equals to operators does not work with null. So if I'm checking null, we have to use is null. If I'll execute this query again, I'll get the desired result. If I want to check, if I want to fetch the columns which do not have null values for the salary column, then we have to use is, and then we have to use the not logical operator, is not null. So not logical operators is always used in combinations with other operators. We get all the employees do not have null values for the salary column. So that is the reason we are using case expressions. So we cannot use the null values, otherwise it will break, because we use the equal to operators and equal operators is not used along with null. So this is how the syntax of case expressions. As you can see, we have declared a variable int input, its type of int, and we have set the values is equals to 2. It's just an example. So we have hard coded the value here in this example. So we are selecting case. I'm just selecting that if the value is 1, then we'll show the output as 1. When it is 2, then we'll showing the output as 2. When it is 3, then we are showing output as a 3. And if it is not out of any these three values 1, 2, and 3, then we'll show the message as your message. This is how we are doing in this example. So let me give you one example for that. Let me do one thing. Let me find out the states of the cities where my department is. So as we know, the Chennai is in Tamil Nadu and Bangalore is in Karnataka. So let's see how we can do that using a case statement. So we have to write select, then case keyword. And the case keyword will define which columns we want to fetch. So I'm fetching the location, and then we'll write the when condition. So I'm writing when Chennai, then show the result as Tamil Nadu, when Bangalore, then let's say Karnataka, and I'm writing an else condition if it is not part of anything. So let's write no idea. So we have to end the when condition, and we have to write from which tables we are basically fetching this results. So if I'll execute this query, I'll get, see, if it is Chennai, I'm getting the result as Tamil Nadu, and if it is Bangalore, then I'm getting as KR. And since there's some departments which do not have any values like Hyderabad, so we are getting is just no idea. So this is how we can use if else conditions in SQL statement or select statement by using case expression. Important point is that we should not deal with where we're using null because we use equals to operator. Built-in functions are used to calculate values and manipulate data. These functions can be used anywhere as expressions. When we say anywhere, it means we can use them in the select query, we can use them in where clause, we can use them in having clause. So these built-in functions can be used anywhere based upon the business requirement or based upon the type of functions which we are using. So we broadly categorize the various built-in functions into the following categories, as you can see on the screen. So we can divide the built-in functions into conversion functions, where we convert the values from one data type to another data type. We have logical functions, math functions to play around with the data, mathematical operations. We generally use math functions. Aggregate functions, if you want to calculate, for example, average, we want to calculate sum or total of salary of all the employees, then we use aggregate functions. String functions helps us to play around with various strings or characters in our data. Most of the string functions are somewhat similar to the string functions which we have in other programming language or the basic programming languages like C, C++, C# or Java. Date functions have all the basic functions which we can use to manipulate date or retrieve date from our database. So let's discuss all of the functions one by one in coming slides. As we discussed that these are the various categories again: conversion functions that support data type casting and converting. Logical functions are scalar functions that perform logical operations. These are kind of similar to the math functions. Are again the scalar functions which performs calculations usually based on the input values that are provided as an argument, and most of the times they returns a numeric value. Aggregate functions, as I mentioned, we use sum, we use average, we use maximum of values. So aggregate functions basically perform a calculation on a set of values and they return a single value, except for the count. So count is also an aggregate functions. Other than count, all other aggregate functions ignore null values. In the objective, we saw that we are going to discuss about the group by and having clause. So aggregate functions are frequently used with the group by clause of the select statement. Or we can say that we use group by clause only with the aggregate functions or group functions. Some people refers aggregate functions as a group functions, so don't get confused, they are one and the same thing. String functions again are scalar functions and they perform an operations on a string input value and return strings or numerical value based upon the kind of functions which we are using. Date function, straightforward, it manipulates the dates. So let's start with the conversion functions. As the name itself suggests that these functions helps us to convert an expressions or a value from one data type to another. So we have three commonly used conversion functions: cast, convert, and parse. And in the bottom three, you can see that we have try underscore cast, we have try underscore convert, and we have try underscore parse. So the top three and bottom three, they give the same results. They work in the similar fashions. The only difference here is that the top three functions returns value of specified data type and on success throw errors on failure, whereas the bottom three, they give the null values on failure. So we can relate this try as like how we have the try catch block in other programming language to handle the exception. Same way we use try cast if you want to get the null values if something wrong happened while calculating the expressions or while fetching the results. Same is the case with try convert and try parse. But if any error happen while using cast, convert, and parse, we'll get an exceptions or we'll get an error. Whereas error can be handled by converting it to the null values if we use try, cast, try, convert, and try parse. So as you can see on the slide, we are converting the value 10 as int and we are multiplying by 20. Again, we are converting int 10 to int and again we are doing a multiplication of the value after conversion with 20. So then what is the difference between cast and convert? Because the end result is almost similar. So both function can be used interchangeably in most of the situations. The only difference is that cast is NC compliant. It follows American National Standard Institute, whereas convert does not follow any such compliancy. Let's see an example of these basic operation. So I'll open Management Studio of SQL. Let's open a new query and let me copy the example. So let me copy both the examples. I increase the font size. So if I'll execute, I'm getting this result. Since we are converting 10 as int, and again, if you'll see, the result of cast function and convert functions is exactly similar. Only difference is in the syntax. The syntax of convert function is different from cast function. So one important point I just want to mention here is that in select operation, we can use mathematical operators like we can use plus, minus, divide, and multiplications. So here, after converting 10 into int, we are multiplying it with 20 to get the end result. And this is the alias which we discussed in module 2. So we can change it. We can change it to any value. We can change it. Let's say I'm writing it to cast result, and I can change it to convert result. Now if I'll execute it, I'll get the same results. Cast results and convert result here are alias. These are the alias for the columns. In the module 3, we saw that we use alias for the table. So let's see that if there's an issue while casting or converting a desired value, then we'll get an error when we'll use cast and convert, but we'll get a null value when we'll use try cast and try convert. Let's verify this using an example. So I'm trying to convert character into int. So we'll get an error that conversion failed when converting the varchar value a to data type int. Now let's use try cast. So I'll copy this statement. So let's assume I use try convert. And if I'll try to convert a value which is not numeric, and if I'll execute it, we'll get the incorrect syntax near the keyword try convert. Sorry, I forgot to write select. And if I'll execute it now, we'll get null value. So instead of error, we are getting a null value if we'll use try convert or try cast. So based upon the business requirement, we'll choose either the try convert or convert. Let's move to the next function. Let's discuss about the logical functions. So we have two logical functions, choose and if. Logical functions can be used to display one of the several values based on a logical conditions. So as we have discussed, we have two logical functions, choose and if. Choose returns a specified index from a list of values and returns null if the index is 0 or greater than the number of items. Or we can say that the choose basically act as an index into an array when an array is composed of the argument that follow the index argument. So as you can see in syntax, we have the choose keyword, and in the parenthesis we have index. So this is the index which we have to define that what value we want to return, and this val 1, value 2, and we can have up to value n. So let's understand choose by an example. So let me write one example so that it will help us to understand. Choose keywords, and all these functions are basically can you see the color code? For the keywords we basically have blue colors, but for these functions we have pink color. So we'll define 3. This is the index, and then it's followed by the various values. Let's say I have test as a one value, I have just as another value. Third value I'll be having rest. So if I'll execute this statement, I should get the value rest because this index does not start with 0. Please note it down. In the choose function, the index start from 1. This is one base index, not the 0 base index like we have in most programming languages. So if I'll execute this statement, I'll get rest because we are instructing the SQL Server that we want the third value out of the various values available. The choose function basically gives an error if you try to use the index as the value 0, or we'll try to provide the index which is outside this range. So let's understand it by an example. So if I provide an index 0, and if I execute this, I'll get a null value. Or if I'll provide an index which is outside the bound of this array, when I say bound, if it is more than the number of values which we are trying to select from, then again it will returns a null value. So this, since there are only 4 values here and I'm giving index 5, so since there's no value at the 5th index, it will return a null. It won't give us 0. So choose functions helps us to select from a given range of values, like how we used to fetch the values from an array. So let's discuss the other logical function. So here, before we discuss the if, let's see these examples as well. So in the first example, we are using select choose and we are giving index 2, A, B, and C. These are the 3 values. So this will, the first example will return the value B in the result set, because we'll count from the index 1. As I mentioned, the choose is based on 1 index and not the 0 index. So let's take the case of the second example. Here we have not provided an integer, we provided a fraction value 1.4. So choose only consider the integer value. In both the cases it will return A as in the result set. So now let's discuss the other logical function if. So let's focus on the syntax first. So it's followed by a if keyword, and then we have a Boolean expression, and then true values and false values. So when we execute this function, it returns one of the 2 values. Either it will return true value or either it will return false value. So the output, whether it is a true or false, depend upon the evaluation of Boolean expressions which will provide in the if function. So if is a shorthand way of writing a case expression. It evaluates the Boolean expression passed as the first argument and then returns either of the 2 argument based on the results of the evaluation. So we can even provide the nesting in the if functions. The nesting should be up to 10 level, similar to the nesting which we can have in the case expression, as it is almost similar to the case expression. So let's see or discuss the example of if logical function. So in this case, it will return false because this Boolean expressions is not satisfying. 1 is not greater than 10. So it will fetch the result false in the result set. Let's execute this example in Management Studio. So you have to write if, then you have to write the Boolean expression, then any value. Let's say I'm just writing true, and the next value if it turns out to be false. Let's see the example. Yeah, the example seems to be right. Let me copy from here. Okay, so we forgot to add the select keywords. Sorry about that. And if I'll execute, it will return the false. So since there is no header for the column name, we can provide an alias as well. If I'll make this statement as true, if I'll reverse the values here, then I will get true as an output in my result set. So as I mentioned, if works like a case expression, and we can nest it, and nesting can be allowed up to 10 level. So this is all about logical functions. So let's continue with other categories of functions. So let's discuss about the math functions. So math functions can be used to calculate business and engineering calculations. So these are various self-explanatory, and we must have used these functions during our engineering classes or any other classes where we do any engineering calculation. For example, when we convert it to an absolute positive value, then we use ABS functions. If we want to generate a pseudo random float values from 0 to 1, then we use rand function. Seed is an optional value here. If we want to return an exponential value, then we use exp function. In most of the mathematical values, we need to round up the values. When the values are of decimal, then we use round functions. So round returns a numerical value rounded to a specific length or precisions that we need to provide in the functions. Floor provides, or it returns, the largest integer less than or equals to the specified numerical expressions. Then we have square root. Square root returns the square root of the specified float value. Ceiling is just opposite of the floor, and it returns the smallest integer greater than or equal to the specified numeric expression. Square, again, as we know, the square of 2 is 4, so like we use the square functions to calculate the square of the specified float value. Power basically returns the value of the specified expression to the specified power. So these are the standard mathematical functions. We have used these functions. So here we can see a consolidated examples of all mathematical functions. So in the first example, we see select ABS minus 10. So here we are using absolute value. So it is converting the negative values to the positive value. And all these keywords we are using as an alias. So we are using ABS as alias for the first column. Rand, as we discussed, rand is basically helps us to get any random values. We can provide the seed. Seed is optional when we use these functions. So as you can see, we are getting a random value here. exp4, it basically helps us to get the exponential value. Flow, we use flow, so it will get the value 4.66, will get the value 4 here. So flow, we will get the value less than the nearest integer, and the ceiling will get the values greater than the nearest integer. So if I use flow 4.66, I'm getting the value 4. When I'm using ceiling, I'm getting value 5 here. Square root, the square root of 2.56 is 1.6. So this is the value we are getting. Square is just opposite to the square root. So we'll get the square of a digit which will provide in the parenthesis. So we have provided a value 4. So we are getting 16 as its result. Power 2, 3. So we are basically giving power 3. The base value here is the 2, and 3 is its exponential value. To the power 3 will get 8. It's statement. If you want to expand this, it's 2 into 2 into 2. So we are getting 8 as its result. Round function is basically to round the values, and we are using 2 as a precision value, so we have provided, so it is basically rounded up to 2.57. So let's execute few of the examples in Management Studio for better clarity. Let's use the square function and square root function first. So square root of 16, and always use the select statement or else we'll get an error. So I can even do like multiplications of various, I can use various mathematical functions and then I can multiply it, or I can use other operators like plus, minus. So if I'll execute this, so what I'm doing is I'm taking the square root of 16, that will be 4, taking square of 4, that is 16, so end result should be 64. Yep, so we get the result. As you can see, guys, when we don't give the name of the column, the header is blank. So it is good practice to provide the alias. As of now, I'm giving a standard keyword result set. If I'll execute it now, I'll get 64 as its value. I can even use other mathematical operator. I can use plus, so it will provide the sum of these two values. 16 plus 4, 20. So I'll get 20 in the result sets. I'm getting minus 12 its value. And let's see, can we club the functions here? So let me write select, and if I'll use apps function here, so now I should be getting plus 12 because I'm using absolute function, so it will convert the negative value into positive values. So we can club, we can nest the functions. So here in the apps functions, I'm using SQRT functions and square functions. We can play around with these functions as per our business requirement. Let's use an example of power. Let's use the base value as 2 and 2 to power 4. So the result will be 16. So this is equivalent to, sorry, if I'll expand this, power 2 is the base and 4 is the exponential. So I'll get the same results at 16. So this is all about the maths functions. Let's move to another category. Ignores null values. Aggregate functions are frequently used with a group by clause and for filtering, like we used to filter the data using where clause. So if you're using group by clause, then we use having keyword to filter the result set. So we have following aggregate functions. We have average, min, sum, count, and max. So let's start with average function first. So average returns the average of the values in a group. As we discussed, null values are ignored. So let's take an example of average function. First, let me fetch the values from department table. Okay, so I can use the average functions on department number column. So I can write select average. I'll write the column number from department. If I'll execute this, I'll get the average of the values. So let me execute both the queries in Funco so we can compare the results. So 25 is the average of 40 plus 30 plus 20, 10 divided by 4. So we can use average functions with a distinct keyword. We discussed about the distinct keyword in module 2. So distinct keyword helps us to fetch the unique records. So if you want to find the average of the distinct values, then we'll provide the distinct keyword before the column name. So let's take another example of the average function. Let me get the results from employee table. So as we discussed that average functions ignores the null values. So if I'll try to get the average of salaries, so we have only 3 rows where the salary is present, rest all the values are null. Let's see what is the result. Select average. I'll provide the name of the column from employee. So this is the average. So let me execute both the statement in Funco like I did earlier. So you're getting the average of this. So we can use average with the distinct keywords if you want to fetch the results. Okay, let's see whether we can apply the distinct here. So in the department 1 table, we have the repeated values for the department number. So if I want to ignore the repeated or redundant data or the duplicate data, then I can use the distinct keyword. So if I execute it now, I'll get the average as 25. But if I'll remove the distinct keyword, the result sets will be different. Sorry, my bad. I'm using department column. I have to change it to department 1. So let's first see the result set without using the distinct keyword. The results is 30. Now I'll use the keyword distinct. So the value is different because I'm just taking the unique values for my result set. So let's move to another aggregate function. Let's discuss the min function. Similar to average, min also ignores the null value and it returns the minimum value in the expression. So if I'll see the values in the department 1 table and if I'll try to find the lowest value of the department number, then I have to use the min function. Okay, so out of all the aggregate functions, count is the only one which takes into account the null values as well. So let's see the example of count. Let's move to Management Studio. So I'll be using employee table because we have a lot of null values in those. I'll execute this. So let's take the count of the salary column. Select count. I have to write the column name, employee. So if I'll execute, I'll get 3 results. But if I'll execute star, I'll get 9 columns. So even we can use the distinct operation here in the count function. So count basically fetch the count of rows from a table. So let's move to another aggregate function. We have max. So max is exactly opposite of min. We have already shown example of minimum. So max, we can use it for numeric as well as with the character data type. If we use for the character data type, it will show the maximum value in the sorting order. If we use with the numeric, then of course it will show the maximum of the value. Though let's see an example of max as well. So if I'll use max, we're trying to find the maximum salary from employee table. So this is the maximum salary. And if I'll try to find the location, let me first show you the various location from the department table. So as per the sorting order, we should get Hyderabad if we'll use max for this column. So let me write the query. Select max LOC from department table. And we can provide an alias as location. So I'll get Hyderabad in my result set. So we have discussed all aggregate functions. So the common aggregate functions are average. If you get the average of values, min, as the name suggests, the minimum value in the expression. Sum helps us in finding of the total for a column. Sum only accepts the numeric value. Count returns the number of items or rows in a group or in a table. Max returns the maximum value in the expression. So let's move to other category of functions. So these are the various examples. Before we move to other functions, let's see the examples here. So in one example, they've shown all the aggregate functions. So we can use multiple aggregate functions in the single statement, a single select statement. So in the single select statement, we have used average of salary, minimum of salary, maximum of salary, and the sum of salary from employee table. Second example is for the count functions. So we will discuss about the group functions and heavy functions once we are done with most of the out-of-box functions. Then we have string functions. String functions are again scalar functions, and they perform an operations on a string input value, and they return a string or numeric value based upon the type of functions which we are using. When string functions are passed arguments that are not string values, the input type is implicitly converted to a text data type. So these are the various string functions. Ltrim, it basically returns a character expressions after it removes leading blanks. It basically removes the blanks from the left hand side of the string. We have rtrim, it returns the character string after truncating all the trailing blanks. Basically it removes the blank from the right hand side of our string. Char functions converts an int ASCII code to a character. Character index find out and searches an expressions for another expressions and returns its starting positions if found. str returns character data converted from numeric data. Concat return a string that is results of concatenating 2 or more string values. So these functions are almost similar to other string functions which we use in other programming languages. So in most of the programming languages, we have trim functions, we have functions to find out the index of a character. We use concatenate operation. This is a very common string functions to concatenate two strings or more than two strings. Then we have replace functions. So replace all occurrence of a specified string value with another specific value. We have substring, it returns part of a character or text based upon the length or the start index which we give in. As we can see in the syntax of the substring, we have a substring keyword followed by the expression, like the string from which we want to find out the part of a character. We'll define the start index and then we'll define the length, that from start index till how many characters we want to fetch the substring. Then we have the format functions. We can format strings into desired format using the culture. Then we have left functions. It returns the left part of a character string. The opposite of left is the right functions, which returns the right part of a character string. Reverse, return the reverse order of a string value. Upper functions converts the string into uppercase, opposite of which is the lower functions, which converts the expressions into lowercase. And in the end, we have length function or len, which basically returns the number of characters of the specified string and exclude the trailing blanks. So these are the various examples on our slide. So first one is for the replace function. So this is our string. And this is string, we are replacing CDE with XXX as the replace. So as you can see in the result set here for the replace column, the value CDE is replaced with XXX. We have substring functions. In the substring, we are get out of this ABCDEF, which is our main string, from index 2 and till length 3, we are getting the substring. So index 2 is start from B, and then up to 3 character we'll get the substring. So we'll get B, C and D in our output. Then we have left, so it basically return the left from a character index. So from index 2 we are getting the values from the left, so it is A and B. From the right we are getting the value of B, C, D. So in the end we have the examples of date and time and format. So here we have provided the various culture values. So first is for US English, second is for British English, and third is for the German. So based upon the info culture, we basically get the different results here. So most of the string functions are pretty much straightforward. So let's discuss about a few of them. So we'll discuss about a reverse. So I'm adding a string A, B, C. Again, I forgot to add the select statement. This will give me an error if I'll try to execute this statement without select. And if I'll execute it now, I'll get the reverse of the string. Always good to provide the alias. Then we have trim or 𝐿trim. Select 𝐿trim. So I have added leading blank spaces in this string, and if I'll execute this, the leading spaces has been trimmed. Same way I can use 𝑟trim. So if I'll use 𝑟trim, then only the trailing spaces will be removed, not the leading one. If I'll execute this, I'll get this result. And if I'll use trim, then it will consider for both. So we do not have trim here. So 𝐿trim removes the leading spaces and 𝑟trim removes the trailing spaces. So this is all about the string functions. You can practice about the other string functions. They are pretty much straightforward. Let's see an example for the upper and lower functions as well. So if I use lower here, I'll get the same result. But if I'll use, or let me convert, let me first write the uppercase character, so it's convert into lowercase. And if I'll write the lowercase, and if I'll use the upper function, it convert it into uppercase. So all other string functions are also self-explanatory. Please try all of them so that you will have an idea. And if you try all of these, you will come to know that if the situations arise, you can start using those. So let's move to other functions, the date and time functions. So date and time functions are again scalar functions that performs an operations on a date and time input value and returns either a string, numeric, or date and time value. So as you can see on the screen, there are various date and time functions. Again, we have sys date time. It returns a date time value that contains the date and time, its current timestamp. Again, return a date time value that contains the date and time. Date part basically fetch as the date part of a date component. Day, month, year returns an integer that represents the day, month, and year part of the specific date. Date if returns the number of date or time date part boundaries that are crossed between two specific dates. And date functions returns a new date time values by adding an interval to the specific date part. So let's see the examples of date and time functions. Sys date time, it returns the system date time, so it has date component as well as the time component. Current timestamp also gives the current date and time. Date part basically provides, if you'll provide year here, then it is providing the year of the date part. If I'll provide here the dd, it will provide the day. If I'll provide it will provide or fetch the value of the month. Date difference, so again, if we are providing so we are getting the difference of month between these two dates. If I'll provide dd, then it will provide me the difference of days between the two dates. So date add is that I am adding 2 months. So this is how we have to do. Since we have provided specify for month here. If I'll provide the dd, then it will add 2 days. Since we have provided here, so it will add 2 months to the current date. So let's see one example here. Date part, year. Now let's say and then we can provide the date. Is providing the month. So 12th month, since I'm using December. If I'll change it to October, and if I'll execute again, it will show me that value 10. So this is how we use the date part. And let's see the datehead function. So if I execute it now, it will add 2 months. I can also provide dd here. So it will add 2 days. So this is all about the date functions. So now let's discuss about the group by clause and having clause. So as you can see, we are using group by keyword here, and we are using having keyword here. So let's discuss about the group by and having clause. Let's discuss group by first. The SQL group by clause is used along with the group functions to retrieve data grouped according to one or more columns. The important part here is that the group by clause should contain all the columns in the select list except those used along with the group functions. So let's see an example of group by functions for better understanding. Let's move to Management Studio, and we will use department 1 table for group by clause. Let me first execute this query. So what I'm going to do, I'm going to group by the department number. So I'll find select count of rows from department 1. Then I'll use group by keyword, and I want to group the data by department number. So can you see? It's grouped. Or even I can write the department number. And let me write the alias for this. And I'm writing the alias here as department number. If I'll execute this, I'll get, so we have count 4 for the department number, There are 4 values for the department number 20, same way 5 values for department number 30, 5 values for 40, 1 values for department number 50, and 1 value for department number 80. So we use group by functions generally in association with aggregate functions. So it helps us in grouping the data in a table. The important part here is that we have to use all the columns in the group by which are there in the select statement. So if I'll try to include location here, there's one more column, locations, in the department 1 table. But if I'll try to execute it now, I'll get an error because all the columns other than the aggregate functions should be there in the group by clause. So if I'll include the other table as well, then the query will be executed successfully. So in order to execute group by successfully, we have to include all the columns which we are including in the select statement in the group by clause. And also we can include multiple columns in the group by clause. It is not that we have to use only the single column. So group by helps us to group the data in a single table, and it is generally used along with other aggregate functions. So let's see the example. So here we are basically again grouping by the department number here. So let me fetch the results from the employee table. So here we can group the records again using the department number or using the job ID. So if I were to use for the employee table, I'll write select job ID, job underscore ID, and then again I can use, for example, let's say count. It's not that we have to always use the count aggregate function. We can use other aggregate functions also from employee, and then I'll write group by job ID. So this will group the data according to the job. So only for a job ID 7 we have 2 rows. For all other job IDs we have a single row. So we are clear with the group by. Now let's discuss the having keyword. So the having clause was added to SQL because the where keyword could not be used with the aggregate function. We cannot use a where keyword with this aggregate function. So having applies to the summarized group records, whereas where applies to the individual records. So if it is a summarized record or the group, when we use group by, then we have to use having, and if it is the individual records, then we'll use the where clause. So if we'll use the having clause, only the groups that meets the having criteria will be returned in the result sets. And having keyword requires that we'll use group by in our SQL query. So we can say that the having clause is used in combination with the group by clause to restrict the group of return rows to only those which is matching the conditions or where the conditions is true. So let's see an example. So here in this example, we are selecting the department number, taking the average salary, minimum salary, and the maximum salary. And we are finding that if the sum of the salary is greater than 3,000, fetches only those results. So let's see this example in the management studio. And I can write here having salary greater than, let's say, 30,000. Oh, we have to include the minimum salary. We have to use the aggregate functions in the having clause. Yeah, so we get only 2 results. So let me first show you the result sets. So we have 3 rows which are having the value for the salary column. J4 having salary of 40,000, J5 is blank, so we have J6 as 500,000, and then we have J1 as 30K. So as per our query, we should get only the 2 results, that is J4 and J6 because these are the only two rows which are satisfying the having clause. So having is kind of we used to filter the result sets, but with the aggregate functions we cannot use where command, so we are supposed to use having clause. So this is it about the various out-of-box SQL functions. And first we'll discuss about the stored procedure. A stored procedure is a set of SQL statements with a name that has been created and stored in the database. So when we execute or when we write SQL statement, but we are not storing those queries. But in stored procedure, we can write a set of SQL statements and we can, execute them and they can store in the server. So every time I don't have to write SQL queries, I can write my business logic in the stored procedure. So stored procedures can be defined as a set of logical group of SQL statements which are grouped to perform a specific task. So basically in stored procedure, we write most of our business logic. So like other programming languages, stored procedures accepts input parameters. They return multiple values by means of out parameters or output parameters. They contain programming statements. A stored procedure can call other stored procedures or functions. A return status to indicate success or failure. Let's see the syntax of stored procedure first. So this is the syntax. We have create keyword to create a stored procedure. So we have to write create followed by a keyword procedure, name of the stored procedure which we want to create. If you want to provide any parameter in the stored procedure, then we'll provide the parameter name. If we want to create the parameter as an output parameter, then we have to use the keyword out or output followed by as keyword, and we'll write begin, and whatever the statement or computations we want, we'll write that, and in the end we have to write end keyword. So in the syntax it is mentioned that it is create or alter. So if we want to modify the existing stored procedure, then we have to use the keyword alter. If we are creating the stored procedure first time, then we have to use the keyword create. So alter keyword is used if you want to modify any existing stored procedure. Now why we create stored procedure when we can write SQL queries? So here are some of the benefits of creating stored procedure. All commands in a stored procedure are executed as a single batch of code. When we execute queries in SQL, generally each query goes as a single batch. But when we execute stored procedure, though it may have multiple SQL statements, all the SQL statements are executed as a single batch of code. So by doing this, it reduces the server or client network traffic and improves the performance. Stored procedures helps us in achieving strong security in SQL because we can impersonate another user. Execute as can be specified to enable impersonating another user to perform certain database tasks without providing direct permissions to the processor. So it makes our environment more secure. Reuse of code. Stored procedures helps us in achieving reusability because as we discussed in the previous slides, that we can call another functions or stored procedures from one stored procedure. Easier maintenance. Changes need to be done within the stored procedure which handles all DB operations, and no changes are required in client applications. So sometimes we move our business logic to the stored procedure. So if any changes are required, we need to modify our business logic, then we don't have to change our client applications or our code. We have to just modify the stored procedures and execute it again. Also, if there is any error, we know where exactly to look for, and we have to debug only one stored procedure instead of looking for multiple SQL statements. That is the reason stored procedures are easier to maintain. Improved performance. All procedures by default are compiled in the database the first time it is executed, and it maintains the execution plan for subsequent call. So if we'll execute or if we'll call or run the stored procedure again, it will take less time because it is already compiled in the database the very first time. So by doing this, the performance of applications has increased. So on this slide, we can see an example of stored procedure. So we are creating a stored procedure. So we are writing first the create keyword followed by the procedure. sp underscore get employee info is the name of the stored procedure. This stored procedure, we are passing a parameter employee ID whose data type is int, followed by the basic syntax. We are defining the keyword as and begin, and then we are writing the basic query that select employee ID, first name, last name, manager ID, phone number, hire date, job ID. These are the columns of table employee. And then we are passing the condition. We are filtering the records from employee table by using a where clause. And in the where clause, we are not hard coding any value. We are equating it with an employee ID, which is the parameter. So when we will execute this stored procedure, we will pass the parameter. So let's see a few examples of the stored procedure. So let me open Management Studio. So let me open the examples I already have. So let's create a stored procedure without parameter first. It is not that every time when we'll create a stored procedure, we have to define a parameter. So I'm writing a create keyword followed by the procedure, and all result keyword will be highlighted in the blue color. Then I'm providing a name of the stored procedure. So I can provide any name here. So I'm providing get details, or I can mention it to give it more meaning, get department details. And the stored procedure, I have simply written one select query that selects star from department, and I'll execute this query. Command completed successfully means we have successfully created the stored procedure in database. Now where to check for the stored procedure? So I'll first expand the database under which I'm creating the stored procedure. An important thing, guys, is that we have to use the database first, that under which database we want to create our stored procedure. So always write the name of the database, use keyword followed by a go keyword. Now if we'll try to execute this statement again, I'll get an error that this is already an object name USP get department details in the database. So since I've already created this stored procedure, if I'll try to create it again, it will give an error. So when you provide a name of the stored procedure, please ensure or please check that the name which you are providing is unique and it does not exist in the database in which you are creating that stored procedure. So if I want to check where exactly the stored procedure has been created, I have to expand the programmability folder. Under programmability folder, we have a separate folder for the stored procedures. Let me refresh it. So here we can see the stored procedure, DBO USP get department details. So from this object explorer, I can modify the stored procedure, I can execute the stored procedure, or even I can delete it. So to delete it, we have to simply click delete here. It will again reconfirm whether we actually want to delete this stored procedure, and if there are any dependency of this stored procedure, we can check it with the show dependency. So when we delete something from our database, it is better to check the dependency. If there are any dependency, we rather not delete that particular object. So as of now, we know that there's no dependency, so I'm just clicking OK here, and it will delete the stored procedure. Since we have deleted the stored procedure, and now if I'll execute this statement again, it will be executed successfully as there was no stored procedure in our database, and by execution of the statement we'll again create that stored procedure. So if I'll refresh this stored procedure again, I'll see the stored procedure. Now we have created the stored procedure, and we'll see how we can execute this stored procedure. To execute this stored procedure, we have to write one command. So there are various keywords which we can use to run this stored procedure. The first one is we have to write this keyword exec followed by the name of the stored procedure. So if I'll execute this, it will execute the stored procedure and it will return this query or this result set, because in the stored procedure we have given only one select statement that selects star from department, and the department table has 3 columns. So we are getting all the rows because we have not specified any where condition. So this is an example of a stored procedure without a parameter. Since this stored procedure doesn't have any parameter. We are not passing any parameter while executing this store procedure. So it is not mandatory to provide the exec keyword while executing the store procedure. Even if you'll provide the name of the store procedure and if you'll execute it, it will fetch the same results. So exec keyword or execute keyword is optional while executing the store procedure. So let me again delete this store procedure. So while creating the store procedure again, we can either provide the create procedure or we can even provide the short form that create proc. Even if I'll execute the statement, it will be executed successfully. And if I'll refresh this node, we can see the store procedure has been created successfully. While executing, again, it is optional to provide the execute keyword. Similarly, while creating the store procedure, we can either provide create proc or create procedure. Now let's see how we can create a store procedure with a parameter. So I'm opening a new query window. I increase the font size for better visibility. So this is an example of a store procedure with a parameter. So here we are providing the parameter department number. So here we have department number as a parameter, and the data type of this parameter is n_var_char and length is 30. So in the previous example, we have written a select statement but without the where clause. Here I'm providing or I'm filtering the record or rows by using where clause, and the where clause I'm checking the depart number with the parameter which will pass while executing the store procedure. So let me create the store procedure first and then we will execute it. The command completed successfully means the store procedure has been created successfully. So let's again refresh this node. Yeah. So now when we are executing this store procedure, even like as we saw that we can provide the execute keyword or we can even directly write the name of the store procedure, or if you are using the management studio, we can right click the store procedure and then we can click execute store procedure. So the execute store procedure will open this window, and if there are any parameter, it will check whether what value we want to pass to this particular parameter. As we know that we have various values of department number start from 10 to 80. So I'm passing 20 as a value for the department number and I will click OK. The moment I'll click OK, I'll get this result. So in earlier example, we got all the rows in the result set. So if we do not want to execute this store procedure from the object explorer, then again we have to write the same command. We have to execute keywords followed by the name of the store procedure, and then we'll pass the parameter. In our case, the parameter is department number. So now this will give the desired result. So this is how we create store procedure with parameter, and this is how we execute the store procedure which has a parameter in it. Now if we'll try to execute this store procedure without providing the parameter, now let's see what happens. See, you will receive an error. The procedure or function USB get detail expect parameters which was not supplied. It means when we created the store procedure, we have ensured that the parameter which we are providing in our store procedure is mandatory. Why? Because we have not explicitly defined that this parameter can accept null value as well. So if you want to make the parameter null, then we have to explicitly provide the null keyword. So let me modify this store procedure, or let me first delete this store procedure and we'll recreate it again. So I'm just deleting the store procedure. And in order to make our parameter optional instead of mandatory, we have to provide the keyword null. And I'll execute the statement again to create the store procedure. Now if I'll execute this store procedure, we won't receive an error, but we won't get the value because we are checking the null value, and if I not provide any null, so it will not return any result. But yes, the error is gone. So this is how we make the parameter optional by providing the null keyword. Now let's see how we can create a stored procedure with multiple parameters. Or is it possible to create a stored procedure with multiple parameters? Yes, it is very much possible to create a stored procedure which accepts multiple parameters. So let's see it with an example. Let me open a new query again. And we already have an example handy with us. Let me paste it in Management Studio. So we have this stored procedure, and here in this stored procedure we have defined two parameters. One is department number and department name. We have make both of these parameters as optional by providing the null keyword. So if we want to create or we want to define multiple parameters in the stored procedure, all we have to do is that we have to separate the two parameters with a comma. That's it. Rest everything is same. We have to provide an as keyword after the parameters, and then we'll write the stored procedure body. In here we are again writing a select statement, but we are adding a where clause to filter the result sets by providing two conditions, and we are using logical operator, that is AND, to combine two conditions. So let me execute these statements to create a new stored procedure with multiple parameters. The stored procedure has been created successfully. We'll refresh this node, and this is the stored procedure. So let me first see the data in our table so that we can provide the right parameters values to get the values in the result set. Okay, so I'll pass the parameter department number as 50 and department name as IT. So all I have to do is I have to provide the keyword execute, name of the stored procedure, get details from, then we have to provide the value for first parameter, that is department number, its value. So we have decided to pass its value as a 50, and then we'll provide the value for another parameter. Since it is string, we have to include it is in single quotation. And now I'll execute this, and we'll get the desired result that department name is IT and is located in Mumbai. So this is how we'll execute and the stored procedure with multiple parameters. So we write the name of the stored procedure and followed by the first parameter, then write a comma, and then the second parameter, and so on. Parameters also in other stored procedure. If you want to execute it from the Object Explorer, then you have to right click the stored procedure and click execute stored procedure. We'll get both the names. We'll pass the value here and we'll click OK. If I'll click it OK now, though there won't be any result in the result set, but it won't throw any error because while creating the stored procedure, we have defined that these two parameters can accept null value. So they are not mandatory, these are optional. That is the reason, even though we won't provide any value, we won't receive one while executing the stored procedure. Now let's discuss about the output parameter in the stored procedure. So if we want to return the value of the parameter, then we have to define an extra keyword, that is out or output. Both keywords are valid whether we use out or output against the name of the parameter whose value we want to return. So let's see it with an example. So I'll open a new query. In this stored procedure, I have two parameters. One is the department number and one is count. So we have defined a keyword output which suggests that this parameter will be the output parameter. So we can pass the value to this parameter, and this parameter will also return the value after execution. So we can provide the keyword output or out. There's no difference. The end result will be the same. Stored is created. We'll refresh the node of the stored procedure to see the results. Yep, we have the stored procedure. Now in order to execute this, we have to do like this. We have to first declare the count int, followed by the executive name of the stored procedure. Will provide the value. This is how we have to define if it is an output parameter. And then we are writing the select statement to see the value of the count. So let me execute this. So the count is 1 because there's only one row with the department number 10. So this is how we use the output or out keyword against the parameter. Now let's see how we can add comments in the store process. So we can add the comments in two ways. One is the line comment and one is block comments. So if we need to provide the line comments, then we have to use 2 dash followed by a statement. And in order to / and then star, I'm just writing this is multi-parameter stored processor having output parameter. Again, we'll write star and a /. So this is how we define the comments in a stored processor. Not only in the stored processor, we can write or define the comments anywhere in SQL queries, whether it is a functions or normal SQL statements or it is a stored processor. So line comments or single line we use 2 dash, and for block comments we use / and star. So let's see how we can handle the exception in the stored processors. So if you have handled the exceptions in your programming languages like C, C++ or like Java or C#, then we use try catch there. And along with try catch, sometimes we use finally block because finally always execute. So if you want to close some, like we want to close some connections, or we want that some statement to execute no matter whether there's exception or not, then we write those statements in the final block. So we do not have any final block in the stored processor or SQL. We have, let's see how we can define the try and catch blocks in stored processor with an example. Let me first increase the font size. I'm creating this store processor with the name DBO USP try catch test. And to write a catch block, we have to provide the syntax begin try. Then in the body, we'll write whatever the statement we want to write, and then followed by the end try. So end try basically ends the try block. After that, we'll provide begin catch, and in the catch, see what we are doing here is that we have written a select statement that we are providing what is the error number, what is the severity of this error, what is the state, procedure, in which line the error is encountered, and the error message. So let's create the store processor first, and then we'll refresh this node. So we have this store processor, and now this store processor do not have any parameter. So I'll execute the store processor, execute keyword followed by the name of the store processor. No parameters, so we are not passing any parameters while executing it. And see, since we are dividing by 0, it will give an error. It will result in infinity. And see, since it will go to the catch block, since error has encountered, so we have written the statement in the try block. So in the catch, we are handling the exception. And while handling the exception, we have written a select statement which provide all these values. So the error number is at 134, error severity is 16. So these are the predefined severity levels. So we can check on Google said what the severity error severity 16 means. Then we have error state, in which processor the error has occurred. So it will give you the name of the processor. The name of the processor is USP try catch test. Error line is 4, and the error message that we are dividing by 0. So we'll get the message that divide by 0 error encountered. So this is how we mentioned try catch block in the store processor. We have seen various examples of the store processor. So we have created the store processor without parameter, with parameter. We have created a store processor with multiple parameters. We have seen that how we can include comments in the store processor using single line comments or block comments. And we have seen that how we can handle the exception in the store processor. So this exception handling is not only for the store processor, we can handle these exceptions in functions as well. So we can write try block and followed by a catch block. In the catch block, again, we can write the select statement to show the message that where exactly what is the severity level, what is the error message. We can even provide the custom error message, it's up to us. So let's move to the next topic. So I hope you are clear with the concept of stored procedure in SQL. Let's move to the next topic. The next topic is user-defined functions. So though SQL Server provides list of many predefined functions that are built into the SQL language, these supplied or out-of-box functions helps in extending the capabilities of SQL by providing the ability to perform like string manipulations, mathematical calculations, data type conversions by using convert or cast functions, etc. But sometimes these out-of-box functions or inbuilt functions are not enough, and there are certain functionalities which is not provided by these functions. So this issue can be easily addressed if we can create some user-defined function. So like functions in programming language, in all programming language we write functions. There are some functions which do not return any values. There are functions which returns a value, and we pass parameters. We do not pass parameters while calling the functions. So user-defined functions in SQL are almost on the same lines of the functions in other programming languages. So user-defined functions are compact piece of transact SQL code which can accept parameters, like how we pass the parameters in stored process. Same way, functions can also accept parameters. Functions can perform complex calculations and return either a value or a table. So this return type is basically based upon what kind of functions we are creating or executing. So let's discuss what are the various benefits of user-defined functions. So again, like stored procedure, functions also helps us in achieving the concept of reusability. It will prevent us from writing same logic multiple times. We can dump a set of SQL statement in a function and we can call it as many as times. Like stored procedure, they also improve the performance because the user-defined function reduce the compilation time of SQL query by caching the execution plan and reusing it. Functions are also easier to maintain because functions help us to separate the complex calculations or the complex business logic from the regular SQL query so that we can understand and debug the query quicker and better. It again reduces the network traffic because of its caching plan. Functions again can be used in where clause as well. By this, we can limit the number of rows sent to the client. So we can use functions in select clause and we can use the functions in where clause. Now let's discuss about the structure of the functions. User-defined functions are composed of two parts. One is header and one is function body. We'll see in some examples that how we create functions. So the header contains the function name, input parameters, if there are any input parameters, because again the parameters are optional, whether it is a stored procedure or whether it is a user-defined function. Along with parameter, we have written parameter info, its name and type in the header section. The function body contains the logic, any business logic. So it contains one or many SQL statement depending upon what we are writing in the function body. As you can see on the screen, there are, if you need to divide the user-defined functions in some broad category, then we can divide into two broad categories. One is the scalar value functions and one is the table valued function. The table value function can again be divided into inline table value functions and multi-statement table valued functions. Let's move to the next slide. Let's first discuss about what are the scalar functions in SQL. Scalar functions returns a single data value of the type defined in the return clause. If it is an inline scalar function, we even don't need a function body. We use scalar functions when multi statements need to be provided within begin or end block. So let's discuss about the syntax. As I mentioned that the syntax contains header and body. So the create alter function, which is basically the header of the functions. In the header, we can define the parameters, the return type parameters, and then in the begin and end, we define the function body. What are the SQL statement or any computations or any calculation which we are doing, you basically do it in the body of the function. So if we need to summarize, the scalar functions are functions which returns a single value. They return scalar values or single values that can be used anywhere a constant expression can be used. And every function, whether it is a scalar or whether it is like table value functions, every function must return a result using the return statement. This is kind of mandatory. So let's see some examples of the scalar functions. So in this example, we are creating a function with the name fn_get_department_number. So we are creating a parameter employee ID of the data type int here. This function basically returns a int data type. Then there's a begin keyword. After begin keyword, we are defining the body. In the body, we are writing select department number from employee, where employee ID is employee ID, where @employee ID is the parameter which will pass when we'll execute this function or will run this function. So in the right hand side, we are executing these functions, and we are executing these functions in the where clause. Just pay attention. So in the where clause, we are mentioning where department number equals to, and then we are calling the function by providing the parameter. So when this function will execute, it will be replaced by the value which the function will return, and then that value will be used in the where clause to filter the data. So let's discuss some examples of functions for better clarity. Let me open Management Studio. Let me close these queries first. So we'll first create a function, a scalar function without any parameters. So this is the name of the function, no parameters. We are not creating any parameters here. The return type is int, and I'm just returning in the return statement. We have just provided a SQL statement that selects some salary from employee. After executing this, function will be created. This is a scalar function. So if you want to verify whether the function has been created successfully, then we have to refresh our database. So we have created this function in employee DB database. I'll refresh that, and I'll expand the programmability. In programmability node, we have subnode called functions. Again, in functions, we have 4 nodes: table value functions, scalar value functions, aggregate functions, and system functions. If I'll expand the scalar value functions, we can see the name of the functions here. So in order to execute this function, we have to write select statement followed by the name of the function. If I'll execute, we have provided the parenthesis. So this function will return the sum of the salary from employee table. So let me show you the data which is there in the employee table, so that we can verify our result, whether I got the right result or not. So if we'll calculate this, we'll get 570K. This is the sum of the salary for all the employees, since we have salary for the 3 employees only. So this is how we'll create the functions without any parameter. Let's see how we can create a functions with parameter. So in this function, we are providing 2 parameters, first name, and the data type of the parameter is varchar50. The second parameter is the last name, and the data type of second parameter is again varchar with the same length as of the first parameter. Return type is also of the same data type, and then in the body we are executing the SQL statement. So what we are doing, we are just concatenating. So if it is a mathematical operations, if we provide the plus operator, then it will add the 2 values, but if it is string or varchar, then it will concatenate the string. Space is a function it is an inbuilt function in SQL which basically add a space, empty space. So what we are doing, we are concatenating first name and last name, and we are adding a space between the 2 names to make it more readable. So as you can see, when I hovering over the space keyword, it is giving me a message that this is a built-in function. So let me create this function first. Function has been created. Again, this is a scalar function but with parameters. Let me refresh the scalar valued function node, and I can see the function name. Let me execute this function, name of the function, and then we have to pass the parameters. So I pass two parameters here, comma, and the name of the second parameter. Why I'm enclosing it in single quote? Because this is a string type, and if you want to add an alias for the column name, we can mention it as full name. So if I'll execute it again, we'll get the result Joe root here. So this is how we'll create functions with multiple parameters, and we can call the functions in the select statement, or we can we call in the select statement, right? And we can even call the functions in where clause, as we saw in the example in the PPT. Again, in the previous example, let me first increase the font size. We can even use the functions in the where clause. So how we can use it? Let's assume I'm calling this query select star from employee, and let me first alter this function. So to alter this function, we have to use the alter keyword, and instead of sum, I'm just finding the average salary of the employee, and I'm executing again. So this is how we modify the function, existing function. Same way we can modify the store procedure also. So alter is the keyword which helps us to modifying the existing functions as well as existing stored procedure. If I have to use the functions in the where clause, so this is how we'll do. Let me show you. So I'm writing a query. So what I want to do is that I want to select the employees whose salary is greater than the average salary. So I'll write where clause where salary is greater than, then I'll call the function. So if I execute it now, I'll get only one result because there's only one record of one employee whose salary is greater than the average salary of all the employees. So this is how we can include, or we can call the function in where clause as well as in the select statement as per our business requirement. So let's move to the next topic. So we are clear with the scalar functions, I believe. So let's move to the next type of function, that is the table valued functions. And as I mentioned earlier, we have two types of table valued function. One is inline, one is multi-valued. So inline table value functions are a subset of user defined function that returns a table. So scalar functions returns only single value, whereas the inline table value functions returns the entire table. So inline functions, if you remember, we have created view in a first module. So we can use inline functions if you want to achieve the functionality of parameterized view. Inline table value function can also be used to support parameters in search condition specified in the where clause. So these are some of the rules which are common for the inline table valued functions. The return clause contains only the keyword table. Format need not to be defined for the return value. There is no function body delimited by begin and end. The return clause contains a single select statement in parentheses, and the table valued function accepts only constants or the local variable arguments. This is the syntax for the inline table value functions, as you can see in the slide. So the return type is table here, and we generally have the SQL statement. This is an example. In the last slide we saw the syntax. So here in this example we are creating a function for, we are passing the parameter, and it is returned as a table, not as a single value. We are providing the select statement where we are returning the values of employee table, and we are filtering the result sends by parameter employee ID. So if you remember, when we executed the scalar value function, we did not use select star, mention select and the name of the function. But if we are using table value function, we are using the select star from, because we are kind of, as you mentioned, we kind of use it for parameterized view. So if you need to fetch the values from views, then again we use select star from the name of the view. So let's see an example of inline table value function. Let me open Management Studio. So this is example of inline functions with no parameter. We can create parameter in the same way we created the parameter or we define the parameters for the scalar value functions. Function top 10 customers. We are returning a table, and in the return statement, I'm just writing a select statement, select top 10 from employee. Let me execute this to create this function. Now I'll execute this function. For this, I have to mention the select clause, select star from, and then the name of the function. So I'm getting, so there are only 9 rows, so it's just fetching the 9 only. So if I can go ahead and modify it, instead of top 10, let me modify it to top 5. So to modify the function, we have to use the alter keyword. So we got the top 5 results. This is how we create the inline table valued function. So this is example of the functions without any parameters. If required, we can go ahead and create the parameter as well. So to create the parameter, we have to define the parameter name here, and then we have to provide the name of, data type of a parameter, and then we can write a where clause. Now let's say where employee ID is greater than employee ID. Command executed successfully, and now if I to run this, I'll pass a value to the function. If I'll execute, it will get the values in the result set whose employee ID is greater than 1003. I hope this is clear, and let's move to the next topic. So we'll discuss the next category of table valued function, that is the multi-statement. So in the inline function, we can use a single statement, but in multi-statement table valued function, we can use multiple statements. So again, they also return a table data type. So the return clause defines the format of the table. We cannot provide the format in the inline table valued function, but yes, we can provide the format of the table in multi-statement table valued function. The transact SQL statement in the function body build and insert rows into the return variable defined by the return clause. And the rows inserted into the variable are returned as the tabular output of the function. So here we have the syntax for this. To modify, we use alter keywords. To create, we use create keywords, name of the function. If you wish, we can define the parameters which you can consume in the function body. Return type will always be the table, but here we can define the format which is not available in the inline table valued function. Let's see an example. So this is an example here. So we are defining the format of the table, and we are defining that the table will be the retired get employee info, and we are providing 4 columns here, and we are defining the data type, we are defining the constant on the table, we are defining whether there's a null constant or not on those columns. And in the function body, we are inserting records in the table, and we'll fetching from the employee, and we are filtering the result set by using the parameter which will pass when we'll execute the function. So let's see one more example other than this. So you can use the same example and execute it. We'll try to write the entire thing, then it will take time. So I'm skipping the example in Management Studio. But the basic difference between these two functions, table valued function, is that here we can format the table and we can use multiple statement in the function body, which is not the options in the inline functions. So we already discussed the benefits of user-defined functions, modular programming. It saves time because we can write or dump the statements in a function and use it or call it as many as number of times. It's faster executions because of this. It caches the execution plan and use it for the subsequent calls, and it reduces the network traffic. So these are few of the main benefits of user-defined functions.
What is normalization? Database normalization is a technique of organizing the data in the database. It is a systematic approach of decomposing tables to eliminate data redundancy. It is a multi-step process that puts data into tabular form, removing the duplicated data from its relational tables. On the screen, we just saw that the table is getting decomposed into 2 smaller tables. Is it really necessary to normalize the table that is present on the database? Well, every table in the database has to be in the normal form. So normalization is used mainly for two purposes. So the first one is it is used to eliminate repeated data. Having repeated data in the system not only makes the process slow but will cause trouble during the later part of transactions. And the second one is to ensure the data dependencies make some logical sense. Yes, usually the data is stored in database with certain logic. Huge data sets without any purpose are completely waste. It's like having an abundant resource without any application. The data that we have should make some logical sense. Normalization came into existence because of the problems that occurred on data. Now, let's look at those problems. And these are known as data anomalies. If a table is not properly normalized and has data redundancy, then it will not only eat up the extra memory space, but will also make it difficult to handle and update the database. Let's look at the first anomaly, that is insertion anomaly. Suppose for a new position in a company, Mr. Rakshit is selected, but the department has not been allotted for him. In that case, if we want to update his information to the database, we need to set the department information as null. Similarly, if we have to insert data of 1,000 employees who are in similar situation, then the department information will be repeated for all those 1,000 employees. This scenario is a classical example of insertion anomalies. The next one is update anomaly. What if Mr. Rakshit leaves the company or is no longer the head of the marketing department? In that case, all the employee records will have to be updated. And if by mistake we miss any record, it will lead to data inconsistency. This is nothing but updation anomaly. And the final one is deletion anomaly. In our employee table, two different pieces of information are kept together. That is, employee information and department information. Hence, at the end of financial year, if employee records are deleted, we will also lose the department information. This is nothing but deletion anomaly. So these were some of the problems that occurred while managing the data. To eliminate all these anomalies, normalization came into existence. There are many normal forms which are still under development, but let's focus on the very basic and the essential ones only. So we will be talking about first normal form, second normal form, third normal form, and finally end this session with voice code normal form. So without wasting further time, let's proceed to first normal form. In first normal form, we tackle the problem of atomicity. Here, atomicity means values in the table should not be further divided. In simple terms, a single cell cannot hold multiple values. If a table contains a composite or multi-valued attributes, it violates the first normal form. So the following functions will be performed in first normal form. The first one is it removes repeating groups from the table. And next, it creates a separate table for each set of related data. And finally, it identifies each set of related data with a primary key. To understand this in a better way, let's look at the given table. In the employee table, we have employee ID, employee name, phone number, and salary as columns. We can clearly see that the phone number column has two values. Thus, it violates the first normal form. Now, if we apply the first normal form to the above table, we get the following result. In this table, each and every row is distinct. That is, no cell has multiple values. The table has achieved atomicity. First normal form is simple and can be easily identified. In the table, we can clearly see there is no multiple values in each and every column. Thus, the first normal form is achieved. Now, let's move to second normal form. Second normal form was originally defined by E.F. Codd in 1971. A table is said to be in second normal form only when it fulfills the following condition. The first condition is it has to be in first normal form. And the second one is the table also should not contain partial dependency. Here, partial dependency means the proper subset of a candidate key determines a non-prime attribute. So what is a non-prime attribute? Let's understand this in a simple way. Attributes that form a candidate key in a table are called prime attributes, and the rest of the attributes of the relation are non-prime. For a table, prime attributes can be like employee ID and department ID, and the non-prime attributes can be like office location. To understand second normal form, let's consider this table. This table has a composite primary key. That is, employee ID and department ID makes the primary key. The non-key attribute is office location. In this case, office location only depends on department ID, which is only the part of primary key. Therefore, this table does not satisfy the second normal form. So what to do in such scenario? The answer is simple. Split the table accordingly. To bring this table to second normal form, we need to break the table into two parts, which will give the following tables. The first table has employee ID and department ID as columns. The second one has department ID and office location as columns. As you can see, we have removed the partial functional dependency that we initially had. Now in the table, the column office location is fully dependent on the primary key of that table, which is nothing but department ID. I hope you have understood second normal form. Now that we have learned first normal form and second normal form, let's head to the next part of this normalization. Next topic is third normal form. Third normal form is a normal form that is used in normalizing the table to reduce the duplication of data and ensure referential integrity. The following condition has to be met by the table to be in third normal form. And the first condition is the table has to be in second normal form. And the second condition is no non-prime attribute is transitively dependent on any non-prime attribute which depends on other non-prime attributes. I know it's a bit confusing, so let me make it simple for you. It's like if C is dependent on B and in turn B is dependent on A, then transitively C is dependent on A. This should not happen in third normal form. All the non-prime attributes must depend only on the prime attributes. So these are the two necessary conditions that needs to be attained. So why was third normal form designed? Firstly, to eliminate undesirable data anomalies. The next one is to reduce the need for restructuring over time. And finally, to make the data model more informative. Since we have understood the third normal form, let's look at the example table. In the above table, student ID determines subject ID and subject ID determines subject. Therefore, student ID determines subject via subject ID. This implies that we have transitive functional dependency. And this table does not satisfy the third normal form. Now, in order to achieve third normal form, we need to divide the table as shown below. Firstly, let's divide the table and store student ID, student name, subject ID, and address in it. All the columns are referring to the primary key, which is student ID. Let the second table have subject ID and subject column. So, subject is dependent only on subject ID and not on student ID. As you can see from the above table, all the non-key attributes are now fully functionally dependent only on the primary key. In the first table, columns such as student name, subject ID, and address are only dependent on student ID. In the second table, subject is only dependent on subject ID. With this being understood, now we can proceed further to next normal form, that is Boyce Codd normal form. This is also known as 3.5 normal form. It is the higher version of third normal form and was developed by Raymond F. Boyce and Edgar F. Codd to address certain types of anomalies which were not dealt with third normal form. Before proceeding to Boyce Codd normal form, the table has to satisfy third normal form. In Boyce Codd normal form, if every functional dependency, that is A implies B, then A has to be the super key of that particular table. So what is a super key? A super key is a group of single or multiple keys which identifies rows in a table. Let's look at the table to clearly understand Boyce Codd normal form. In the given table, one student can enroll for multiple subjects. There can be multiple professors teaching one subject. And for each subject, a professor is assigned to the student. These are the necessary conditions of this table. In this table, all the normal forms are satisfied except Boyce Codd normal form. Why? As you can see that student ID and subject form the primary key, which means that the subject column is prime attribute. But there is one more dependency, that is, professor is depending on subject. And while subject is a prime attribute, professor is a non-prime attribute, which is not allowed by Boyce Codd normal form. Now, in order to satisfy the Boyce Codd normal form, we will be dividing the table into two parts. The table at the top will hold student ID, which already exists, and we will create a new column, that is professor ID. And in the second table, which is below, we'll have the columns professor ID, professor and subject columns. Why do we need to have a new column, that is professor ID? By doing this, we are removing the non-prime attributes functional dependency. In the second table, professor ID will be the super key of that table and remaining column will be functionally dependent on it. By doing this, we are satisfying voice code normal form.
What are SQL joins? So if someone asks you what are joins in SQL are commands which are used to combine rows from two or more tables based on a related column between those tables. The joins are predominantly used when a user is trying to extract data from a table which have one-to-many relationships between them or many-to-many relationships between them. Joins in SQL are basically commands, guys, by which you can join two tables and you can get the rows of two tables based on a related column. Now, if you ask me what are the different types of joins in SQL, there are mainly four types of joins in SQL. That is the inner join, the left join, the right join, and the full join. So let's look into each one of them one by one. Starting with the inner join is a type of join that returns those records which have matching values in both the tables. So if you consider table A and table B and you apply an inner join on both these tables, then all those records would be returned which have matching values in both these tables. So for our understanding, I'm going to consider two tables, that is the employee table and the projects table. So when I apply the inner join on the employee table and the project table, all those tuples which have matching values in both the tables will be given as output. So the syntax for inner join is as you can see on the screen, that is select table 1.column1, table 2.column2, table 2.column1 and so on. So basically these are the various columns that you want to retrieve from the respective tables. From table 1, inner join table 2. That is basically you're applying the inner join on table 1 and table 2. And then you have to mention the related column. So that will be mentioned after the on statement. So you'll mention inner join table 2 on table 1 dot match in column name is equal to table 2 dot match in column name. So if I have to just repeat the syntax for you, it's select all the columns, basically whatever columns that you need. From table 1 inner join table 2 on table 1 dot match column name equal to table 2 dot match column name. So if you want to see how inner join can be applied practically, let's move on to my MySQL workbench where I've created these two tables, that is the employee table and the projects table, and let's apply the join statements on both these tables. Okay, so before I move forward with this, let me just open a new query tab and let me just clear all the action outputs. So now what I'll do is I'll just write a statement that is select star from employee, right? So I'll just execute this particular statement and you'll see that, you'll get the output as all the details from the employee table that I've already created. I have around 5 rows with 5 employee IDs and their first name, last name, age, email ID, phone number, and address feed it into this table. So similarly, I'll show you the projects table, right? So let me just remove this and let me type in project and just execute this particular statement. And you'll see the different column attributes in the project table. So as you can see, I have the project ID, the employee ID, the client ID, project name, and the project start date. Client ID can be basically considered for all those clients. So you can have a separate table for the client IDs. So guys, if you see in both these tables, there's a matching column that is the employee ID, right? So the basic relation between both these tables is that a specific employee having a specific employee ID can work on n number of projects, right? He can either work on the project number 1, 2, 3, 4, 5, 6 and so on, right? So as you can see, my employee ID 3 works on two projects, that is the 333 project and the 444 project. And similarly, you can see that, there are employees with the employee IDs 9, 7, 8, but yes, their information was not present in the employee table, right? So let's apply the join statements on these tables and understand what we get as output. So initially I had explained you what the inner join was. So when you apply inner join on two tables, you can clearly see that, you get matching values from both the tables. So what I'm going to do is I'm going to apply inner join on both these tables. So for that, you simply have to write a query. So what I'll do is I've already executed it before. I'll just copy and paste the query over here so that I can explain it for you guys. So what I've done is I've just selected the employee ID, the employee first name, the employee last name, the project ID and the project name to be retrieved from both the employee and the project tables. And then I've applied an inner join on the employee and the project tables. So for that, I've just written a query as you can see on the screen. It's select employee.emp ID, employee.empf name, employee.empl name, that is basically the first name and the last name. Then project.project ID, project.project name. from employee in a join project on employee.empid is equal to project.empid, because empid is basically a matching column in both the tables, right? So let's just execute this particular query. So when you execute this particular query, you can clearly see that all the matching values from both the tables have been retrieved. That is basically all the employees working on a specific project and their respective employee ID, employee first name, last name, project ID, and the project name has been retrieved. So guys, that was about inner join. Now let's move forward to our next type of join, that is the left join. Now as you can see on the screen, now the left join or the left outer join returns all those records from the left table and also those records which satisfy a condition from the right table. So if you consider table A and table B as two tables on which you want to apply the left join, then table A would be considered as the left table and table B would be considered as the right table. And when you apply a left join on table A and table B, you'll clearly see that all the records from the left table would be retrieved and also the records which satisfy a condition from the right table would also be retrieved. Also, let me tell you that the records which have no matching values in the right table, the output or the result set will contain the null values, right? So basically, if you have around 3 rows from the left table which have no matching records from the right table, then those records will have null values. So the syntax for left join is, as you can see on the screen, it's just similar to inner join. You just have to replace the word inner join to left join. You can change the syntax like, select table1 dot column1, table2 dot column2, and so on. That is basically the different column attributes that you want to retrieve from table 1, and then left join table 2 on table 1 dot matching column name equal to table 2 dot matching column name. So guys, that was about left join. So now let's just again shift back to my MySQL workbench, and then I'll show you how you can apply the left join. I'm just going to use a similar query. So what I'm going to do is I'm going to retrieve the first name, the last name, the project ID, and the project name from both the employee and the project table, and then apply a left join on it. So for that, I've written a query as you can see on the screen. That is select employee.emp name, employee.empl name, project.project ID, project.project name. From employee left join project on employee.empid is equal to project.empid, right? So basically that is because this is the matching column between both the tables. So I'm going to just execute this particular query. So once you execute this query, you can clearly see the output. All the records from the left table, and for those records which do not have any matching record for the right table, we have a null value present. So if you remember, we had 5 employees in the employee table, right? So basically that was Vardhan, Himani, Ayushi, Swati, and Hemant. And if you remember, Ayushi worked on 2 projects. So both the project details are present over here. And Hemant worked on no project, right? So since he worked on no project, the values present in the project ID and the project name are null values by default. So guys, that was about the left join. Now let's move forward to the next type of join, that is the right join. So the right join or the right outer join returns all the records from the right table and also those records which satisfy a condition from the left table. So I know guys, this sounds quite similar to the left outer join. Yes, it definitely is. The only difference between both of them is that the right outer join returns all the records from the right table and also the records which satisfy a condition from the left table. Coming to the left outer join, the left outer join returns all the records from the left table and also those records which satisfy a condition from the right table. So it's just vice versa of both of them. And also, the records which have no matching values in the left table, the output or the result set would contain the null values. So guys, that was about the right join. Now the syntax of right join is, as you can see on the screen, it's again really similar to the left join. It's simple. It's select table1 dot column1, table2 dot column2, and so on. So basically all the column values from both the tables that you want to retrieve. From table 1, right join table 2 on table 1 dot matching column name equal to table 2 dot matching column name. So the only difference between syntax, if you've seen the 3 joins that you saw till now, was the word inner, left, and right. Else everything else would be same. So you just have to apply the same logic. So for that, what we'll do is we'll again shift back to my MySQL workbench. Now what I'll do is I'll just copy the query. I'll paste it over here again. And then I'll just change this word to right. So I'll just apply right join. Now I'll just execute this query again. So when we execute this query, you'll clearly see that, the employee first name, last name, project ID, and project name are retrieved from both the tables. All those records from the right table are being retrieved, and the records which satisfy a condition from the left table are also retrieved. But yes, those records which have no matching values from the left table have null values present in the record. you can clearly see that, Vardhan, Himani, Ayushi, and Swati worked on projects, and then they had their specific project IDs and project name. But yes, there were employees who worked on project 6, 7, 8, but their employee information was not present in the employee table. So that's the reason there's null value present in the records of 6, 7, 8th project. So guys, that was about right join. Now moving forward to a final type of join, that is the full join. So the full join or the full outer join returns all those records which either have a matching value in the left table or in the right table. So basically, if you consider table A and table B and you apply full join on both these tables, then it will return all those records which either have the matching value in table A or in table B. Now the syntax for full join is really simple. It's again the same as the other three joins, but you just have to mention the word full join. So the syntax is select table1.column1, table2.column2, table2.column1, and so on. Basically, the different column attributes from table 1, full join table 2 on table 1 dot matching column name equal to table 2 dot matching column name. So that's basically again the related column, that is basically a matching column. Now to see how full join works, let me just shift back to my MySQL workbench. Now let me just tell you one thing over here. Now since I'm showing you how to apply joins on SQL, let me just tell you that, on MySQL, the full join is not applicable. So that's the reason, since I'm showing you on MySQL workbench, the word full join will not work. To just show you the working of full join, I'm just going to use the word union in between both these queries. So what's going to happen is we're going to retrieve all the values from the left table and the matching value to the right table, that is through the left join. And then we're going to union it with all the matching values from the right table and also the values which satisfy a condition from the left table. So this is nothing but full join, but since we're working on MySQL workbench and the word full join doesn't work, so I'm going to just use the word union. I'm just going to retrieve the project ID, the employee first name, and the employee last name. So what I'm going to do is I'm going to just execute this particular query. So when I execute this particular query, you'll clearly see that, we're getting all the values from the left table which satisfy a condition from the right table, and also all the values from the right table which again satisfy a condition or match the values from the left table, right? So if we consider the first left join condition where we got all the employee details and the project details, you'll see that, we've got Vardhan, Himani, Ayushi twice, Swati, Hemant, and the respective project details. Since Hemant did not work on any project, the project ID was null over here. Now, similarly, if we consider the output for the right join where, we took all the records from the right table and took matching values from the left table, we saw that, for the project IDs 666, 777, 888, there was no employee information present, right? So that's the reason we have null values over here for employee first name and employee last name. So guys, that was about full join. So I hope you've understood the different types of joins. The syntax is really simple for all the different types of joins, guys. You just have to change the word in all the different types of joins. For inner join, you use the word inner. For the left join, you use left join. For the right, you use the right join. And for the full join, you use the word full join. So if you just want to apply left join, what you simply do is you mention all the columns. That is, you mention the keyword select and mention the table name dot column name. And then you mention from table 1, left join table 2 on, and then you mention the matching column names from both the tables, right? So you mention table 1 dot matching column name equal to table 2 dot matching column name. So guys, that's how you can use the different types of joins. I hope it's really clear to you guys. If you have any further queries, then you can definitely let us know in the comment section. Now that you know the different types of joins in SQL, let me just cover a few important questions that are generally asked in interviews about joins. So the first question is, what is a natural join and in which situations is a natural join used? A natural join is also a join operation that is used to give an output based on the columns in both the tables between which the join operation is implemented. So that's what a natural join is, guys. It basically aims to give you output based on the columns between which this join is applied. Now, basically, natural join is used when you want to make sure that, the number of columns returned are less. So, for example, if you see on the screen, we have two tables, right? That is table 1 having 2 columns and table 2 having 2 columns over here. Now, table 1 had column names column 1, column 2, and table 2 again has column names column 1 and column 3. Now, if you apply a natural join on both these tables, you'll clearly see that you'll get an output as column 1, column 2, column 3, and the respective records. But in the same scenario, if you apply an inner join, what you will clearly see that, you'll get an output like 1 dot column 1, that is basically for table 1 dot column 1, and then 1 dot column 2, that is table 1 dot column 2, and the respective records would be stored. Now, if you see over here, you'll clearly see that, when you apply the inner join, you'll have a redundancy of data. That is, the column 1 data is getting repeated again. That is basically, it is repeated twice. But in this case of natural join, it's just mentioned once. So this was a scenario of two tables where, the output was so simple. But yes, if you look into a daily basis where, database administrators deal with n number of tables and then they want to apply the join operation on these two tables, you'll clearly see that, if they apply an inner join, then that would create a lot of problem of redundancy of data, and obviously more number of columns would be generated. But yes, in the same scenario, if they apply a natural join, the number of columns would be reduced at a maximum extent. So that's the situation, guys, where you apply a natural join. So if you're ever asked, in which situations do you apply a natural join, you can just answer this question by simply saying that, you can apply a natural join when you want the number of columns to be less. So I hope I'm clear with this point. Now moving on to our second question, that is how to map many-to-many relationships using joins. Now it's a known fact that the joins are basically used to map one-to-many relationships. But yes, if there's a confusion, how to map many-to-many relationships, let me just tell you that you need to use two join statements. So to explain you why two join statements are required, you can consider a scenario where you have three tables, that is the employee table, the projects table, and the technologies table. Now let's assume that each employee is working on a single project. So this obviously means that one project cannot be assigned to more than one employee. Now similarly, if you consider a project can be based on multiple technologies and any technology can be used in any number of projects, this kind of relationship is basically a many-to-many relationship. Now to apply the join operation on the many-to-many relationships, what you can simply do is you can have three tables. That is the projects table and the technologies table itself. So basically, these are the two tables which have many-to-many relationships between each other. And also we can have an extra table, that is the project to technologies table. Now the project to technologies table will hold the combination of project and technology in every row. Now let's say we have a project A. Let's say this project A has three technologies, that is DevOps, microservices, and Hadoop. Now you have to map these technologies to the project, right? Now this project to technologies table will hold the record of every project technology combination. So it will hold a record of project A to DevOps and then project A to again Hadoop and project A to microservices. Similarly, it will have n number of records for n number of projects and m number of technologies. So this table is really important in this scenario. And this table basically aims to map the item on the projects table to the items on the technologies table so that multiple projects can be assigned to one or more technologies. So now that you have three tables, that is the projects table, the technologies, and the projects to technologies table, you need to use two join statements to link all these tables together. That is, use the first join statement to join the project to technologies to projects table, and then we have to use the second join statement to join the project to technologies table to technologies table. Now, this is how all the projects and the technologies which have a many-to-many relationships between them will be linked with each other. So it's really simple, guys. Whenever you have an end-to-end relationship between two tables and you want to apply a join operation between these two tables, you just have to create another table, which can have all the combinations of the previous table, and then you apply a join operation from table A to table C and then table B to table C. So I hope I'm clear with this point. Now let's move forward with our next question, that is, what is a hash join? Now hash joins are also a type of joins which are used to join large tables or an instance where the user wants most of the joined table rows. So whenever the user wants the most of the joined table rows, or when you want to join two large tables, you basically use this type of join, that is basically the hash join. Now the hash join algorithm is basically a two-step algorithm. So it has mainly the build phase and the probe phase. So in the build phase, you basically create an in-memory hash index on the left side of input. And in the probe phase, you go through the right side of input each row at a time and then find the matches using the index created in the build phase. So hash join is again a type of join which is used to join large tables, and it has mainly two steps, that is the build phase and the probe phase. In the build phase, you basically create an in-memory hash index on the left side of input. And in the probe phase, you go through the right side of input each row at a time and find the match using the index created in the build phase. So guys, that was about the hash join. Now let's move forward with our next question, that is, what is a self join and a cross join? So the self join, in other words, is a join of a table to itself. So this basically means that each row in a table is joined with itself. So when you apply a self join to a table, Just remember that each row in a table is joined with itself. Now coming to cross join, the cross join is a type of join in which a join clause is applied to each row of a table to every row of the other table. So whenever you apply a cross join to tables, then just remember that a join clause is applied to each row of a table to every row of the other table. Also, when the where condition is used, this type of join behaves as an inner join, and when the where condition is not present, it behaves like a Cartesian product. So you just have to remember 2 points. The first point is that whenever you apply a cross join on specific tables, a join clause is applied on each row of a single table to every row of the other table. And also, when the where condition is present, this type of join behaves as an inner join. And when the where condition is not present, it behaves like a Cartesian product. Now let's move forward with our final question, that is how to perform join operation on three tables. Now, if you remember in the previous questions, I had discussed a question where, we understood how to map end-to-end relationships using join operations, right? So over there, if you remember, we used three tables, that is the projects table, the technologies table, and the project to technologies table. Now, to apply a join operation on three tables, we use two join statements, right? That is to join table A to table C and then table B to table C. So basically, to apply a join operation on three tables, you need to use two join statements.
What are triggers? Triggers are the SQL code that are automatically executed in response to certain events on a particular table. These are used to maintain the integrity of the data in a given table. A trigger in SQL works similar to real-world trigger. I know this is a formal definition, but let's try to understand it in a better way. Here we can see Anna is asking Sharon about triggers. Sharon imagines trigger to a falling dominoes. How does a falling dominoes is related to a trigger? Let's move further and see the explanation given by Sharon. Anna is a marketing officer in a company. When a new customer data is entered into the company's database, she has to send the welcome email to each and every new customer. If it is one or two customers, Anna can do it manually. But what if the count is more than 1,000? It will be a repetitive and tiring job. Efficiency of Anna may drop. Well, in such scenario, triggers come in handy. Anna can easily create a trigger which will automatically send a welcome email to new customer once the data is entered into the database. After creating a trigger in the database of the company, she doesn't have to monitor the trigger frequently. The efficiency of the work is increased. With this analogy given by Sharon, I hope you're clear with the introduction of trigger. Let's head to the next topic, that is syntax and example of a trigger. On the screen, we can see the syntax of a trigger. And let me explain each and every part in detail. The first part is create trigger. These two keywords are used to specify that a trigger block is going to be declared. The next one is trigger name. It specifies the name of the trigger. Trigger name has to be unique and shouldn't repeat. The next one is before or after. This specifies when the trigger will be executed. It tells us the time at which the trigger is initiated. That is, either before ongoing event or after the ongoing event. Before triggers are used to update or validate record values before they are saved to the database, while after triggers are used to access fields values that are sent by the system and to affect changes in other records. The records that activate the after trigger are read-only. We cannot use after trigger if we want to update a record because it will lead to a read-only error. The next part of the syntax is insert, update, or delete. These are the DML operations and we can use either of them in a given trigger. Next is on table name. We need to mention the table name on which the trigger is being applied. Don't forget to use on keyword and also make sure the selected table is present in the database. The next part is for each row or for each column. Row level triggers get executed before or after any column value of a row changes, while column level triggers get executed before or after the specified column changes. The final part of the syntax is trigger body. It consists of queries that needs to be executed when the trigger is called. So this was a brief introduction to syntax of a trigger. On the screen, we can see an example for a trigger. In the given trigger, we are trying to calculate the marks of a student as soon as his details are updated to the database. Here, we are adding 100 marks to the marks column of each new record. Also make a note, new keyword refers to the row that is getting affected. So this was all about a simple trigger. But we can also create a nested trigger that can do multiple processes. Also handling it and terminating it at the right time is very important. If we don't end the trigger properly, it may lead to an infinite loop. You might be wondering in which scenario we can use the nested trigger. Rather than giving you a tailored answer, let me share a scenario with you, which will help you in understanding the nested trigger in a better way. Continuing from the earlier scenario, Anna sent an email for every new customer that was added to the company's database. Now, what if she wishes to keep a track of numbers of customers to whom the email was sent? Now, Anna needs to create a nested trigger to keep the track of the count along with sending an email. Doesn't it sound simple? So that was all about the syntax of trigger. Let's now try to implement an example of trigger in SQL. So the next topic is operations in trigger. We can perform many operations using triggers. Some may be simple and some may be little complex. But once if we go through the query, it's easy to understand. The first operation is drop. We can use drop command to remove a trigger from the database. And the syntax for this is drop trigger trigger name. To understand this in a better way, let's head to MySQL Workbench. I hope you know how to use MySQL Workbench. If not, then check SQL Basics for Beginner video by Edureka for better understanding of how MySQL Workbench will work. To drop a trigger from the database, the trigger has to be present in our database. So this is the syntax used to drop a trigger. So let me execute this query. So we can see in the status bar, the trigger with the name sample trigger has been dropped. Let's head to the next operation, that is display. We can use show command to display the triggers from the database. And the syntax for this is show triggers in database name. So let me head back to MySQL Workbench to execute this command. To display a trigger, the trigger has to be present in the database. So let me execute this SQL query to display the triggers that are present in my database. I can see that the trigger with the name sample trigger is present in my database Edureka. So let's head to the next operation. The next operation is insert. And the first variant is before insert triggers. Before insert triggers are used to update or validate record values before they are saved to database. And the syntax for this is create trigger calculate. Here calculate is the name of the trigger before insert on the table name for each row and set operation. So let me head back to MySQL Workbench to execute this query. Before explaining before insert trigger, let me explain something else. I will be using student table and the columns of this table are, it has student ID, first name, last name, address, city and marks. I will be creating a trigger with the name sample trigger. Here, before insert trigger is used to set 100 marks extra for each and every student marks column when the new student value is added to the table. So let me execute this trigger. And we can see that the trigger has been created. Now, let me insert a record into the table. I'll be using insert into command to insert a record into the table. So let me execute this query. But before that, make sure to remember I will be adding details of 𝐓𝐵𝐾. His marks will be 478. But as we have created a trigger, it has to add 100 marks extra and the resulting marks has to be 578. So let me execute this query. Okay, the query has been inserted. So let me check the table. And we can see that the marks of 𝐓𝐵𝐾 is 578. So we can clearly say that the trigger has worked. So the next variant of insert is after insert triggers. After insert triggers are used to access fields values that are set by the system and to effect changes in other records. And the syntax is create trigger, name of the trigger that is total mark, after insert on student. Student is a table name for each row, insert into final marks value of the column. So let's head back to MySQL Workbench to execute this example. To use this variant, we need one more table. that is final marks table, where the trigger will store the results. This SQL query will create a table with the name final marks. So let me execute this query. So we can see in the status bar, the table with the name final marks has been created. Whenever we insert data to student table, the previous trigger, that is sample trigger, will be executed. Now, with the help of after insert trigger, let's store the marks of the student table in the final mark table. This will be the after insert trigger, and the name of this trigger is cal. We will be updating total marks from student table to final marks table. Let me execute this trigger. And we can see that the trigger with the name cal has been created. To check the working of a trigger named cal, let me insert the data of Rachit Kumar into student table and make a note his marks is 500. So we can see that the data has been inserted into the student table. Let me execute this query. And we can see that the student named Rachit Kumar has 600 marks. Let's move to the next topic, that is advantage and disadvantage. Let's look at the advantages of a trigger. The first one is forcing security approvals on the table that are present in the database. The next one is triggers provide another way to check the integrity of the data. The third one is triggers counter-react invalid exchanges. The fourth one is triggers handle errors from the database layer. And the final one is normally triggers can be useful for inspecting the data changes in the table. Let's look at the disadvantage of a trigger. Triggers can only provide extended validation, that is, not all kind of validations. For simple validations, you cannot use not null, unique, check, and foreign key constraints in a given trigger. The next one is triggers may increase the overhead of a database. And the final disadvantage is triggers can be difficult to troubleshoot because they execute automatically in the database. This may not be visible to client applications.
Now let's come to our topic, that is SQL versus MySQL. So as the first topic of comparison, we have the definition. So what is the definition of SQL? SQL is the standard language for operating, managing, and accessing databases. Now let's see what is the definition of MySQL. So MySQL is a relational database management system for storing, retrieving, modifying, and administering databases. So next point is history. So for SQL, SQL was born in 1970 as a programming language known as SQL. It was developed by Microsoft Corporation, but now it is also known as SQL. While MySQL claims to be the first open source relational database in the early 1990s, it was developed by MySQL AB and is currently owned by Oracle Corporation. Now looking into the complexities, to use SQL efficiently, you must first learn and then grasp the language to start working with SQL. While for MySQL, you can easily access it by downloading and installing the same. Now coming to the usage, SQL is a programming language, so it can be used by querying and operating, while MySQL allows for data manipulation, storage, modification, and deletion in a tabular format. Now the syntax or format. So SQL is a programming language, as we all know now. The syntax and format are fixed, it's declarative and easy to use. It starts with the clause and ends with a semicolon. While MySQL is a software and it is not a programming language, hence it does not have any commands or any format. Now the updates. Since SQL is a programming language, it is fixed and command remains unchanged and we can't update it. While MySQL has its latest updates and versions for enhanced performance. Now for supporting language, SQL was designed for Windows, but it also works on Linux, Mac OS in its most recent versions. While MySQL is a cross-platform compatible running on Linux, Mac OS and Windows as well. Now coming to the data security, SQL servers are secured as no third party or outsiders are allowed to manipulate data. While in MySQL, it is susceptible to more security threats due to its open source nature. It gives access to data manipulation and modification to unauthorized users as well during the runtime.
Now let's just understand what is NoSQL. NoSQL, or most commonly known as Not Only SQL database, provides a mechanism for storage and retrieval of data and is the next generation database. This kind of database has no specific schema and does not have tables with rows and columns storing data values, but can definitely handle large amount of data. So if you consider the example on the screen, we have an employee database which has two collections, that is the employee and the projects collection. Now each of these collections have documents which are basically the data values. So if you just want to understand these terms, then you can just consider the collections to be your tables and the documents to be your fields in the tables. So if you compare a SQL database and a NoSQL database, for example, let's just say we have an employee database where there's an employee table with around 10 columns, right? That is basically the 10 fields. Now in the NoSQL database, what will happen is the employee table itself will be taken as a collection and each of these fields will be considered as documents. Now, the most interesting part of NoSQL is that these kind of databases do not have to use the same schema for the presence of multiple documents in one collection. So since NoSQL has dynamic schema, that means that multiple documents can be present in a single collection, and also each collection can have different documents. So you can have a document in the collection which has both employee ID and employee name. And also you can have a document in the same collection which do not have the ID and just stores the name. So that's how, guys, you can play around with collections and documents in NoSQL database. Apart from this, let me just also tell you that there is no specific query language present in NoSQL. So basically the language that you use to retrieve data is completely infrastructure based. That is basically how you store your data and where you store your data. Lastly, there are no or very few relationships present in a NoSQL database, as you do not have a predefined schema, but you do have a dynamic schema in which we can put all the required information in a collection, right? When you have a dynamic schema and you have the option of putting all the required information in a single collection, and the collection can differ in the same schema itself, you actually do not need any relationships to be present, right? So that's how, guys, NoSQL does not have or has very few relationships. So guys, if I just have to summarize NoSQL for you, then NoSQL is a type of database which do not have a predefined schema, a query language, and has no tables. It follows a method of storing data in a dynamic schema with less or no relationships and can handle humongous amount of data. Let's now see how these databases stand against each other. So in this face-off, we'll be comparing both these databases based on the grounds such as the type of database, schema, database categories, complex queries, hierarchical data storage, scalability, language, online processing, base properties, and external support. Let's get into the detail with the first comparison factor, that is type of database. Now, when we compare these databases based on this factor, let me just tell you that SQL is essentially called a relational database and it organizes structured data fields into defined columns. So a database can have n number of tables and each table can have m number of columns with the data stored in it. Each table can be related to the other tables also, right? So if you have around 10 tables, then those 10 tables can have around 2 to 3 columns, or you can say more than that columns in each table, and all these 10 tables can be related to each other. Coming to NoSQL, NoSQL is a non-relational database which provides a mechanism for storage and retrieval of data. In the NoSQL database, data is modeled in the form of collections and hence it tries to avoid relations, as I just explained you before. So guys, if you have to compare these databases based on this factor, then SQL is essentially a relational database and NoSQL is a non-relational database or a distributed database. Next, we'll be comparing these databases based on the schema. While comparing these databases based on this factor, let me tell you that SQL needs a predefined schema for structured data. So before you start using SQL to extract and manipulate data, you need to make sure that your data is predefined in the form of tables. Coming to NoSQL, well, NoSQL databases have a dynamic schema for unstructured data. So if you're using a NoSQL database, then there's no predefined schema present and the complete schema of your data completely depends on how you wish to store the data. That is which fields, that is basically which documents that you wish to store in which collections and how you wish to store them. So guys, that was about schema. The SQL has a predefined schema and the NoSQL has a dynamic schema. Now moving on to the next parameter, which is database categories. Now SQL databases are basically the table-based databases. So as I explained in the previous factors, the SQL databases can have n number of tables related to each other and each table can have m number of rows and columns storing data in each cell of the data. Now, similarly, if we talk about the NoSQL databases, the NoSQL databases have mainly four categories of databases. That is document database, the key value stores, the graph stores, and the white column stores. Coming to the document database, now this kind of database pairs each key with a complex data structure known as a document. It can contain many different key value pairs or the key array pairs or even the nested documents. Coming to the key value stores, these are the simplest form of NoSQL database. So every single item in the database is stored as an attribute name or a key together with its value. Now coming to the graph stores are basically used to store the information about networks such as the social connections. Now the graph stores mainly include the Neo4j and the Hypergraph DB. Coming to the last kind of database category of NoSQL, that is the white column stores. The white column stores such as Cassandra and HBase are optimized for queries over large data sets and stores columns of data together instead of rows. So guys, these were mainly the four categories of NoSQL database. That is the document database, the key value stores, the graph stores, and the white column stores. Now this might have given you an idea of, the SQL databases basically represent data in the form of tables which consist of n rows of data, whereas the NoSQL databases are the collection of key value pairs, documents, graph databases, or white column stores which do not have a standard schema definitions which it needs to stick to. So guys, this was the main difference between SQL and NoSQL, that SQL is basically the table-based databases with a predefined schema, and the NoSQL databases mainly have different categories of databases with a dynamic schema. So I hope I'm clear with this point. Next, let's discuss how these databases fit for complex queries. Now, when we talk about complex queries, let me just tell you that SQL is a good fit for complex query environment as the schema in SQL databases is structured and has proper tables. So even if you wish to apply nested queries with many subqueries inside the outer query, you can easily do by using the proper table and column names, and you can retrieve the required data. Coming to the NoSQL databases, the NoSQL databases are not a good fit for complex queries as they don't have standard interfaces to perform complex queries, and the queries themselves in NoSQL are not as powerful as the SQL query language. So this is basically because they're not written in a specific language, and the language in which they're written is completely based on the database infrastructure, or you can say the schema. So if you have to compare how these databases fit for complex queries, then let me tell you that SQL is a better fit for complex queries when compared to NoSQL. Now moving on to the next factor of comparison, that is hierarchical data storage. Now, when we compare the databases based on this factor, let me tell you that the SQL databases are not a best fit for hierarchical data storage. Now, this is because as the number of tables increase, the complexity of relating them to each other also keeps increasing. Now, in such a scenario, you cannot relate humongous amount of tables with n number of columns to each other, right? But coming to NoSQL database, the NoSQL database fits better for hierarchical data storage as it follows the key value pair way of storing data similar to the JSON data. Now, NoSQL databases are also highly preferred for large data sets when compared to the SQL database, and one such example is HBase. So basically, HBase is used for this purpose. Next point of comparison will be scalability. Now, SQL databases are vertically scalable. You can load balance this database by optimizing your hardware requirements such as increasing the CPU, RAM, SSD, etc. on a single server. On the other hand, the NoSQL databases are horizontally scalable. You can do load balancing by adding more servers to your cluster so that with the help of these servers, you can handle large traffic. So on the note of scalability, SQL is vertically scalable and NoSQL is horizontally scalable. Next, we'll be comparing these databases based on language. The SQL databases have a specific language and it does not vary from database to database. So basically, the SQL databases use the structured query language for defining and manipulating the data, which is very powerful. Coming to NoSQL, the NoSQL has no specific language and it varies from database to database. In the NoSQL databases, the queries are focused on the collection of documents, and sometimes the language used in NoSQL is also called the unstructured query language. So on the note of language, guys, the SQL uses a proper defined language, that is the structured query language, and NoSQL has no specific language, and the language differs from database to database. Now moving on to the next parameter, which is online processing. Now when we compare both these databases based on online processing, SQL databases are the best fit for heavy-duty transactional type applications as it's more stable and promises the atomicity as well as the integrity of data. While you can definitely use NoSQL for transaction purpose, yet it is still not comparable and stable enough in high load for complex transactional applications. So you can understand by this that SQL is mainly used for OLTP, that is basically online transactional processing, and NoSQL is mainly used for OLAP, which is online analytical processing. So if I have to just explain these terms OLTP and OLAP for you, then OLTP is basically characterized by large number of short online transactions such as insert, update, and delete. The main emphasis for OLTP systems is to put on a very fast query processing, maintain data integrity in multi-access environments, and an effectiveness measured by number of transactions per second. In OLTP databases, there is proper detailed and current data, and the schema used to store transactional database is in the entity model, usually 3NF. Now coming to OLAP, that is basically online analytical processing. This is basically characterized by relatively low volume of transactions, and queries are often very complex and involve aggregation. For OLAP systems, response time is an effectiveness measure, and OLAP applications are widely used by data mining techniques. So in the OLAP database, there is aggregated historical data stored in multi-dimensional schemas, usually the star schema. So guys, that was about OLTP and OLAP. So you can just understand this point that SQL is mainly used for heavy transactional type applications, and NoSQL is basically used for analytical processing and can definitely be used for transactional type applications, but yet it is still not stable for high load applications. So now the next point of comparison we have is base properties. Now SQL databases emphasize on the asset properties, that is the atomicity, consistency, isolation, and durability, whereas the NoSQL database follows the 𝐶AP theorem, that is the consistency, availability, and partition tolerance. So let's talk about both of them one by one. Starting with the asset properties mainly stand for atomicity, consistency, isolation, and durability. Now, atomicity basically refers to the transactions that are completely done or failed, where the transaction refers to a single logical operation of data. Now, this basically means that, even if one part of the transaction fails, the entire transaction fails and the database state is left unchanged. Coming to consistency, the consistency ensures that data must meet all the validation rules. In simple words, you can just say that, your transaction never leaves the database without completing its state. Coming to isolation, the main goal for isolation is basically the concurrency control. And finally, the durability. The durability means that, if a transaction has been committed, it will occur whatever may come in between, such as the power loss, crash, or any sort of error. So guys, that was about the asset properties, that is basically the atomicity, consistency, isolation, and durability. Coming to the 𝐶AP theorem, the 𝐶AP theorem or the Eric Brewer's theorem states that we can only achieve at most 2 out of 3 guarantees for a database. That is basically the consistency, availability, and partition tolerance. So here the consistency means that all the nodes in the network see the same data at the same time, or the reader gets most recently written data. Coming to availability, availability is the guarantee that every request receives a response about whether it is successful or failed. And the more number of users a system can cater to, a better is the availability. Coming to the partition tolerance, the partition tolerance is a guarantee that the system continues to operate despite arbitrary message loss or failure of any part of the system. In other words, even if there is a network outage in the data center and some of the computers are unreachable, still the system continues to perform. Now, out of these 3 guarantees, that is the consistency, availability, and partition tolerance, no system can provide more than 2 guarantees. Now, since in the case of distributed systems, the partition of network is must, the trade-off is always between consistency and availability. So you can just understand that, NoSQL cannot provide consistency and high availability together. So guys, that was about the base properties. SQL is completely based on the asset properties and NoSQL is based on the 𝐶AP theorem. Finally, the last but not the least factor of comparison is external support. Now, external support is available for all SQL database from their vendors. There are also a lot of independent consultations who can help you with SQL database for a very large-scale deployment. This is mainly due to since SQL has been into existence since more than 40 years and people have been using SQL regularly now. Coming to NoSQL, for some NoSQL databases, you still have to rely on the community support and only limited outside experts are available for you to set up and deploy your large-scale NoSQL deployments. This is mainly because NoSQL has come into existence and many of them haven't explored it yet much. So folks, with this we come to an end of this face-off between SQL and NoSQL. I hope all the comparison factors were clear to you guys. Now in this session, since we have discussed so much about SQL and NoSQL, let me just show you some examples of the same. So as you can see on my screen, these are the examples for SQL and NoSQL. So the popular examples for SQL are the Oracle, the PostgreSQL, the MySQL, the Microsoft SQL Server, and SQLite. Now coming to the examples of NoSQL, the examples of NoSQL are Redis, MongoDB, Apache HBase, Big Data Table, and Cassandra. Now out of the lot, the most popular databases in today's market are basically the MySQL and MongoDB from the SQL and the NoSQL sections. So next in this session, we'll be comparing MySQL and MongoDB based on various parameters. Now, before I move on with the comparison of MySQL and MongoDB, let's first understand what is MySQL and what is MongoDB. Starting with MySQL, MySQL is an open source relational database management system that works on many platforms. It provides multi-user access to support many storage engines and is backed by Oracle. So you can buy a commercial license version from Oracle to get premium support services. Now the features of MySQL are as you can see on my screen. So basically MySQL provides comprehensive application development, scalability and flexibility, and it's open source and provides 24/7 support, provides high availability, high performance support, secures your data, provides robust transactional support, requires low total cost of ownership, and provides ease of management. Now coming to comprehensive application development, MySQL has plugin libraries to embed the database into any application. So it basically supports stored procedures, triggers, functions, views, and many more application development. Coming to scalability and flexibility, with MySQL, you can run deeply embedded applications and create data warehouses holding a humongous amount of data. Next, talking about open source and 24/7 support, this relational database management system can be used on any platform and offers 24/7 support for open source and enterprise edition. Talking about high availability, MySQL can run high-speed master-slave replication configurations and it offers various cluster servers. Talking about high performance, MySQL provides fast load utilities with distinct memory caches and tables index partitioning. Next, about data protection, MySQL supports powerful mechanisms to ensure that only authorized users have access to the databases. Next, talking about robust transactional support, MySQL holds the asset properties, that is basically the atomicity, consistency, isolation, and durability properties, and allows distributed multi-version support. And talking about low total cost of ownership, MySQL makes sure that it reduces the licensing costs and hardware expenditures. And talking about finally the ease of management. This software can be easily downloaded and also uses an event scheduler to schedule a task automatically. So guys, the features of MySQL are basically the comprehensive application development, the scalability and flexibility, open source and 24/7 support, high availability, high performance, secure data protection, robust transactional support, low total cost of ownership, and ease of management. Now coming to MongoDB. MongoDB is a non-relational database which stores data as documents in a binary representation called BSON, that is basically binary JSON. This kind of database stores related information together for fast query access to the MongoDB query language. The features of MongoDB are as you can see on my screen, that is indexing, replication, ad hoc queries, schema list, and sharding. Talking about indexing, MongoDB indexes are created in order to improve the search performance. Next, talking about replication, MongoDB distributes the data across different machines. Coming to ad hoc queries, MongoDB supports ad hoc queries by indexing the BSON documents and uses a unique query language. Coming to schema list, it's very flexible because it's schema list database and is written in C++. And talking about sharding, MongoDB uses sharding to enable deployments with large datasets and high throughput operations. So guys, these were the mainly 5 features of MongoDB, that is indexing, replication, ad hoc query, schema list, and sharding. So guys, now that you know what MySQL is and what MongoDB is, let's compare these two databases based on the grounds that you can see on the screen, that is the query language, the flexibility of schema, the relationships, security, performance, support, key features, replication, usage, and active community. So now let's get into detail with the first comparison factor, that is the query language. Now MySQL uses the structured query language to communicate with the database. Not only is it simple, it is also very powerful language which consists of mainly two parts, that is the data definition language and the data manipulation language. MongoDB, on the other hand, uses an unstructured query language. To build a query in JSON documents, you need to specify a document with various properties you wish the results to match. It is typically executed using a very rich set of operators that are linked with each other using JSON. Now, MongoDB treats each property as having an implicit Boolean AND. It basically also supports Boolean OR queries, but you must definitely use the special operator $OR to achieve it. So to make you understand better, I've considered the example on the screen. So to insert the data into the employees table in the SQL query, you just have to type in insert into employees, that is basically your table name, and insert into is your SQL syntax, and then you mention the column names, that is the employee ID and employee age, and then you use the SQL syntax, that is the values, and mention the values for the fields. So to just insert data into the table, you mention insert into employees, employee ID, employee age, values, and then you mention the values. Now similarly, in the same scenario, if you wish to insert the data into a collection which is stored in the MongoDB database, what you simply have to do is you have to mention db.employees.insert, where employees is the collection name, and then you have to mention employee ID and then mention the value, and then mention again age and the value. So basically over here, employee ID and age are basically the fields. So guys, this is how the query language between MySQL and MongoDB differs. Next, we'll be comparing these databases based on the flexibility of schema. Now, in the perspective of flexibility of schema, let me tell you that before you can store anything in MySQL, you need to clearly define tables and columns, and every row in the table should have the same column. Now, this is basically because there isn't much space for flexibility in the manner of storing data if you follow normalization. For example, if you have an employee database, you need to create a table which can hold the data of employees. Now, this table can have many attribute values such as the employee ID, employee name, and so on. Now, similarly, talking about MongoDB, one of the best things about MongoDB is that there are no restrictions on the schema design. So you can directly drop a couple of documents within a collection, and it isn't necessary to have any relations between those documents. Now, the only restriction with MongoDB is that you need to frequently optimize your schema based on how the application will be accessing the data. Now, MongoDB stores the data in the JSON type manner. So if we consider the previous example, that is the employee table, the data in MongoDB would be stored as employee ID, and then we have to mention the employee ID, that is basically the value for employee ID, then employee name, and then you have to mention the employee name, employee age, and so on. So basically this will be considered as a document, and now these documents can be stored in a collection as well. So basically MongoDB creates schemaless documents which can store any information you want, though it may cause problems with the data consistency, whereas the MySQL follows a strict schema template. Now moving on to the next parameter, which is relationships. Now when we talk about relationships, MySQL supports the join operations. So to explain you in simple terms, join makes the relational database relational. So basically the join allows the user to link the data from two or more tables in a single query with the help of the select command. So for example, if you want to retrieve the data from the employee and the projects table based on the matching column, you can easily obtain the desired data by applying any type of join such as the inner, left, right, or full based on your need. Now coming to MongoDB, well, MongoDB does not support the join statements, but it supports the multi-dimensional data types such as arrays and even other documents. So the placement of one document inside another document is basically known as the embedding of documents, and MongoDB supports the embedding of documents. So talking about relationships, guys, MySQL supports the join statements and the MongoDB does not support any join statements. Next, let's discuss the security factor for both of them. Now talking about MySQL first, MySQL uses a privilege-based security model. This means that it basically authenticates a user and facilitates it with the user privileges on a particular database such as create, select, insert, update, and so on. Now coming to MongoDB, MongoDB uses a role-based access control with a flexible set of privileges. Its security features basically include the authentication, auditing, and authorization. Not only this, but it is also possible to use the transport layer security and the secure socket layer for encryption purposes in MongoDB. So basically this ensures that it is only accessible and read by an intended client. No other client can go through the documents. So guys, that's how the security is provided in MySQL and MongoDB. Now let's move forward to the next factor of comparison, that is performance. So on comparing MySQL and MongoDB on this parameter, MySQL is quite slower in comparison to MongoDB when it comes to dealing with the large databases. This is mainly because MySQL can't cope up with large and unstructured amounts of data, whereas MongoDB can. So that's the reason, guys, MongoDB is much faster than MySQL. Now talking about MongoDB, MongoDB has the ability to handle large unstructured data. It's much faster than MySQL because it allows the users to query in a different manner that is more sensitive to workload. But yes, there is as such no benchmark on which database is faster because only your demands, your data and your infrastructure can tell what you need and which database can provide you the output faster. So guys, that was about performance. Next, we'll be comparing these databases based on support. Well, both of them offer excellent support 24/7 for security fixes, maintenance releases, bug fixes, patches and updates. So there is as such no difference between both of them based on this parameter as both of them offer good support. So guys, that was about support. Now moving on to the next parameter, which is key features. The key features of MySQL and MongoDB are as you can see on my screen. Let's start with MySQL first. The key features of MySQL are mainly triggers and SSL support, provides text searching and indexing, also allows query caching, provides integrated replication support, and also provides different storage engines. So guys, these were the key features of MySQL. Now talking about MongoDB. MongoDB supports auto-sharding, comprehensive secondary indexes, in-memory speed, native replication, and embedded data model support. So these were few features of MySQL and MongoDB. So yes, there are various differences between both these databases, but there are few key features, which help both MySQL and MongoDB to win in their own market. Now, next point of comparison we have is replication. Now, MySQL supports the master-slave replication and the master-master replication as of MySQL 5.7.6 and later. And this kind of multi-source replication allows you to replicate from several masters in parallel. Talking about MongoDB, MongoDB supports the built-in replication, sharding, and auto-elections. So by using auto-elections, you can set up a secondary database to automatically take over if the primary database fails. So sharding allows for horizontal scaling, which is difficult to implement in MySQL as MySQL is vertically scalable. Not only this, but MongoDB also uses replica sets to create multiple copies of data. So each member of the replica set can have the role of primary or secondary at any point in the process, and the read and writes are done on the primary replica by default and then replicated to the secondary replicas. So guys, this was about the replication. MySQL supports the master-slave replication and the MongoDB supports built-in replication, sharding, and auto-elections. Next, we'll be comparing these tools based on usage. Now for this factor, I'm going to tell you where you can use MySQL and MongoDB. So let's start with MySQL first. MySQL is the best fit for data with tables and rows. This works better for small data sets and allows frequent updates. MySQL is also used for strong dependency on multi-row transactions and is also used when you want to modify large volumes of records. Talking about MongoDB, MongoDB best fits for unstructured data and works better for large data sets. This is also used when you have high write loads and high availability in unstable environment, and the data is completely location based. So this was about MySQL and MongoDB, guys. MySQL mainly best fits for data with tables and rows, and MongoDB best fits for unstructured data. Finally, the last but not the least factor of comparison is the active community. The MySQL database is mainly owned and maintained by the Oracle Corporation. So they offer a developer zone on the MySQL website, and the community for MySQL is, I would say, much better than that of MongoDB. So if you want the support, both of them offer good support. But yes, if you talk about active community, then MySQL has a better active community than compared to MongoDB. So guys, now that I've told you so much about MySQL and MongoDB, let me just shift to my MySQL Workbench and MongoDB Compass so that I show you how you can create tables and databases in MySQL and how you can create databases and collections in MongoDB. So first we'll be looking into MySQL. So for that, I'll open my MySQL Workbench. So as you can see on my screen, this is my MySQL Workbench. So I'm just going to open my connection. So guys, this is how your MySQL Workbench looks. Now to show you how you can use MySQL, I've already written the commands. So I'm just going to tell you how you can use them. So to create a database, I've used the query create database and I've mentioned the database name, that is employee info. So this is a SQL language, guys, where create and database are the SQL syntax and employee info is the data parameter. So I'm going to just execute this particular query. Now once the query is executed, you can clearly see that the database has been created. Now to use this database, you can just directly use database name, that is employee info. So if I just execute this query again, you'll clearly see that, we'll be using this particular database. Now to create a table inside this particular database, you can use the query like, create table, table name, and then you mention all the field names and the data types, right? So over here, I have different field names like the employee ID, employee first name, last name, age, email ID, phone number, and address, and their specific data types, right? So I'm going to just execute this particular query. So once I execute this particular query, you can see that, a table has been created. So now if we just look into our databases, we have a database that is employee info, and then we have a table inside it. Now to insert data into the table, what you can use is, you can just use the query insert into table name, that is employee over here, mention all the field names, then use the SQL syntax keyword values, and then mention all the values, right? So over here, I've written a query as insert into employee, employee ID, first name, last name, age, email ID, phone number, address, values, and then I've mentioned the values, right? So I'm going to just execute this particular query. So once the query has been executed, you can clearly see that, data has been inserted into the table. So I'll just go to the employee info table, go to the tables option, go to employee, and then I'm going to just look into the table. So when I just check into the option of view, you can clearly see that, our first record has been inserted. So guys, that's how it's really simple to use MySQL, and with the help of MySQL Workbench, you get the GUI experience, where you can easily mention your required queries and then get the outputs, right? So that was about MySQL Workbench, guys. Now shifting to MongoDB Compass. So guys, this is how the MongoDB Compass looks. So basically, I've already created a database. Now, if you just wish to go and check how a database has been created, what you can simply do is you can go over here to My Cluster. And once you go to My Cluster, you get an option of create database, right? So I'm just going to create a database. So let's say I mention it to be employee info. And then over here, since I've told you, database has collections and then collections have documents. So basically a group of documents is collections and a group of collections is a database. I'm going to mention my first collection name. Let's say, employee. And then I'm going to just click on create database. So once I click on create database, you can clearly see that, my database has been created, that is employee info. So I'll click on this and you'll see that, we already have a predefined collection created. Now, apart from this, you can also have a number of collections to be created. But since I'm just showing you how you can use MongoDB, I'm not going to create many more collections. This is just a single collection that I've already created. Now, what you can do is you can again create documents inside this particular collection. To do that, you have to click on this collection, that is the employee collection, and over here you get an option for insert document, right? So you can just click on this option of insert document, mention the required values, that is basically the id.object ID. So basically over here you can just mention employee ID, and in this section you can just mention the employee ID. Now similarly you can mention the employee name also, and over here I'll mention the employee name to be, let's say, Sahiti. Right now over here, if you see, we can also use the data type. So let's just say, our employee ID should be int. So I'll just mention it to be int and employee name to be string, right? So that's how you can mention the data types for your documents. And then once you've inserted all the required values, you can just click on insert. So once you click on insert, you can clearly see that, your document has been created. Now this you can either view in the form of a table. That is basically, which document ID basically has which employee ID, that is which data type, and also the employee name. Or you can also view it as a list. So I was previously viewing it as a list. This is how you can create a database and then create a collection and documents. Well, I'm not going to go in depth of how you can use this MongoDB Compass and how you can explore much more features of this. So guys, it was just a short demo on, how you can use MySQL Workbench and MongoDB Compass to handle structured data and unstructured data. So folks, with this, we come to an end of this face-off between MySQL and MongoDB, and I hope you understood all the points. Now, knowing so much about MySQL and MongoDB would have definitely raised a question on your mind whether to use MongoDB or MySQL for your businesses. So guys, well, there is no clear winner between both of them. The choice of database completely depends upon the schema of your database and how you wish to access it. Nevertheless, you can use MySQL when you have a fixed schema, high transaction, low maintenance data security with a limited budget, and MongoDB while you have an unstable schema, no specific database administrator, high availability, cloud computing involved with inbuilt sharding. So guys, this is when you use MySQL and MongoDB. There's no clear between both of them. It completely depends on you, which type of database you would want to go for your businesses, and how you think your business will be benefited by choosing which database. So there won't be any final verdict as to which among them is best, as each one of these excel based on your requirements.
Now, what exactly is data science? Now, data science in simple terms is the process of deriving useful insights from data in order to solve real world problems or in order to grow a business. Now, data science was introduced because we are generating an immeasurable amount of data. For example, there's a fact that we're generating more than 2.5 quintillion bytes of data every day. And at this pace, it's only going to grow because right now everything runs on data. So the idea behind data science is to take up all this data and derive useful insights or derive knowledgeable insights from this data so that you can grow your business or you can solve a problem. That's what data science is all about. The data is the key in data science. And since we are producing so much data, is the perfect time for you to learn data science. And data science basically covers artificial intelligence, machine learning, natural language processing. All of these processes are covered under data science. So that is one of the reasons why data science has become so popular. Because of the amount of data we're generating, we need methods and technologies that can handle so much data and they can, derive something useful from the data. So that's a small introduction to data science. And if you guys want to learn more about data science, I'll leave a couple of links in the description box. Now let's move ahead to our topic of discussion. First, we'll understand why we need SQL for data science. So like I said, data science is basically all about deriving useful insights from data. Data science involves extracting, processing, and analyzing tons and tons of data. At present, what we need are tools that can be used to store and manage this vast amount of data. Now, this is where SQL comes in. SQL can be used to store, it can be used to access and extract massive amounts of data in order to carry out the whole data science process more smoothly. So SQL as a querying language, it can be used to perform a lot of querying operations, a lot of search operations, extractions, and editing and modifying your data. So we need a huge management system. And along with that, we need a language that can perform all the operations that we want to do on our data. That's where SQL comes in. So like I said, we'll be using MySQL today. And let's understand why I've chosen MySQL. Now, first of all, MySQL is very easy to use. You have to get only the basic knowledge of SQL, right? You can build and interact with MySQL with just a few simple SQL statements, right? And SQL statements are quite easy, like they're a lot like your English language. I feel like it's the most basic and the most understandable language there is, querying language. Apart from this, it is also very secure. Actually, MySQL consists of, you can say, a solid data security layer, which will protect all of your sensitive data or your confidential data from any intruders. Passwords are encrypted in MySQL. So that's a good advantage of using MySQL. Apart from that, of course, it's open source, so it's free to download and to use. You can just go to the official website and download it in a matter of minutes. Then, of course, it is scalable as well, right? It can handle almost any amount of data, right? It supports large databases up to as much as 50 million rows or more, right? That's the amount of data that you can store in MySQL. And the default size limit is about 4 GB, if I'm not wrong. And you can also increase this number to a theoretical limit of around 8 TB of data. I think you'll have to pay a little bit of money for that, but I feel like 4 GB is a lot, first of all, to have a data set of that size. Then another important point is that MySQL follows a client-server architecture. So this is where you basically have your database server, which is your MySQL, and you have many applications and programs as your clients, right? And these communicate with the server. This is where they query data, they save changes, they update the data and all of that. Not only this, MySQL is compatible on many operating systems. It is easy to run on a lot of operating systems such as Windows, Linux, Unix, and so on. Now, MySQL actually provides a functionality that the clients can run on the same computer as the server, or they can even run on another computer. So basically, communication via a local network or the internet. Another important point is that there are quite a number of APIs and libraries for the development of MySQL applications. So basically, it has support for multiple programming interfaces, right? So client programming, you can use languages like C, C++, Java, Perl, PHP, Python, and so on. Right? All these languages are easily compatible. They provide APIs so that you can integrate and you can perform or you can build applications using these languages. And since Python is one of the best languages for data science, MySQL is perfect for data analysis, storing data, and querying data. You can easily work with MySQL and Python to build applications and query data and all of that. Right? Apart from that, it is also customizable, like I said, and it's also platform independent. Right? It's not only your client applications that can run under a variety of operating systems, but MySQL itself can be executed under a number of operating systems. The most important ones are your Mac operating systems, Linux, Microsoft Windows, and so on. Apart from that, we also have speed, right? MySQL is considered a very fast database program. And this speed is actually being backed up by a large number of benchmark tests. And apart from that, it's highly productive because it uses triggers, it uses stored procedures and views. And this basically allows the developer to give a higher productivity. So these are a few reasons why you should go with MySQL, right? I feel it's one of the most easiest to use and it's one of the most compatible databases that are there. Now let's move on and discuss a couple of basics about MySQL. So we'll discuss the data types which come under MySQL. We have numeric, we have character string, we have bit string, boolean, date and time, and timestamp and interval. Right? Under numeric, it includes integers of various sizes. There is a floating point of various precisions and formatted numbers. Under character strings, these data types either have a fixed or they have a varying number of characters. Now, this data type also has a variable length string, which is called character large object, which is used to specify columns that have large text values. So it supports large text values as well. Apart from that, there is bit string. Now, these data types are either of a fixed length or varying length of bits. Now, there is also a variable length bit string data type, which is called binary large object. Now, this is available to specify columns that have very large binary values, such as, maybe images and so on. Then we have the Boolean data type. Now, this data type, as the name suggests itself, it has true or false values. And since SQL has null values, a 3-valued logic is used, which is unknown. That's the third value. Then we have date and time. So the date and time is like any other date variable. The date data type has year, month, and day in the normal date form. And similarly, the time data type has components like hour, minute, and second. Now, obviously, these formats can be changed based on your requirement. Next, we have the timestamp and interval data type. So the timestamp data type includes a minimum of 6 positions for decimal fractions of seconds and an optional with time zone qualifier in addition to your date and time fields. Right, so the interval data type will basically mention a relative value that can later be used to increment or decrement an absolute value of time or date or any of that sort, or basically a timestamp. Right, so you can increment or decrement any absolute value using the interval data type. So guys, this was a little bit information about the different data types that are there. Now let's discuss a little bit of basics of SQL. Like I said, I'm just going to brush up a couple of topics because I'm hoping that you all have a good understanding of the querying language. So let's just brush up a little bit. So first of all, we have the first command, which is create database. Now, this is a very general purpose command, right? It basically creates a new database for you. So the syntax is just create database and the name of your database. Then once you create it, in order to initialize and use it, you just use the command use and the name of the database that you created. And remember that at the end of each command, you have a terminator, which is a semicolon. And also your commands are usually written in capital letters so that you can differentiate your commands from your table columns or table names and all of that. So it's a good practice if you write all your commands in capital letters. Next, we have create table. Now, tables are the most important part of a database. Right, so create table is a simple command that will create a new table for you, and it can contain a lot of data variables of different data types. Right, so the syntax is simple. The command is create table, the name of the table you want to create, and then within the table, whatever variables you want, you can mention the name of the variables with their respective data types. Like for example, if your variable is age, then your data type will be an integer or something like that. Similarly, you can add another variable like name, and you can have the data type as a character. So it's as simple as that. It's very understandable, the language. And then let's talk about insert into. Now, this command is used to insert new data into your table. Now, usually what happens is when people insert values into the table, they forget the data type that they've defined under that particular variable. So remember that the values that are inserted must align with the defined data types. So for example, if your variable is age, and instead of putting your numerical 3, you've put your character 3. Basically, you've typed out 𝐻REE. Right? That's not going to work because you already defined your age variable as integer. So you'll get an error there. So make sure that the values that you're inserting into your variable are of the same data type as you've defined your variable as. Okay, so make sure that happens. Now, these are very simple things, guys. I'm sure you guys are aware of this. Now let's look at our next command, which is select. So this is one of the most important commands when it comes to SQL for data science. And because mainly it's all about extracting useful insights and extracting particular type of data from your database. Right? We'll see how often we'll use this command when we perform our demo today. This is one of the most simplest, and in fact, it's one of the most important commands in SQL. Okay. So basically select will select a specified table or a column, and it'll extract the values from it. Okay, so select star from and table name is your syntax. Now we'll be using this in the demo, so don't worry if you do not know exactly what this does. Just remember that your select command is for extracting data from your table. Next, we have the update command. So update will basically allow you to modify any values that are stored in your table. And the where clause here will select the variable or value that you want to change. So it's basically it'll highlight the variable or the value, or it'll try to identify the value that you want to change. Next, we have the delete command. Now delete will basically delete data from your data set or from your table, as the name itself suggests. So delete from the name of your table and where with a condition. It's as simple as that. Next, we have a drop table. So this command is basically used to delete a table and all the rows in the table. So your table will get deleted from your database. That's what happens with drop table. These were a couple of commands that I thought you should brush up on. I'm sure you guys are already aware of these commands. But in case there are a few of you who don't know much about SQL, I'll leave a couple of links in the description box. You can go through those videos and then maybe come back to this if you're specifically looking for SQL for data science. Now let's get started with our demo, which is quite interesting. So guys, for this demo, I'll be using the MySQL workbench. So it's quite easy to install. It'll just take like 15 to 20 minutes. I'll leave a link in the description box. We have a short video wherein we're showing you how to install the whole workbench. So once you've installed MySQL, we'll start by creating a database and we'll import a data set into our workbench. So I'm going to import a existing data set, right? I'm doing this because we are doing a more advanced tutorial. This is not about creating tables and extracting values from tables. Instead, this is about deriving useful insight from your data. So usually for data science, you don't have to sit down and create tables and do those basic commands. Instead, you have to explore the data variables. So usually there's a humongous data set that needs to be explored and analyzed in order to derive something useful from it. Right, so that's what we're going to do today. So I've already imported a CSV file. Let me show you what the file looks like. Right, so this is our CSV file, and this basically contains details about employees. So basically the name of the employee, title is the job title of the employee, department is the department that the employee is working in. Then we have the annual salary, we have the hiring date, we have the start date in the present position, we have the salary, and we have the employment category, whether you're full-time employee or whether you're part-time employee. So our data set has around 32,000 observations, right? So this is a very huge data set, and I basically downloaded from the internet. You can find a lot of data sets on the internet and you can perform all of the data analysis in no time. So if you don't know how to import a data set in your MySQL workbench, then I'll quickly show you how it's done. So I've already created a database here. Now creating a database is as simple as this, right? You just have to do create database and name of the database. Let's say tutorial. And then if you want to use it, you just use the command use tutorial, right? So basically tutorial database gets activated. Now all you have to do to run is you have to use this, right? Use tutorial. So we've basically activated our database. Now for this tutorial, I've already created a database. So I'm going to use that database itself. Name of my database is students, right? So let's activate this database, right? Now in this, I have a couple of tables and we are going to be focusing on this table, employee details. So this is the table that I imported. So guys, for those of you who don't know how to import a CSV file into your MySQL workbench, all you have to do is go to tables, right click on any table and go to table data import wizard, right? Click on this and browse for your CSV file. Okay. Just to take an example, I'll consider this CSV file. I'm not going to import the CSV file that we're going to be using right now because that is a very, very huge CSV file and it'll take a lot of time for me to import that CSV file into the workbench. To save up on some time, I'll import a small CSV file and I'll show you all. Right, so I'm selecting this file, students marks. Let's open it, right, and go to next. After that, create a new table. Now, basically what you're doing here is you're going to create a new table that corresponds to all the columns that are there in your CSV file. Either you can create a table on your own and click on use existing table, or you can allow MySQL Workbench itself to create a new table for you. That's what I'm going to do because obviously it's simpler. Then click on next. So this is basically all the fields that are there in my CSV file. It'll collect all the fields in my CSV file and it'll create a table out of it, right? This is my CSV file. Basically, it has name, gender, date of birth, math, physics, chemistry, and all of that. These are just records of students and their marks. Then if I click on next and next again, yeah, data gets imported. Next, 5 records are imported. Click on finish and refresh. Here you'll see student marks. So this was the CSV file that I just imported into MySQL Workbench. So guys, that's how you import a CSV file as a table into your MySQL Workbench. So if you want to see this table, right, the CSV file that we imported as a table, all you have to do is select star from and the name of the table. It is student underscore marks. So let's just run this. So here you can basically see the entire CSV file that we imported into a table. So guys, that's how simple it is to import a CSV file into your MySQL Workbench in order to perform data analysis. So now let's clear this up. So for this demo, like I said, we'll be using employee details dataset. This is a very huge dataset and let's just get started. I've already imported the dataset here as a table, right? If you take a look at this employee details, so these are the columns in my table. We have name of the employee, title is the job title of the employee, department is the department he works in, salary, annual salary, then we have hiring date, start date, salary basics, and we have employment category. All right, so let's start by performing some sort of data analysis. So first what we'll do is let's just view the entire table that we have. For that, all you have to do is select star from the name of the table. Employee details is the name of the table in my case. So I'll just run this command, right? So this is the entire table that just got loaded, right? So this will just extract your entire table for you. Since I did select star from and name of the table, so my entire table is extracted here, right? If you take a look at this, the whole table is being extracted here, right? Now let's do something a little more complex. Now let's write a query to find the salaries of all the employees. For that, what you have to do is select again. Now name of the column that has the salary. Okay, in our case, it is salary annual, right? So let's write that down. Salary annual, right? from the name of your table, employee details. Okay, so let's run this. So this query basically just gave me the salary column in my table, right? Salary annual. This is the salary of all the employees that are there, right? It's as simple as that. Now let's write a query to display the unique designations for the employees. Basically, unique job roles we'll display. So for that, again, we have select because we're extracting. Then we have a keyword called distinct. Since we are trying to display the unique designations, it'll just take the designations that are unique. It won't take your repetitive designations. For example, there might be 10 employees who are working as data analysts. So we'll just consider that as one. So we're just extracting the unique designations for the employees. That's why we have the word distinct here. Next, our job title is in the variable title. So that's why I've written title here. And then we have from and the name of your table. Right. Let's run this command. So here you can see that there are different job titles in our data set. We have sergeant, we have police officer, we have chief contractor, expeditor, we have civil engineer, concrete laborer, we have traffic controller, pool motor. This is police officer and this is police officer assigned as detective. Wow, that's interesting. Right, so basically this query gave us the unique job roles that are there in our data set. Now let's try something else. Let's write a query to display the unique departments with their jobs. So let's extract that. So select, again, since we're trying the unique, we are going to use the distinct keyword and we are going to extract the unique departments and the job titles and from the name of the table. So let's run this code. Now under police department, we have different job titles. That's why this is repeated here. Right? We have police officer, then there is fleet and facility management, under which we have a chief contractor as expeditor. Under water management department, we have a civil engineer and so on. Right? So guys, this query was pretty simple. It just gave us the distinct departments according to their job titles. Now let's perform another query. We'll write a query to list the employees who are working in a particular department. Let's say the fire department. Again, since we're extracting, we'll use the keyword select. After that, select star from and the name of your table. Where, so this is where the where clause comes. Right? We're trying to identify a particular department. So we'll put where department in the name of the department that we're looking for. Let's say fire department. That sounds interesting. So let's run this. All right. So here you can see that we've just got employee details of all the employees that are there in the fire department. These are their salaries. These are the dates that they were hired on. And apart from that, this is the employment category, full-time, part-time. Salary basis is whether you're getting paid hourly or whether you're getting paid on a daily basis. So these are the details of all the employees that are working in the fire department. If you see that here, it's entirely fire department. So that was also quite simple. So this is how SQL is. The language is very, very simple because it's pretty understandable. Like you can read the statement and you can understand what exactly I'm trying to extract or what exactly I'm trying to do. Next, let's try to do something interesting. Let's say that we want to write a query to list the employees who do not belong to a particular department. Let's say that we're trying to list out the employee details of employees which are not in the police department. So for that, it's quite similar to our previous query. So you'll write select star from name of your table again, where department not in. That's the only difference. Okay, not in, and the name of the department that you want to exclude. So this time, let's say police department. So we want only details of employees that are not there in the police department. So let's run this. So all the departments here will have everything apart from your police department. Okay, so we have fire, we have water management, we have law, we have streets and sand, we have finance department, we have fleet and facility management, and all of that. So basically, we excluded our police department and printed out the details of all the employees which are in every other department apart from the police. All right, so now let's write a query to list the employees who joined before a particular date. So for that, again, we'll start from select star from name of your table, right? And we'll add the where clause. And here we'll mention our original hiring date, since that's the name of the variable that has the hire dates in it. Let's keep it less than a particular date. Okay, let's choose 1st of January 2000. Let's run this code. And so when you run this code, you'll find all the employees that were hired before 2000. So if you see original hire date, all of this is before 2000. Some of them were in 1994, 1996, 1984, and 1987. So there are only 4 employees who were hired before the year 2000, basically before the 1st of January 2000. Now let's try another query. Let's write a query that will display the average salaries of all the employees who work at a particular department. Okay, let's choose the surgeon department. So basically, we're going to display the average salaries of all the employees who are working as surgeons. So for that, again, it starts from select. Since we have to calculate the average salaries, we'll use a function called average, which is a predefined function in SQL. And average of which column? It is a salary column. Salary annual. And let's mention the name of the table from employee detail some error. Let's write down the whole statement and then we'll see what the error is. This, and we're going to select the job title as a sergeant. So basically the average salary of a sergeant. Let's run this first and we'll find out what the error is. Okay, there is no error. I have no idea why I'm getting this. So the average salary is around 1,06,000 and change, right, for a sergeant. So now let's try another query. What we can do is we'll write a query to display the details of a particular employee. Some name we'll select at random. Okay, so select star from name of your table, employee details, where name is equal to, let's look for a particular name, 𝐓𝐻𝐵. Okay, so this is the name of the employee. Let's paste that name over here, right? Hopefully this should give us an output. Let's run this. So now we have the details of this particular employee, who is 𝐓𝐻𝐵, his title, job title, his department, his salary, all the details about him. So we just printed all the details about a particular employee. Now let's try something else. Let's write a query to list the employees whose salary is, let's say, more than 3,000 after giving a 25% increment to their salary. Now let's do a little bit of math. So we list down employees whose salary is more than 3,000 after giving them a 25% increment. So let's write down a query for that. So again, start off with select star from the name of your table, where here we'll specify the condition. Basically, after giving them a 25% increment, 1.25 into the salary. So salary annual, and after giving them a 25% increment, their salary should be at least 3,000. All right, so this is exactly what we're doing here. Let's run this code and let's see if we're getting anything. So here are the employees whose salary is more than $3,000 after giving them a 25% raise. So basically these guys are promoted. This is a list of all the employees. So that's quite simple, guys. It's basic math implemented in one line of code. That's how simple SQL is. A lot of data scientists require this kind of tool because querying even your complicated math and even complicated things from your database becomes very easy when you make use of SQL languages. It becomes extremely easy to even do the complex things. Now, I just did this in one line. So now let's try something else. Let's write a query to list the employees whose salary is less than a particular number. Okay, let's say less than $3,500. So let's write a query basically for employees whose salary is less than 3,000 or 3,500, where salary annual is less than, let's say, 3,500. So let's run this line of code. All right, so we have a couple of people whose salary is less than 3,000. So we have 2,756, like maximum of these people have 2,756. Okay, so basically this is a list of employees whose annual salary is less than $3,000. That's also quite simple to do. It's just one line of code. Now let's try something else. We'll write a query to list the names and a particular set of details about an employee who joined before a particular date. Let me write it down for you and then we'll understand what exactly I'm doing. So select. Okay, now we'll define a variable so that we can basically extract a number of columns. Okay, so let me write this down and then I'll tell you what exactly I did here. Name, and let's also get their salary, right? Original hiring date. Then we'll also get the salary. From the name of the table where the hiring date, let's say, was lesser than, I'll give a random number, 0102 2008. Now what exactly I'm doing here is I'm basically listing out the name of the employee, the hiring date, and the salary of all the employees that have joined before a particular date. Okay, basically before this date. That's what I've done here. Let's run this line of code and let's see if it works. Right. So here we have the name, the hiring date, and the salary of individuals that have joined before a particular date in 2008. So it's as simple as that. Now let's write a query in SQL to list all the employees who joined on a particular date. Okay, let's say we want the details of all the employees who joined on October of 2013 or something like that. For that, again, it starts off with select star from the name of the table. We'll add the where clause along with the hiring date, original hire date, a particular date, let's say 08 2013. Let's run this line of code. So basically we list down employees that were hired on this particular date. Okay, these are details of all the employees that were hired on the same day. So we have around 6 employees that were hired on the 8th of 2013, some date, right? So guys, that's what you see. SQL is a very easy language. You just have to understand what you're trying to extract. That's all. You just have to know like 5 to 10 basic commands. And these basic commands can do wonders. They can extract and manipulate data in such a way that, you can perform proper data analysis, data processing, and so on. Now let's try one last query. Let's write a query to list the employees whose annual salary is within a particular range. For this, again, we have select star from name of the table, employee details, and let's add the where clause. And here we will say salary annual is between is another keyword. So between two numbers. Okay, let's say between $24,000 and let's say 50,000. Right? Let's run this line of code. All right. So here you can see that all of these employees have a salary range between 25,000 and 50,000. So 43,201, we have 42,000, we have 44,000, we have 45,000, 48,000 is the maximum salary. All right. So this is basically how you perform querying using SQL.
What is PostgreSQL? Now, PostgreSQL is an open source object relational database system with a 30 plus years of active development in the industry. So basically, if you have to understand PostgreSQL, guys, PostgreSQL is basically a programming language, or maybe you can understand that, a language through which you can handle open source relational database systems and then handle databases. PostgreSQL is world's most advanced open source relational database. So guys, this is a really great topic to start learning about databases. So if I have to just define PostgreSQL for you, then you have to understand just 2 points over here, that it is open source and it is used for handling databases in the form of object relational database system. So the data present in the form of relational database, but yes, it is object oriented. That's where PostgreSQL comes into picture. Now, since PostgreSQL is so popular in the industry, next let's look into the features of PostgreSQL. So the features of PostgreSQL are, as you can see on my screen, that is basically the data types, the data integrity, performance, reliability, security, and extensibility. So talking about data types, when I say data types, what I mean by that is PostgreSQL provides various kinds of data types to store data in any format, such as, integer, numeric, data type, JSON, XML file, maybe in the form also of point, line, circle, polygon, and also you can have custom data types. So there are various kind of data types like, the primitive one, the structure, the document, geometry, and customizations. So we'll not get into the depth of, the different data types related to PostgreSQL. You can go to their official document and check what are the different data types that, PostgreSQL provides. Well, I would leave that to you. Moving on to the next feature, data integrity. So when I say data integrity, what I mean by that is, your data is secured. So basically, whatever data that you have, it's made sure that, there's no redundancy, and then it's stored in the proper format with the help of, various constraints and keys used in databases like primary key, foreign keys, exclusion constraints, unique constraints, explicit locks, and so on, right? So that's how basically your data integrity is met. Coming to the next feature, that is performance. Now, performance is something that's very important to all of us, right? Because all of us want a good performance for any action that we do in industry basis, right? Now, since PostgreSQL meets with good performance standard, that clearly implies that, it has been used for more than 30 plus years of active development. Now, to enable performance in PostgreSQL, we have various features like, indexing, or maybe sophisticated query planner, multi-version concurrency control, table partitioning, just-in-time compilation of expressions, and so on. Now, moving on to the next feature, that is reliability. Now, PostgreSQL also proves itself in the factor of reliability. That is because, it has various functionalities like write-ahead logging, replication, point-in-time recovery, active standbys, and table spaces. Finally, coming to extensibility. Now, obviously, any database that you wish to use, you would obviously want to extend it to maybe any application that you might be using in the industry or maybe in your company, or also on an individual basis. Well, PostgreSQL provides all those functionalities with the help of stored functions in procedural language, foreign data wrappers, and many extensions that you'll see further in the session. So guys, these were the main 6 features of PostgreSQL, that is data types, data integrity, performance, reliability, security, and extensibility. So now that you know what is PostgreSQL, let's next look into how you can install PostgreSQL. So what I'm going to do is I'm going to install PostgreSQL on Windows. So apart from that, if you want to install PostgreSQL on any other operating system, well, the steps are really simple and the steps are almost same. So let's get started by installing PostgreSQL. So what I'm going to do is, let me open my Google Chrome, and then let's say I just type in PostgreSQL download, right? So once I type in, you have to first go to the official website of theirs, that is postgresql.org/download. So this is where basically you'll have to go to first start installing PostgreSQL. So what I'm going to do is basically I have to install on Windows, right? So over here, you have to start choosing your operating system. So if you wish to install on Linux, like let's say, Ubuntu, then you would choose this option. But since I'm going to install on Windows, I'm going to simply choose this particular option. So if I click on Windows over here, you'll be next redirected to this particular page. Now this is the page. Basically you have to install the installer, right? So basically every operating system that you choose, the official website of PostgreSQL will redirect you to a particular page which will have this particular installer. So over here you can see that I have the Windows installer, and then I have to install, and then you can see the platform support, right? So what I'm going to do is I'm going to just click on this option, download the installer. Now, once I click on download the installer, this is where basically you have to choose your configuration, right? So either it is Linux or Windows or Mac OS, that's completely your choice on what operating system that you wish to choose. Since I've been installing on Windows, I'll choose Windows 64-bit, right? So I'm going to choose this particular option of download. And please remember the fact that, try to install the most latest version so that you can get the maximum features that you want. So I'm going to install the 11.4 version for Windows 64-bit, right? So I'm going to just click on download over here. And then you see that, you'll be redirected to this particular page that, thank you for downloading PostgreSQL. And also on the left hand side, you'll see that, PostgreSQL is getting downloaded, right? So let's wait for it to download. All right. So as you can see on my screen, it has got downloaded. So I'll just double click it so that we can open. Now, once you double click on the setup, you'll see that, this particular dialog box opens, which says, welcome to PostgreSQL Setup Wizard, right? So now you just have to click on next, and then you have to choose the installation directory. I'm going to let it be as it is. So by default, -C, program files, PostgreSQL and 11. So that will be basically my installation directory. And then I'll click on next. Once I click on next, you'll get an option basically on the various components that you wish to install. Well, I wish to install all of them. So basically I'm installing the server, the pgadmin, the stack builder, and the command line tools. So now over here, let me tell you that, the pgadmin is the official GUI for PostgreSQL. So we'll be working on the GUI for this particular session. So I'm going to just let it be as it is since all of them are checked in, and then I'll click on next. Once I click on next, I have to next choose the directory under which I'll basically store my data, right? So this is basically my data directory, that is C, program files, PostgreSQL, 11 data. So I'm going to let it be as it is, and then I'll click on next. Once I click on next, I have to mention my password for the database super users. So just mention the password, any password that you wish to. And please remember the fact that, you have to remember this password to configure your server, right? So do not forget this password, and please make sure that you remember this password. After that, just click on next again, and then you have to select the port number. So I'm going to let it be as it is. So basically my server will run on the port 5032, and then I'll click on next. Once I click on next, you'll see that, I can choose the default local to be used by the new database cluster. So I'm going to let it be as it is, and then I'm going to click on next. Once I click on next, you'll see that, basically the following setting will be used for installation. That is basically whatever you have selected till now will be shown over there. That is the installation directory, the server installation directory, the data directory, the database port, the database super user, and so on, right? And then I'll click on next over here again. And now you'll see a confirmation that, the setup is now ready to begin installing PostgreSQL on your computer. If you're fine with it, you can just click on next. Else you can just go back, make the changes, and then again come back to this particular dialog box, right? So I'm fine with it. So I'll just click on next over here, and then you'll see that, PostgreSQL is getting installed on my system. So let's wait for it to install. All right, now once the installation is done, you get a confirmation wizard that, the setup is finished installing PostgreSQL on your computer, right? So you can just click on finish. And then if you want to launch the stack builder at your exit, you can just check in this box. Well, I'll just uncheck this particular box, and then I'll click on finish. Once I click on finish, basically guys, your installation is done. Now, if you search for PostgreSQL on your system, you'll clearly see options of the various stuff that we have installed, right? So as you can see on my screen, we have pgadmin, we have the SQL shell, we have the documentation, the pgadmin documentation, the release notes, and so on, right? So what I'm going to do is I'm going to open the SQL shell and also the pgadmin. So let me just open. All right. Now, once you open the pgadmin, you basically are asked for the master password. So if you remember, while installing, I asked you to enter a password, right? So that's basically the password that you have to mention over here. So I'll just mention my password, right? Now, once the password is entered, you'll clearly see that, we have a server, and then automatically the server gets connected to databases and the super user database, that is Postgres, right? Under this particular database, what we're going to do is we're going to basically use the different commands, that is the different SQL command categories. And then we're going to create a schema, table, and then we're going to choose how we can play around with databases, right? So on the SQL shell, what you can do is you can again similarly connect to the server. So you just basically have to click on enter because you're connecting your server on the local host. So I'll just click on enter. That the database, basically the super user database is Postgres. So I'll click on enter again. The port has to be the same, that is 5432. I'll click on enter again. The username will be Postgres. So I'll just click on enter again. And password is basically what password you mentioned while installing, right? So you'll mention the same password and then you'll see that, once you hit on enter, you'll clearly see that you've been redirected to Postgres. So basically that's how, guys, you can configure server either on the PG admin and also on the SQL shell. So guys, that was about installation of PostgreSQL on Windows. I hope you've understood all the steps. So now that you've installed PostgreSQL on your system, next let's look into the SQL command categories. So as I said, there are mainly 4 command categories. That is the data definition language commands, the data manipulation language commands, the data control language commands, and the transaction control language commands, right? So basically, guys, these are the main 4 command categories of SQL. That is the DDL commands, the DML commands, the DCL commands, and the TCL commands. The DDL commands basically consist of the commands which can be used to define your schema, right? So you can create a table, you can create a schema, you can create a view, and so on. Right, so basically all those commands which define the database of the schema, basically how your data has to be represented and what would be the various tables, or maybe let's say which table will be related to other table and so on, will be all under this particular section. That is the data definition language commands. Coming to data manipulation language commands, the DML commands basically consist of those commands which deal with the manipulation of data present in the database. So all the manipulation that you'll do in your databases will be with the help of the data manipulation language commands. Coming to the data control language commands, the data control language commands basically includes those commands which deal with the rights, permissions, and other controls of the database system, like, which database has to be granted to any specific user, or maybe that particular database will be open to public, and so on. And finally, coming to transaction control language commands. So the transaction control language commands basically include those commands which mainly deal with the transaction of the database. So guys, these are mainly the 4 different command categories, that is the DDL, DML, DCL, and TCL. So without wasting any further time, let's look into the DDL commands. Now what I'm going to do is I'm going to show you how you can write commands on the SQL shell, and then I'm going to use the PG admin, right? So it's really simple. PG admin is the GUI for PostgreSQL. In today's market, in industries, people are mostly using PG admin because they can connect this particular database to various other external tools also, so that they can manipulate the data and maybe they can generate reports and so on, right? So I'm going to initially show you on SQL shell for few commands, and then I'll completely shift over to the GUI. So now let's say you want to create a schema. How do you think you can create a schema? Well, the command is really simple. For that, you'll have to use create, right? So what you'll do is basically you'll type in create schema, and let's say we mentioned the schema name to be information, right? Right, so I'm going to use caps so that you understand that that's the particular syntax, and the small case letters to understand that's the name that I'm giving, and that's completely your choice on how you wish to do. And then I'll end with a semicolon and click on enter. Once I click on enter, you'll see an output that create schema. That means a schema has been created. Now if I go back to my PG admin and then let's say I just refresh over here, so automatically you'll see a schema that is information, right? So basically whatever I've created in SQL shell is automatically seen in PG admin, right? So that's the reason I told you it's easy to visualize and use GUI over here. Now similarly, if you wish to create a new schema over here, what you can do is you have the schema option, right? You right click over here, choose create, and choose create schema. Automatically you just have to mention the name. Let's say I mentioned sample, and then I'll leave the other details to be the same, that is security, default privileges, and SQL, right? So in SQL you'll basically see that the syntax that I just mentioned in the SQL shell, that is create schema and then schema name, and authorization Postgres. That's basically our database super user. Well, that's by default in SQL shell because we are already under Postgres. So that's the reason we didn't have to give it over there. So I'll just click on save. And then once I click on save, you'll automatically see that a schema has been created, that is basically sample. So now I have the information schema, the public schema, and the sample schema. Now the public schema is created by default, and the information was the one that I created in SQL shell, and the sample is the one I created in GUI. So you see, right, how simple it is. Now, if you're getting confused how you can write queries in GUI, well, don't worry, we have a query tool also. So if I right click over here and then if I choose query tool, you'll see that, automatically you'll get a workspace where you can basically put all your queries. I'm not going to do that. Now, next what I'll do is, let's say, we want to use this particular schema. So what I'll do is I'll just type in the query set search path to, and then I'll mention the schema name, right? So I'll mention information over here. So automatically you'll see an output that, it is set to information, right? So whatever actions that I wish to perform, like, creating tables or maybe views and all of them will be basically under this particular schema. Now, once the path is set, let's say, we want to create a table, right? So for that, you'll type in create table, and then you'll mention this table name. So let's say I'll mention students. And now each student will basically have various attributes, right? For example, let's say I'm a student. Now I'll have a name, I have an age, I have a date of birth, and so on. So basically all those values will be a column. So I'll just put it in brackets, and let's say I mention student ID and int to be data type. And let's say further I again mention student name, and then let the data type be varchar 255 characters, right? And then what I'll do is I'll put a semicolon at the end. Once I click over here, once I click on enter, you'll clearly see an output that, create table. Now let's go back over here, and then let's just basically refresh the schemas, right? So I'll just refresh the schemas. And under the information table, you'll clearly see an output that, we have a table students, and then it has columns student ID and student name. So basically that's how you can create a table basically on the SQL shell, guys. Now, if you wish to create a table in the PG admin, what you do is you right click on the table over here, go to create, choose table, and then basically you have to mention the name, right? So for example, let's say we mention the table name to be teachers, and then the owner to be Postgres, the schema to be information. So you'll have to basically choose the schema under which you wish to create the table, and then you click on save. So if you click on save without choosing the columns, then remember that, this particular table will have no columns. So if you wish to add columns, you can just add column over here. For example, let's say I wish to add column, right? So I'll go to plus button over here, choose the names. Let's say, teacher ID. Let's say data type to be int, right? And then, not null primary key and all, I'll come later on this session, right? So I'll click on save over here. So once I click on save, you'll see that, automatically a teacher's table will be created with a single column, that is teacher ID. So guys, that's how basically you can create tables in the SQL shell and PG admin. Now, before I move forward and show you the various other commands related to DDL, let me cover a concept known as entity relationship diagram. Now, this particular concept is important over here because, you have to understand how to create tables and how you have to relate those tables to the other tables, and basically what will be the column values for this particular table. So as you can see on my screen, guys, this is the example for entity relationship diagram that I'm going to consider for this particular session. Now, based on this particular diagram only, I'm going to basically take forward my session to show you the different commands also. Now, entity relationship diagram basically is a simple diagram through which you can understand the various relationships between two different tables or two or more tables, right? For example, let's say, we have this particular entity relationship diagram, right? Now, over here, we have employee, department, project, and dependent over here. Now, all the rectangular boxes on this particular screen will represent entities. Now, what I mean by entities is basically that, for example, let's say I'm a person, right? Now, I have a name. Now, my name, my age, my phone number, my date of birth, my address, all these are basically my attributes, right? And I, as a person, can be uniquely identified with the help of these particular attributes, right? So whatever can be uniquely identified with the help of attributes is basically entity, right? So I am an entity. So for example, I'm Sahiti, right? So my name, my age, my date of birth, all of these will be attributes through which anybody can identify me as Sahiti. Right? So over here, any employee can be uniquely identified with the help of an SSN, that is basically a social security number, or you can simply understand as ID. Name. Now, name further can have the first name, the last name, and the middle name. Now, address, salary, and sex, right? So basically, all these attributes can uniquely identify an employee, right? So employee over here is an entity, and all these particular attributes are basically the factors through which you can identify. So when you build a relational database management system, what happens is that employee will become the table name, and all these particular values, that is basically the attribute values, will be the column names, right? So you'll have a column name with SSN, birth date, first name, middle name, last name, address, salary, and sex, right? So all this basically will be your column names, and then employee will be your table name. Now, similar is the case with the other factors also. For example, if you take department, now a department can be uniquely identified with number and name, right? So these two will be attributes, and the locations is basically a multi-valued attribute. Now, when I say multi-valued attribute, what I mean by that is an attribute can have various factors, right? For example, let's say location. What will be your address? You can have so much of street, let's say, 5th Street, 4th Cross Road, and let's say Queens Road, right? So this could be basically your location, right? Now this has various attributes, like, maybe you can have 5th Street, like the streets can be put into one value, and maybe the Queens Road, basically the main locality, can be another value, right? So basically it's a multi-valued attribute. That's what basically double ellipsis means. Apart from that, also please remember that even this particular attribute will be included into the columns part. So you'll have a department table with the department number and department name as columns. Now, apart from that, next, let's look into project. Now, project is again another entity, right? So every project can be again uniquely be identified with the project number and the project name and the location, right? Now, over here, the project number and the project name will be unique for each and every project. So that is the reason for every entity, for this particular entity, these two attributes are very important over here, because every project can be uniquely identified with the project number and the project name. And finally, coming to dependent. Now, you must be wondering over here, why does the dependent entity have two rectangles, right? That is because it is a weak entity. What I mean by weak entity is basically that the dependent entity is basically dependent on the employee entity, right? For example, let's say I as an employee, right? So I'm an employee, and then maybe I'm going for an insurance, right? And then I have a health insurance and my next nominee, let's say, is my sister. So what happens over here is basically that this particular entity is dependent on the employee entity. My details will be basically taken from the employee entity, right? So for example, let's say I am an employee, then all my details will be taken from the employee entity, right? So that is the reason basically the dependent entity is completely dependent on the employed entity. So that's what you have to understand over here. When I say weak entity, you have to understand that it is dependent on any other particular entity, right? Now over here, I hope you understood what is entities and what is attributes. Next, if you look into the diagram, we have various other factors like these diamonds, and then we have double lines, we have single lines, and so on, right? So let's look into what they are. So coming to diamonds over here, when I say diamond, what I mean by that is basically the relationship set. So what is relationship set? So if you have to understand this, then you can understand that employees are related to every department, right? So if you take your company, any number of employees, like more than one instance of the entity is basically associated with one instance of the department, right? So in simple terms, if you just have to understand it, like let's say 10 employees are working in one particular department, let's say IT department. So that's how basically you can understand this. Now coming to the next relationship, that is managers. Now there's a relationship between employees and department also, right? So there's a department, and then there's a manager for each and every department, right? So now not all employees are managers for the departments, right? So it could happen that only one instance of the employee entity is basically associated with one instance of the department entity, right? So let's say we have the IT department. Now the IT department can basically have only one manager, the HR department can have only one manager, and so on, right? So basically all of them are also employees, right? So that is the reason there's a relationship between employees and department over here. Now coming to the next relationship, that is works on. Now it is obvious to the fact that all the employees must be working on some or the other projects, right? For example, let's say we can have 10 employees working on 2 projects, or maybe the same number of employees working on some other projects also, right? It's never that in industry that a single employee is working only on single project and not more than one project, right? So in this particular relationship, that is the reason we have M:(n). Basically by that, what I mean that more than one instance of the entity employee is basically associated with more than one instance of the other entity, that is the projects entity, right? So that is because any number of employees can work on any number of projects. Similarly, let's look into the next relationship, that is dependence of. What I see in the relationship of dependence of is basically 1:n. That is because, one employee can have any number of insurance, right? You can have a life insurance and so on. So that is the reason basically you have 1:n relationship, and then you have the relationship of dependence of, because your dependence entity is completely dependent on the employee entity. And finally, coming to self-referencing relationship over here. What I mean by self-referencing relationship is basically basically that, for example, let's say you have a boss, right? Now your boss can handle 10 people, right? So basically he's your supervisor and then he supervises 10 people, right? And he himself is also an employee and all the 10 people are also employees, right? So that is where this particular relationship comes into picture. That is 1:n, right? So one instance of the employee where employee is basically a supervisor can supervise more than one instance of the other employees, right? So basically that's how it happens. You basically have different relationships like this, guys. If I have to just summarize the different relationships, then you have 1:1, 1:n, n:1, m:n, right? And then you also have self-referencing relationships. So if you have to talk in technical terms, then you have one-to-one relationship, one-to-many relationship, many-to-one relationship, and many-to-many relationship. Apart from that, we also have the self-referencing relationship that I just spoke about. Now, if you observe the complete entity relationship diagram over here, so I hope you've understood how entities, attributes, and relationship works in the databases, right? Now let's look into the double lines over here. What do you think the double lines mean? What I mean by total participation is basically that, each entity in the entity set must at least have one relationship in the relationship set. So basically each entity in the employee must work in some or the other department, right? So that is the reason we basically have total participation over here. Moving on to the next relationship, you can see that, it's not necessary that every employee manages some or the other person, right? So that is the reason we don't have total participation on this particular side. But yes, every department has a boss, right? So every department has a manager. So that's the reason we have total participation on this particular side. That is from managers to department. Moving on to the next relationship, that is basically employees to project. If you see, every employee has to work on some or the other project, right? So that is the reason we have total participation on both the sides, that, every employee basically will be working on something or the other thing, and every project will have a set of employees working on it, right? So that is the reason we have total participation over here. Coming to the next relationship, you can clearly see that, that the dependents are basically completely dependent on employees. So it's the total participation towards from the dependent side and not from the employee side, because it can happen that maybe an employee doesn't have some insurance, or maybe an employee doesn't have any insurance, right? So in that scenario, what basically happens is that you don't have total participation over here, but you have total participation on this particular side. And now finally coming to this particular relationship, if you observe over here, we do not have any total participation. That's because, it's not necessary that every person in the employee table, basically every person in the company should be a supervisor of somebody, right? It's not necessary like that. Maybe a fresher is just not a supervisor. So in that scenario, basically total participation will not hold true. So that is basically, guys, how you can build up an entity relationship diagram for the scenario that you have. I took a company database where, you have various entities like employees, department, dependent, projects, and then they are related to each other in some way or the other, and each of these entities have various attributes. So remember the fact that when you build a relational database, you have entities which will basically become your tables, then you have attributes, so your attributes will basically become your column names, and then you have relationships. So guys, this was all about entity relationship diagrams. You basically have entities, attributes, and then relationships, right? So I hope you've understood how my ER diagram looks like. Now, as I was talking about different kinds of attributes, let me next take you through what are the different kinds of attributes that you see. So you must have observed, right? We had multi-valued attributes, we had derived attributes, and then we have complex attributes and composite attributes. So basically there are various attributes like, composite, simple, single, multi-valued, stored, derived, and complex attributes. So let's look into each one of them one by one. So talking about composite and simple attributes, guys, if you remember the entity relationship diagram I showed you, I told you that the name can have first name, last name, and middle name. The first name, last name, middle name will basically be my simple attributes, and the name altogether will be my complex attribute. So basically, if I have to define in single terms, then a composite attributes can be divided into smaller subparts, and these subparts can represent individual basic attributes with their own meaning. For example, let's say we have address, right? Now, address can have street address, city, state, zip, and street address can be further divided into number, street, and house number. Now, city, state, zip, number, street, and house number will basically be your simple attributes. So this was about composite and simple, guys. Now let's move forward with the next type of attributes, that is single and multi-valued. Now, attributes having a single value for a particular entity are known as single valued attributes, and a multi-valued attribute may have lower and upper bounds to constrain the number of values allowed for each individual entity. So you can have a single attribute and a multi-attribute in an entity. And I forgot to tell you one thing over here. Every entity is uniquely identified, right? So as I told you, employee had SSN, that is the social security number. Now that is basically uniquely identified, right? So that is the SSN. So over here, that will be basically a unique attribute through which the complete table will be identified. Next, let's move forward with the next type of attribute, that is stored versus derived. So the attributes which are derived from the real entities are known as derived attributes, and the stored attributes are the attributes which are already stored in the database and from which the value of another attribute is derived. So basically, if you consider age, from age you can derive birth date, right? And from birthday you can derive age, right? So I'm not saying in the matter of exact birthday, you can, like, let's say you're 23 years. So you can derive the fact, the birthday could be either in 95, 96. And if, the year born is 95, 96, then automatically you can derive an age that, the age could be 23 years, right? So that's how basically you can understand stored and derived attribute. And finally, coming to complex attributes, the attributes that can be represented by grouping composite attributes between, brackets, by separating the components with commas, and by displaying multi-valued attributes with square brackets are known as complex attributes, right? So basically an address can have phone number, and then the phone can have again like area code and phone numbers. And then moving forward, we can have again address, and maybe address can again have street address, number, street, flat number, state, zip code, and so on. So basically this is how you can define complex attributes, guys. So guys, that was about entity relationship diagram. So I hope you've understood how entities work, how attributes work, how a table name can be found, and how columns are formed, and how each table can be related to the other table, because this concept is really important to understand, so that you understand the further concepts like, the keys in databases and the constraints used. Now, before I wrap up this entity relationship diagram, let me just shift back to my PG admin and show you the simple commands of DDL, like, the create, truncate, alter, and so on. So for example, let's say, you want to truncate the table, right? So when I say truncate, what I mean by that is you basically delete all the data present in the table, but you do not delete the table itself. Now, since we haven't added any data into the table, I'll just show you the syntax so that you can understand. So let's say, you want to truncate table students, right? So for that, what you'll do is you'll type in truncate table, and then you'll mention students, right? And then you'll execute, right? Once you execute, you'll see the output that, truncate table, the query has been returned successfully. Now, since we have no data is present, you cannot see any particular output. But if you had any data present in the table, you would see that, all the data would be removed from the table. Now, let's say, you want to rename the table. Let's say you want to rename the table students to, let's say, info students, right? So to rename the students, you basically have to use two DDL statements, that is alter table and rename, right? So for that, what you'll do is you'll type in alter table, and then you'll mention the original name, that is students, and then you wish to rename, right? So you'll type in rename to, and then you'll mention the new name, that is info students, right? And then you'll execute. Once you execute, you'll see that, alter table, the query has been returned successfully. So what I'll do is I'll just refresh this particular schema, and then you'll automatically see that, we see an output of info students, right? So that means our table has been renamed. Now, for example, let's say, we want to add a new column. So for that, again, you'll use the alter statement. So I'll just type in alter table, and then I'll mention the table name, that is info students. And then what you'll do is you'll mention add, and then you'll mention the column name, that is, let's say, date of birth, and then the data type of it, let's say date, right? And then you'll end with semicolon, and then you'll execute. Once you execute, you'll see that, the query has been returned successfully. So if I just refresh this part again, and you'll see automatically that, a new column has been added onto the table, that is date of birth. So this was just for a single column, guys. Now you can add multiple columns also. So for example, let's say I want to add two more columns, right? So what I'll do is I'll just remove this. Let's say, I want to add gender. So I'll just mention sex, character, and again, comma, and add, let's say, class. Okay, class is a keyword, so I'll mention standard, and then integer, right? And then I'll again execute. Once I execute, I'll again refresh. And when I refresh, you'll see that, automatically my sex and standard, so basically the gender, date of birth, and standard have been added as new columns, right? So that's how basically you can add a single column, or you can add multiple columns. Now you can also alter the data type of the particular column. For example, I want the data type of the standard column to be changed to, let's say, character. So for that, what you'll do is you'll basically mention alter table info students, that is basically the table name. And then what you'll do is you'll mention alter column, and then you'll mention the column name, that is basically standard, and then you'll mention the keyword type, and let's say we mention character, and then I'll execute. And now once I execute, and then if I show you the properties of this particular column, you'll automatically see that the data type is character, right? So basically guys, that's how you can also alter a particular table or maybe column, maybe if you want to rename and all. Now let's say you want to drop this particular column. So for that, what you do is you type in alter table, mention the table name again, and then what you do is you mention the keyword drop column, and then you mention the column name, right? And then you just execute. Now once you execute, and let's say if I refresh this, you'll clearly see an output that your standard column is gone, right? So that's how basically you can drop a column. Now similarly, if you want to rename a column, it's really simple. You have to write a query like alter table, the table name, and then you have to mention rename column, and then you mention the column name to the new column name, right? For example, let's say I want to change the column name of sex. So what I'll mention is alter table info students, rename column sex to gender. So that's how you can basically rename a column also. Now simply, let's say if you want to drop a table. Now if you want to drop a table, I'll mention drop table, and then I'll mention the table name, right? So I'll just click on execute, and then you'll see that automatically your table will be dropped. So if I just refresh this, you'll see that we just have one particular table, that is teachers, and the students table is gone. So guys, this is how basically you can work on PG admin for basically the DDL commands, right? What I'm going to do is for this particular session, I'm going to consider the ER diagram as I mentioned before, right? So I'm going to create tables and manipulate data over those particular tables only. So before I move forward with this session, what I'll do is I'll explain you the different keys and constraints used in the database so that it's more clear to you how you can create the database in a more structured manner, and then we'll move forward with the various manipulation commands. Until then, what I'll do is I'll just delete this particular table. So I'll right click here, go to delete, and click on OK. And then let's say, we'll delete this particular schema also so that there's no confusion at all. And then what I'll do is I'll close this shell also. So guys, remember that, I am using PG admin. Well, you can use the same queries that I mentioned there on SQL shell also, and you'll see the same output. So I hope that's clear. So I'm going to close the SQL shell, and then I'll continue with this session. So now moving forward with this session, let's start with the next topic, that is keys in database. So there are mainly 5 types of keys in database, that is the candidate key, the super key, the primary key, the alternate key, and the foreign key. So talking about the candidate key, the candidate key is basically the minimal set of attributes which can uniquely identify a tuple. So any minimal set of attributes which can uniquely identify a tuple is known as a candidate key. So the value of the candidate key will be unique and non-null for every tuple. So if you have to identify a specific tuple, let's say Sahiti, age 24, let's say date of birth 30 October, and so on, then you need a particular candidate key to uniquely identify my tuple, right? So that particular can be my employee ID and so on. Now let me tell you one thing over here. There can be more than one candidate key in a relation also. So a candidate key can also be either simple key or a composite key. Now coming to super key. Now super key is basically again the set of attributes which can uniquely identify a tuple. So any set of attributes which can uniquely identify a tuple is known as a super key, but it's not the minimal set of attributes. The minimal set of attributes is the candidate key, but as any set of attributes which can uniquely identify is known as a super key. So when you add 0 or more attributes to a candidate key, it becomes a super key, but the vice versa is not true. So a candidate key is definitely a super key, guys, but the super key is not a candidate key. So that's what you have to understand. Now moving on to primary key. Now primary key is also a set of attributes which can be used to uniquely identify every tuple. Now if you remember the entity relationship diagram that I was explaining you, I said the employee table has a special social security number through which every tuple will be identified, right? So that particular social security number will be the primary key through which every tuple will be identified. And now apart from that, there can be more than one candidate key in a relation, right? So out of all the candidate keys present in the relation, you can choose any one key as the primary key. So if you have around 5 candidate keys, out of them one can be definitely your primary key for that particular relation. Moving on to the next type of key, that is the alternate key. So the candidate keys other than primary keys are basically the alternate keys. So as I was giving you an example of 5 candidate keys. So if there are 5 candidate keys in a relation, Then out of which, if let's say, the first key is chosen as the primary key, then the other 4 keys will be the alternate keys. And finally, moving on to the foreign key. So the foreign key is basically the key if an attribute can only take the values which are present as values of some other attribute. So basically, whenever an attribute can only take the values which are present as values of some other attribute, then it will be basically be the foreign key to the attribute to which it refers. So basically, the relation which is referenced is called reference relation, and the relation which refers to the reference relation is called the referencing relation. So the referenced attribute of the referencing attribute should be a primary key, right? For example, let's say, you have employee and department, right? Now you want to reference department to employee. So what will happen is you'll basically use a foreign key to validate this relationship, and then you'll add a foreign key from department to employee. I hope that's clear. So guys, these were the various keys that you need to understand about. That is the candidate key, super key, primary key, alternate key, and the foreign key. So now that you know the different keys in database and you know the DDL commands also, let me take you to the constraints in database so that we can quickly create the tables that we discussed in entity relationship diagram, right? So the constraints in the database are, as you can see on my screen, that is not null, unique, check, default, and index. So the not null constraint basically ensures that, a null value cannot be stored in a column. For example, let's say, you have a students table. Now in the students table, you have a column known as student ID. And then when you're creating the table, you mention the not null constraint for this particular column. Then whenever you're inserting the data, you have to remember that, there cannot be a null value in this particular column, that is the student ID. Coming to unique constraint makes sure that, all the values in a column are different. So in whichever columns that you want to store unique values, you have to use this constraint unique. Coming to check, this constraint ensures that all the values in a column satisfy a specific condition. So you have to check, let's say, we want to store the age of employees. Now let's say age has to be greater than 25. So only the age values whose value will be greater than 25 will be stored in the age column if you mention this particular constraint. Now moving on to the next constraint, that is the default constraint. This particular constraint consists of a set of default values for a column when no value is specified. So whenever, let's say, you have not inserted any value specifically, then automatically a default value will be stored in that particular cell if you use this particular constraint. And finally, coming to the index constraint, this constraint is used to create and retrieve data for database very quickly. So if you want to create and retrieve data from database very quickly, then you have to use this particular constraint, that is index. So guys, I hope the keys and constraints concept is clear to you guys. So now that we have understood the entity relationship diagram, the constraint and the keys, let me shift back to my PG admin. And now let's say, I'll start creating table. So I'll just show you for one table, and then I've already a set of commands that I've already executed. I'm just going to copy paste the command over here. So what I'm going to do is we had the employee table, right? So for that, what I'm going to do is I'm going to mention create schema first so that you create a schema. So I'm just going to mention create schema. Let's say we mention schema name to be company. After that, what I'm going to do is I'm going to use this particular schema, right? So I'll just mention set search path to company. Now automatically, if I just refresh over here, you'll see that there are two schemas, that is company and public. Now what I'm going to do is I'm going to create tables inside this particular schema. So for that, what I'll do is I'll mention create table. Let's say we mention employee, and in brackets, what I'll do is I'll mention all the column names. So we had first name. Let's say we mentioned text, not null. So I'm using a constraint known as not null, right? So this particular constraint is used. That means that, there cannot be a null value in this particular column. Similarly, let's do for middle name. Let's say char null, right? So there can be null values over here. Now last name, let's say text, not null, right? Now I have basically a social security number, right? So I'll put SSN, let's say character of, let's say 9 characters. Let's be specific over here. And I'll put not null. So this cannot be null. And I also want it to be the primary key. So basically through this particular number, the complete table will be uniquely identified. After that, I'll mention birth date, and then I'll mention the data type to be date, right? Let's mention address. And let's say I mentioned data type to be text, not null. This also cannot be null, right? Similarly, I'll mention sex, let's say character, null. Now similarly, I'll mention salary, let's say decimal, and then 10 to 2. And this can be null. So we don't know. It can happen that, we don't know the salaries, right? Then I'll mention super SSN. So this is basically to identify the self-referencing relationship, if you remember, right? And then I'll mention character of 9 characters. And this can be null. And then let's say we mentioned department number. Let it be int, and let's say not null because we don't want it to be null, right? Now what I'll do is I'll just execute this particular query. Now, once I execute this particular query, you'll see that, automatically we get an output that create table. So our table is successfully created. So if I refresh this particular schema, and then if I open tables, you'll clearly see that, we have the employee tables. Now, similarly, what I'm going to do is for all these particular entities, I'm going to create table, right? So I already have a doc present. So I'm just going to copy paste from that. So let me just open that doc. Right, so let me just copy paste from here. So I'm going to copy for department, locations, projects, works on, and dependent. Now I'll go back to my PG admin. And then what I'll do is I'll just paste it over here. So what I'm doing is, let me just explain you. So I'm creating a table department with the column names as department name, department number, MGR assistant. That's because for the relationship of manager, right? So if you remember, if I just open a diagram, you'll clearly see that, employee managers department, right? So you see for this particular relation, and then MGR start date. That is because, we have to consider the column present on the relationship also, that is managers. Similarly, I'm creating department locations, that is with department number, department location, and primary key as department number and location together. Then I'm creating a table known as project. So the project table will have project name, project number, location, and then I've used the primary key to be project number, and then the project name has to be unique, right? So I've used a constraint over there. Similarly, I'm creating a table known as works on. So for the works on table, I have employee assistant, the project number, the hours worked, and the primary key to be the employee number and the project number together. The dependent table will again have the employee number, the dependent name, sex, birthday, relationship, and the primary key to be employee assistant and dependent name, right? So I'll just execute all these particular queries. So you can see that, automatically my query has got successfully executed. So I'll just refresh this particular table again. So once I refresh this particular schema, you'll see that, I have 6 tables. That is the department, dependent locations, employee, project, works on, right? So guys, that's how basically you can create tables, and that's how you can use keys and constraints while creating tables. So guys, that was all about the data definition language commands. I hope you understood how you can use them and create databases. Now, before I move on to the next topic, that is the data manipulation commands, let me take you through an interesting topic, that is normalization. So what is normalization? So normalization is a technique that organizes tables in such a way that, the redundancy and the dependency of data is reduced. So obviously, when you're storing humongous amount of data on an industry level, there could be scenarios where you have redundancy. So normalization is basically that technique through which, you can remove the redundancy and dependency of the data. So as you can see on my screen, the normalization is basically at 4 levels. That is 1NF, 2NF, 3NF, and BCNF. So let's discuss the same now. Now, before I move forward with 1NF, let me tell you that, I'm going to consider this particular example. So the example that you can see on my screen is basically of 3 people, living in specific address, and they've rented few movies of a specific category. Now, you definitely see redundancy in this particular table, right? That's because, you see Alice Johnson has rented 2 movies, that is Mission Impossible and Clash of Titans. Similarly, David Allen's address has been divided, and also the movies rented are also been divided into different categories, right? Like the sci-fi movies are put into one category and the action movies put into the next category, and both of them are in 2 different tuples. This is definitely a redundant data, right? Now, how do you think you can normalize the data? Well, we'll start with 1NF. Now, the rule of 1NF is really simple, guys. What the rule says is that, each table cell should have a single value. So basically, any table that you have, and then you wish to normalize the data from that particular table, you have to make sure that, each table cell has a single value. So for example, we had Alice Johnson and David Allen, right? So if you remember from the previous slide, we had movies rented together, right? So for Alice Johnson, we had Mission Impossible and Clash of Titans in the same tuple. And for David Allen, we had the address divided, but also the movies also divided. So what I've done over here is to get the data into 1NF, what I've done is I've divided all the movies rented into different tuples. So Alice Johnson staying in First Street, house number 3, has basically, specific movies rented, that is Mission Impossible and Clash of Titans. So what I've done is I've divided both these movies into two different tuples. The same goes for David Allen. If you remember from the previous slide, what happened is that, in the 3rd Street 45 address 1, David Allen had Interstellar and Edge of Tomorrow together, right? So what I've done is I've divided those two into two different tuples again, and David Allen's 7th Avenue into the next tuple. So this is basically how I've got my table into 1NF. Each table cell basically has only one single value. If you observe over here, there's still a problem, right? That's because, our address is redundant for Alice Johnson, and for David Allen, our address is redundant, and yes, it is divided also. It's not all together. So for that, what we'll do is we'll convert this table into 2NF. So basically, to normalize the database into 2NF, remember the fact that, the database should be in 1NF and should also have a single column primary key. What I mean by that is, what I'm going to do is I'm going to divide the table into two different tables such that, for each specific user, I'm going to identify the specific movie rented. For example, let's say, I give Alice Johnson staying in 1st Street, house number 3, ID number 1. Now, I know she rented Mission Impossible and Clash of Titans, right? So what I did was I gave the movies Mission Impossible and Clash of Titans, which are rented by Alice Johnson, the ID 1. Similarly, what I did is for David Allen staying in 3rd Street 45, basically for that particular tuple, I've given the ID to be 2. We know that, he must have rented Interstellar and Edge of Tomorrow, right? So for those particular movies, I've given the ID to be 2. And finally, for Mission Impossible Fallout, that is basically rented by David Allen staying in 7th Avenue, what I've given is I've given ID number 3. So that's how basically I've divided 1NF table into 2NF. Now, if you see over here, there's still a problem, right? Now, that's because, we still have redundant data with respect to Alice Johnson and David Allen, right? Because David Allen's name comes twice. Alice Johnson, who rents 2 movies, comes once. But yes, the address is also divided for David Allen. So to normalize this factor, what we'll do is we'll normalize again. So now we'll normalize the database, which is in the form of 2NF to 3NF. Now, if you want to normalize the database from 2NF to 3NF, the database should be in 2NF and must not have any transitive functional dependencies. So for that, what I'll do is I'll basically add a salutation ID. So basically, I'm going to identify Mr. from 1, Miss from 2, Mrs. from 3, and Doctor from 4. So in that way, what will happen is that, David Allen's name won't come twice because he'll be uniquely identified with Mr. So we'll type in Mr. David Allen. So that will only comes once, and then all the movies will come together. So that's how, guys, basically you can normalize your database. So we've normalized from 1NF to 2NF, 2NF to 3NF, and finally comes BCNF. Now, since my example ends there, so I'm not going to normalize it further. But yes, if your database is not yet normalized, you can then go forward and normalize again, that is BCNF. So to perform the normalization for the 4th time, what you can do is you have to normalize, right? So the condition to normalize it again is basically that, your database must be in 3NF. And maybe, even after being in 3NF, there would be some anomalies and it may have more than one candidate. Now, in such scenarios, what will happen is BCNF will come into the picture and then it will divide the tables further so that there would be only one candidate key present. So whenever after 3NF you observe that, there's more than one candidate key and then you'll have to normalize it again, that's where BCNF comes into picture to divide the table further. So guys, this was about normalization. I hope you've understood how you can normalize your databases. Now let's move forward with the next topic for today's session, that is data manipulation commands. Now the data manipulation commands, as I said before, are basically the commands which are basically used to manipulate your databases. So what I'm going to do is I'm going to manipulate data present in the database that I've created over here, that is in the 6 tables that I've entered. So to initially manipulate data, you need data present in your table. So now to do that, what you have to do is you have to insert data. So to insert data, what you'll type in is insert into, and then let me show you for employee table, employee, and then you'll mention values. And then you'll have to mention the values that you wish to enter, right? So let's say I'll wish to enter John as first name. And let's say I'll enter middle name, let it be a character. Now similarly, I'll enter the next name, let's say Smith. That is basically my last name. Sorry, the comma has to go at the end. Now I'll enter SSN, right? After that, what I'll do is I'll enter birth date. So let's say, I mentioned 1965. 0109. Then let's say, I mention address. So let's say I mention 731 Houston TX. And let's say further I mention the gender to be male. And then let's say we mention salary to be 30,000. And then we mentioned super SSN, let's say 333 4 times 5. And let's say we mention the department number to be 5. Now, once this is done, you can just execute this particular query. So what you can do is you can just hit on execute, and you'll see that automatically the query has been returned successfully. That means the data is filled. So if you want to see the data output, what you can do is you can use the other manipulation command, that is basically select star from employee. So that will basically show you all the values present in the employee table. So let me just mention that, and then I'll hit on execute, and you'll see that automatically you see the data present in the table, that is whatever we have mentioned over here. Now, since guys, filling data would be a waste of time for me to explain for each and every value, I've already put it in my doc, so I'll just copy paste from there so that we can move faster in the session, right? So let me just copy paste these commands. So if you observe over here, what I'm doing is I'm entering data into the department table, the dependent table, the department locations table, projects table, works on table, and so on. So I'm not entering just one, I'm entering quite a amount of detail. So what I'll do is I'll just select all of them together, and then I'll hit on execute. Once I hit on execute, you'll see that the query has been returned successfully. That means that automatically our data has been entered into our tables, right? So if you just want to check how if the data has been entered or not, you can similarly use the same command that I just showed you, that is select star from, and then you mention the table name. So now let's move forward with the session. Now, as you remember from the entity relationship diagram, I said there were relations between two entities, right? So those relations are basically made into picture with the help of foreign keys that I mentioned before, right? So to add foreign keys, what you'll do is you'll have to alter the table, since the tables are already created. So what you can do is either you alter the table, or the other way completely around is basically whenever you're creating the table, you can add foreign keys. So I'm just going to alter the table, since my tables are already created. So for that, what I'll do is I'll put an alter table, and let's say I add a foreign key for the managers relationship. So what will happen is I want to add a foreign key for the managers relationship, where I'll say the department is managed by an employee, right? So what will happen is department will be our first table, where we'll add a foreign key, basically MGR SSN, which references to employee table, because every employee manages a department. So that's what I'm going to do. So I'll mention alter table, and then let's say we mention department. Then I'll mention add foreign key, and then I'll mention the column attribute which has to match, right? So that is MGR SSN that I had created in the department table. And then I'll mention references. Oh, I'm sorry, there's a spelling mistake over here, right? And then I'll mention the table number 2, that is employee to SSN. So basically you have to add a foreign key to each of the columns, right? So you are basically trying to connect the MGR SSN column of a department table to SSN column of the employee table. You'll just execute this. And then once you execute this, you'll see that query returned successfully. That means there is a foreign key, right? So for example, let's say if I just refresh this, and then we go to the employee table, and then if we see the properties, and let's say we go to constraints over here, and in the primary key we see that it's SSN, and in the foreign key, so there's nothing over here, so I had to go to the department table. So let's go to properties, because we are adding the foreign key from there, right? So I go to foreign key, you see that MGR SSN foreign key, basically MGR SSN is connected to SSN. So you clearly see that that's how you can add foreign key. Now what I'm going to do is I'm going to add foreign keys for other tables also, so that we can move forward again. Let me just directly add it from here, right? So as you can see on my screen, I've mentioned a foreign key between employee SSN and an employee super SSN. So that was basically for our self-referencing relationship. Then I've mentioned a foreign key between department number and the department, basically who works on which department, right? So for that particular relationship. After that, I've mentioned a foreign key for department locations and the department. So basically which department is present in which location. After that, I've mentioned a foreign key between project and department, basically which department is looking into which project. And then I've mentioned a foreign key between works on table and employee table to understand which employee is working on which project or which department. And finally, on the dependent and the employee table to make sure the dependency relationship is taken into account. Right? So what I'll do is I'll just execute all these particular foreign keys. So I'll hit on execute. You'll see that, automatically the query has been executed, right? So guys, that's how basically you can add foreign keys to all your tables. if you just refresh over here, and then if you check all the tables, you'll see that, there's some or the other foreign key present for each and every table, that is for each and every relation. Now let's move forward. Now, for example, let's say, I want to see all the details from the works on table, right? Now, let's say, I want to delete records with the project number, let's say 30. Let's try deleting, right? So if I try deleting, let me just try it over here. Delete from, you have to delete from the project table. And then I'm saying the project number, I've considered 30, right? So I'll just type in 30. And let's see what happens when we execute this. Okay, I'm sorry. Yes. Now, when you execute this particular statement, what do you see? You see an error that, update or delete on the table project violates foreign key constraint, because we have a foreign key with respective works on, right? So because we just mentioned over here that, we'll have a foreign key with works on and project number. So now that's the reason we get this error. Now, to resolve this error, basically, I'm talking about the concept where you want to delete the records where foreign keys are present, right? So what you'll do is you'll initially delete the record from the works on table, and then you'll go forward and delete the records from the project table. So you directly won't come over here. What you'll do is you'll initially delete from works on table. So let's say P number is 30, right? So I'll delete the record from the works on table over here. You'll automatically see that, query returned successfully. And now if we try deleting data from project table, what you'll clearly see that, queries returned successfully. That means there was no violating error, right? So what happens is whenever you have a foreign key from A table to B table, remember that, if you want to delete anything from the B table, you have to first delete it from the A table, and then you can go forward and delete it from the B table, right? So guys, that was about the insert statement, the alter statement, and about foreign keys. Now, in this session, what I'm going to do is I'm not going to talk about any theory part like what's going to happen and then how you can use. What I'm going to do is I'm going to directly jump on the queries so that you can understand how you can write queries and how you can manipulate data. So let's get started. So now let's say, we want to update the salary of employees. So for example, let's say I'll just see which employee salary has to be updated. So I'll just type on select star from employee so that I can see the details. I'll just execute this. So when I execute this, you'll see that, I have all the details, right? Now, let's say, I want to update the salary of a person, let's say employee whose SSN is, let's say 99988 4 times 7. Now, let's say the salary is around 25,000, right? Now I want to update it to 27,000. What can I do is basically I have to use the update statement. So to use the update statement, what I can simply do is let me just press on enter so that the screen is clear for you guys. I can just type in update, and then you have to mention the table name. So that will be employee. And then you'll mention set column name. And then what you'll do is you'll mention the new value that you want. That is, let's say 27,000. And then let's say where SSN, that is basically through which you can uniquely identify every tuple, right? So where SSN is equal to, what was the SSN? It was 99988 4 times 7, right? So I'll just type in 99988 4 times 7. And then what I'll do is I'll just end with a semicolon. Once I execute this, you see an output that, query returned successfully, right? So now let me just go back over here and choose select star from employee. And now if you go back to this particular table, you can clearly see that, the employee who had an SSN about 99988 4 times 7 has now a salary of 27,000. So guys, that's how you can update the values. So guys, that was about the update statement. Now let's say you want to delete a tuple's data, let's say more than one condition. So what you can do is you can just use the delete statement. Okay, delete from, and then let's say we want to delete it from works on table, right? So I'll just type in works on, and then let's say where employee SSN, because our works on table has employee SSN as column, right? So over here, if you can see, we have ESSN, and let's say, we use the same employee SSN, let's say 99988 and 4 times 7. And we also have project number details, right? So where I'll choose project number, let's say, right? So that is basically the data I had mentioned. So I'll just execute this particular query, and you'll see that, automatically it's executed, right? So now if I just change this from employee to works on, and then if I execute this particular query, you can clearly see that, we have no employee with employee ID of 99988 4 times 7 and working on project number 10's data present in the works on table. So guys, that was about how you can delete, update, insert and alter. Now let's move forward with one of the most important queries, that is the select query. Now the select query is basically considered as one of the most important queries because this is the query through which you can retrieve the data. So as you can see over here, I was using select query again and again because I wanted to retrieve the data that I have in my database. So that's where basically the select query comes into picture. Now when I had select star from works on, that means all the data was shown. For example, let's say I just want the first name, last name and the address from the employee table, and let's say we are specific to department number 5. So what I can do is I can just type in select first name, last name, address, and I'll mention from employee, and let's say we mention department number is equal to 5. So I'll execute this particular query. So when I execute this particular query, you can see that John, Franklin, Ramesh and Joyce. So basically the first name, last name and address have come into picture, right? So that's how guys you can use the select query. Now this was quite a simple one, right? Now let's look into something more complicated. For example, let's say you want to retrieve data for every project located in Bellary, and then you want the project number, the controlling department number and the department manager's last name, address and birth date. So over here if you observe, what all I have taken into account: the project number, the department manager's, the last name, address and birth date. So if you observe over here, basically what's happening is there are 3 tables coming into picture, right? That's basically the project table, the department table and the employee table. So let's look into how we can write the query for this. So what all did I mention? I mentioned the project number, the department number, last name, address and birth date. So what I'll do is I'll mention select and then I'll mention all these factors, that is project number, dnum, right? And then I'll mention lname, that is basically my last name, and then I'll mention address, say we mentioned birth date, right? And then I mentioned from what are the tables that I had considered, that is the project, department and the employee, right? So I'll mention project, department, employee, where dnum is equal to dnumber. So basically the department number from the project table has to match the department number from the department table. Also, so that's basically you use an operator known as and then you mention MGR-SSN, that is basically who manages the project, has to match with the employee code, that is right, SSN. Apart from that, we also have to mention that our project location is Bellary. So we'll mention and P location is equal to, in quotes we'll mention Bellary, right? So if I just execute this particular query, you'll see an output that there are no tuples which satisfy this particular condition, right? So what I'm going to do is, let's say we change Bellary to, let's say, Houston, right? Now let's execute again. Now if I execute on Houston, you can see that we've got the project number, the dnum, the last name, the address and the birth date of basically all those employees who work on the project basically located in Houston. So that's how guys you can basically integrate 2 to 3 tables together and use the select statement to further play around with it. Now, if you remember, I was talking about the self-referencing relationship where, we have employee related to himself, right? That was basically how a supervisor can have a supervisor. So for example, let's say, for each employee, we want to retrieve the first name and the last name and also the first name and the last name of the supervisor. Then what we can do is we can use the select statement again, right? And then I'll mention e.fname and e.lname. So this is basically to identify every employee, right? So that is basically the supervisee. Now, if you want to identify the supervisor, what I'm going to do is I'll mention s.fname and s.lname. And then I'll mention from, and then I'll mention employee. Sorry, let me put it in small so that it's clear to you. From employee as E, right? So for every employee, that is basically for every supervisee, I'm identifying employee as E. And similarly for supervisor, I'm going to identify as S, right? So I'll mention employee as S, where E dot super SSN is equal to S dot SSN. Now, if I just execute this particular query, you see an output that, we have the first name and the last names of the supervisees and the supervisors. So that's how basically you can play around with the names of the columns and the tables also, guys. So I hope you've understood this particular query. Now, moving forward, you might have heard about the term distinct. So when I say distinct, what I mean is I want to find out all the unique values, right? So to find out unique values, you have to use the term distinct. Let's say we want to find out the distinct salary values for all the employees, right? So now what I can do is I can just mention select distinct, and then I choose the column salary from the employee table, and then I click on execute. So you'll automatically see that we see all the distinct salary values present. So whenever you want to find out any unique values, or let's say distinct values, this is basically the keyword that you have to use, that is distinct. So guys, that was about the distinct query. Now let's move forward and understand the cross product. Now cross product is something like when you have A into B, right? So basically you have A, and then you want to find out all the combinations of A with B. That's when you use cross product. For example, let's say you want to find out all the SSNs, basically of all the SSNs of the employee, and then you want to find out all the combinations of employee SSNs with the department name. So let's do that. So what we can simply do is, to perform cross product, you can mention select SSN and the name from, we'll mention employee and department. So if I just execute this particular query, you'll see that we get all the combinations of SSNs with department name. So let me just drag a little bit, right? So as you can see, we have for each SSN, we have various departments. Like you can see, we have the research department, the admin department, the headquarters department, and so on. So that's how basically you can perform cross product. Now let's say if you want to take this query further. So let's say we want to find out all the employees who work in the department, let's say administration. So what we can simply do is, we'll type in select star, and then I'll mention from employee department, and then I'll mention a where condition which says the name is equal to administration and the number is equal to the number from the department table. So if you have any queries with how am I mentioning the column names, you can always refer to the tables that you have, and then you can go back to the tables and check for the column names. For example, let's say I go to the department, then you can see that I have the department number over here. So I'll just execute this particular query now. And once I execute this particular query, you see that we get all the details of all the employees who work in the department administration, right? So if I just extend this, you'll clearly see the output, right? So guys, that's how basically you can play around with the select statements. Now before I move forward with the further data manipulation language commands, let's look into the next topic, that is operators. Now there are various kinds of operators present in the SQL commands, that is arithmetic operators, the bitwise operators, the comparison operators, and the compound operators. So the arithmetic operators are basically used to perform the arithmetic operations. As you can see on my screen, it's plus, minus, into, divide, and mod. Bitwise has bitwise and, or, and XOR. Comparison has greater than, less than, greater than, equal to, less than, equal to, and then not equal to, and so on. And the compound operators have increment, like a is equal to a plus 1 can be written as a plus equal to. So that's how basically you can use operators, guys. Well, I'm not going to explore more about operators because that's a really simple topic that you can explore about, right? So I've just given you a basic understanding of the top operators. Well, don't worry, we'll be looking forward into these particular operators later on in the session. So let's get started with our next topic for today's session, that is nested queries. So nested queries are SQL queries which have an outer query and an inner query. So the subquery is a query nested within another query such as select, insert, update, or delete. So for example, if you see the screen, that is basically the outer query and the inner query. So I have an outer query which says select last name, first name from employees. Let's say, where address in, and then we choose, we mention an inner query which says select address code from office where country is India, right? So if the condition matches, then automatically this query will be executed and then we'll get the output. So this was about nested queries, guys. So now what I'll do is I'll now explain you a little bit more concepts, and then I'll shift back to my PG admin to show you how you can write nested queries and implement various other queries. So on that note, next let's look into what are set operations. Now all of you might be knowing what are set operations, right? It's basically union, intersect, and minus. For example, let's say you have set A and set B. Now if you perform the union operation between set A and set B, what you'll get is you'll basically get all the data present in both set A and set B. Coming to the intersect option, basically if you have set A and set B, and then if you perform the intersect operation between both these sets, what you'll get is only those rows which are common in both the queries. And finally, coming to minus, that is, you can basically mention minus or except, right? So for example, let's say you have set A and set B, and then you mention set A minus set B. You basically keep all the rows from the left query which are not included in the right query. Now the vice versa is also true. For example, if you do set B minus set A, then you keep all the queries from the right query which are not included in the left query. So that's how basically you can perform set operations, guys. So in the matter of database management systems, if you have to understand, then you can understand set A and set B as left query and right query. So as you can see from the pictorial representation over here, if you do union, then you get all the rows from both the queries. If you do intersect, then you get only those rows which are common in both the queries. And then if you perform the minus operation or the except operation, you get only the rows from the left query which are not included in the right query, or maybe only those rows which are included in the right query but maybe not included in the left query, right? So guys, that was about set operations. So now let's move forward and let's look into special operators. So when I say special operators, there's nothing much big deal about it. There are just few operators which are special, like, between, is, null, in, exist, all, and any. So these are various operators. This is not something that you need to learn in depth, but as you write queries, you should have an idea about all these operators. So when you say between operator, what I mean by between operator is basically that we want to mention a condition between A and B. So whatever values which satisfy the condition between A and B, all those values rows will be printed. Similarly, is null. So the is null operator is basically used to test for the null values. Now, since it is not possible to test the null values with comparison operators like greater than or less than, we can simply use is null and is not null operators instead. So what you can simply do is you can just find out where if address is null, or maybe if the date of birth is null, and so on. Coming to like operator, the like operator is basically used to get the data of all those values which either start with a specific character that you mention, or maybe end with a specific character that you mention. Or it could also happen that you have few spaces and then you mention a specific character. You also want all those rows. Coming to in operator, this is basically a shorthand operator for multiple or conditions, which allows you to specify multiple values in where clause. So this is basically used when you want to use nested queries, right? Coming to exist operator is basically used to test if a record exists or not. If it exists, it's fine. If it doesn't exist, then it returns an output that the query not found. And finally, coming to the all operator, the all operator is used with a where or a having clause and returns true if all the subquery values meet the condition. So this was about all operator. Coming to any operator, the any operator is also used with the where and the having clauses and returns true if any of the subquery values meet the condition. Apart from that, over here, I also want to tell you about the order by, group by, and the having clauses. So the order by is basically to order the data that you want in a specific format. Let's say, ascending order, descending order, and so on. The group by is basically you want to group the data according to some specific column and so on, right? And having is basically where you're checking, let's say, having salary greater than 25,000. So only those tuples will be returned whose salary is greater than 25,000. So guys, that was about group by, order by, and having clauses also. Now let's move forward with the next one, that is aggregate functions. So aggregate functions is also one of the most simple topics. So aggregate functions is mainly used with the nested queries. That is basically the min, max, the count, average, and sum. So the min function is basically used to return the smallest value of the selected column in a table. The max function is basically used to return the largest value of the selected column in a table. The count function is basically used to count the number of rows that match a specified criteria. The average function returns the average value of a numeric column that you choose. And the sum function returns the total sum of a numeric column that you choose. Now that was about aggregate functions, guys. So don't worry, I'm just brushing you with the topics, basically the concepts. I'm going to show you how you can use all these concepts based on the queries that I'll execute on the PG admin in a while. Now, but before that, let me just take you through the limit, offset, and fetch values. So the limit is basically used to limit the number of data that you want to get. Now we want only the data of the first 5 rows. So what we'll do is we'll basically mention select star from employee limit 5. What will happen is automatically we'll see the first 5 tuples. Coming to offset, offset is used to basically select a specific number of rows after the limit, right? For example, let's say after the 5th row, we want 3 rows, right? So what we'll do is we'll use the offset statement to basically mention that, after the 5th row, we want 3 rows, right? So basically only after the 5th tuple is read, automatically 6, 7, 8 will be printed out as an output. Coming to fetch, fetch is also one of the ways to limiting the query results, right? So whenever you want to fetch, let's say first 5 rows only, or maybe let's say 10 rows only, then you can use the fetch statement. So I'm going to show you how that's done. Let me just shift back to my PG admin. And now what I'll do is I'll start with the first topic that I had discussed over here, that is nested queries. So let's write some interesting nested queries so that you get a hands-on experience on how you can integrate into complex queries, right? So for example, let's say, we want to make a list of all the project numbers for projects that involve an employee whose last name is Smith, either as a worker or as a manager of the department that controls the project. So our main question is basically to list the project numbers for projects that involve the employee Smith. Now that particular employee can either be the manager or can also be the worker of that particular department and controls the project. So to do that, what I'll do is I'll have to write a nested query. So the reason for nested query is simple. That is because, we have to first find out all the projects where, Smith is working as an employee. Later on, we'll find out the projects where Smith is working as a manager, right? So let's start with Smith working as a manager. So for that, what we'll do is we'll type in select distinct because we want unique records. And let's say P number, that is basically the project number from project. And then we also want the department because we're going to use a department table. And then we mention employee because we're going to use the last name, where we'll mention dnum is equal to the number and mgrssn is equal to ssn. Also, my last name should be Smith, right? So I'll mention last name is equal to, right? So let me just remove this, put it over here, and let me put a bracket. Now let me tell you one thing over here. This is not the end to the query because we also want to find out all the project numbers where employee Smith is working as a worker, right? So for that, what we'll do is we'll use the set operation union, right? So because this makes sense, right? We want all the values from set A and then we also want all the values from set B. So that is the reason we'll use the union operation and then we'll mention select distinct P number from project works on employee where P number is equal to P number, that is basically the project number from the project table and the works on table, and employee SSN from the works on table to SSN from the employee table. Apart from that, we also have to mention that last name should be Smith, right? So we'll mention and L name is equal to Smith, right? So I'll end it with a semicolon and let me just remove this typo over here. And then let's execute this particular query. All right, it says department. Oh yes, there's a spelling mistake over here, right? And now let's execute again. So once I execute, you see that, I get the project number 1, 2. That means that, the person with the last name Smith works as a manager or maybe works as a worker in these two projects, that is project number 1 and 2. So guys, this was a nested query with the union operation. Now let's say, you don't want to use any set operations and let's say you just want to write a simple query. Let's take an example for that. Now let's say, we want to retrieve the name of employees who have no dependents, right? So we had a relationship which says employees have dependents, right? So let's say, we want the name of employees who have no dependents. So for that, what you can do is you can just type in the query, select first name. Let's say we take first name and let's say we take last name from employee where we'll mention not, I'm sorry, I have to correct the spelling of where over here. We'll mention not exists and then I'll again mention a subquery which says select star from dependent where we have to match the SSN, right? So SSN is equal to ESSN, right? So I'll just execute this particular query. And then once we execute this particular query, you'll see an output of all those employees who have no dependents. So that's how, guys, basically you can use this operator of not exists. What I've done is I've basically taken the operator of exists. So if it exists, what will happen is that initially the subquery will be executed which says select star from dependent where SSN is equal to ESSN. So this query will generate all those results which have the dependents, right? So basically all those employees who have dependents, that particular result will be generated over here. Then I put a not condition before that. So when I put a not condition, the output gets reversed. And automatically I got that output printed. So if you just mention exists over here, and then if you remove not, and then again if you just execute this particular statement, you'll see a different output. So this is basically the output of all the employees who have dependents. So now let's take this query further, and let's say we want to find out the names of those managers who have at least one dependent. So what I'll mention over here is I'll mention select first name, last name from employee where exists, and then I'll change this condition. Select star from dependent where SSN is equal to ESSN, and also I have to take this condition further which says and exists, and then I again have a nested subquery which says select star from department, because we are considering manager, right, where SSN is equal to MGR SSN. So I'll just close this bracket over here, and then I'll remove one bracket at the end, and let me put an enter so that's clear to you. So what I'm basically doing is I'm basically listing the name of managers who have at least one dependent. So for that, what I've done is I've used an outer query which has a subquery, and underneath that I again have another subquery. So for that, what I'm using is select first name, last name from employee where exists, and then again I have a subquery which says select star from dependent where SSN is equal to ESSN. This will basically give the output of all the employees who have dependents. Now after that, we also have to match from select star from department where SSN is equal to MGR SSN, which is basically the name of managers that we want. After that, we're taking dependents into account, and then we are returning the first name and the last name. So if you see the output, we get Franklin and Jennifer, right? So Franklin and Jennifer are those managers who at least have one dependent. So guys, that was about exists and not exists, how you can use and all. Now let's move a little bit further, and as I was talking about operators, like the special operators, let's look into few queries related to that. So let me just press on enter over here so that I can make the screen clear for you. Now let's say over here we want to retrieve all the employees whose address is in Houston, Texas. So it's really simple. What I can do is I can just generate select SSN and first name from employee where address like, and then in quotes I'll mention percentage Houston and percentage. Sorry. And then what I'll do is I'll end with a semicolon over here. So basically I'm generating the SSN and the first name of all the employees whose address is in Houston, Texas, right? So let me just execute it. So once I execute, you see an error that where address. Okay, so that is basically because our spelling is incorrect over here. So let me just execute again. So once I execute, you see SSN and first name of all those employees whose address is in Houston, Texas, right? So if you want to check this information, you can go back to our employee table and then you can check the information for sure. So that's basically how you can use the like operator. Now let's say, we want to find out all those employees whose first name has, let's say, 5 characters. So if you want to mention 5 characters, how will you do that? Any 5 characters, not necessarily that, it has to start with F or S or A or any other character. It can be any character that you wish to, right? So in that scenario, let's just generate select first name, and let's say I again generate SSN from employee where first name like, okay, there's a typo over here, and then I'll mention 5 characters, right? And then I'll end with a semicolon. So let's just execute this particular query, and you'll see that it's just Joyce, Ahmed and James who have first name with 5 characters. So all the other employees who have first name with any other number of characters are not taken into account. So that's how basically you can use the like operator, guys. Now let's say you want to use the between operator. For example, let's say we want to find out all those employees whose salary lies between, let's say, 30,000 to 45,000. So for that, I'll type in the statement select star from employee where, and then you mention the nested query salary between, and then you mention 30,000, right, and 40,000, right? And so let me just execute this particular query. All right, once I execute this particular query, you get the information of all those employees whose salary lies between 30,000 to 40,000. So guys, that's how you can use the between operator. Now, as I'm talking about operators, let me just show you a simple functionality of the arithmetic operator also. Let's say, we want to show the resulting salaries of each and every employee working on the product Y project, and let's say, it's given a 20% raise. So to do that, what you can do is you can write a query, let's say select E.F name. So if you remember, I used a similar query previously also. and then I choose 𝐸.LName, and then I mention 1.2, right, into, that is basically my arithmetic operator that I'm using, and I'm choosing 𝐸.salary as let's say increased salary from, I'm choosing employee table because salary is an employee table, and then since I'm using 𝐸.FName, I'll mention employee as E, and then works on W, and project as P. And further what I'll do is I'll mention where employee.ssn is equal to the works.ssn, right? So whatever employee is working on product Y, right? So that's what we want to find out over here. So he has to first satisfy the condition of the SSNs have to match. Apart from that, we'll consider and, all right, this has to be ESSN, right? And then I'll mention work.pNumber is equal to P.pNumber, and P.pName is equal to product Y. So let me just end this particular query over here and now execute it. Once I execute, you'll see that we get the first name and the last name and the increased salaries of all those employees who have worked on product Y, and their salary is increased by 20%. So that's how, guys, basically you can use the as operator and also arithmetic operators together. Now, as I was talking about one more operator, that is null. So if I have to talk about is null, let's say we want to find out all those employees who do not have any supervisor. So then directly you will use is null operator. So in that scenario, what you'll basically do is you'll write a query like select, let's say, star from employee where super SSN is null. I'm basically using this is null operator to find out all those employees who do not have any supervisors. So I'll just execute this. And then once I execute this, you get the details of that particular employee who doesn't have a supervisor. So guys, that was about operators and all. I won't go into each and every operator now. I'm leaving the rest to you so that you practice. So next, let's look into how you can use aggregate functions in SQL. So to use aggregate functions, what you can simply do is you basically have to use the functions as sum, max, min, average, and count, right? For example, let's say, we want to find out the sum, the max, the min, and the average salary from employee. Let's say, I want to find out the sum, min, max of salary from employee, right? So I'll just mention select sum salary, min salary, max salary from employee, right? So when I mention that, you'll see that the sum is so much, the minimum and the maximum is so much, right? That was about sum, min, max. Now let's say I want to count the salary. So what I'll do is I'll basically change this particular function to count, right? And then I'll say count distinct salary because I want to count the unique ones, right? And then I'll mention from employee, right? So I'll just remove this particular section, right? And then if I just execute this, you'll see an output of 7, right? So basically we have 7 distinct salaries. So that was about aggregate functions, guys. Now next, let's look into order by, group by, and having clauses. So as I mentioned before, the order by is basically used to get the output either in the ascending format or the descending format. The group by is basically used to group the data that you want by a specific column, and having is basically used to check a condition. Let's say we want to write a query to retrieve a list of employees and the projects they're working on, ordered by the department, and within each department they have to be ordered alphabetically by the last name and then the first name. So initially they have to be ordered by department, and then under each department also they have to be further ordered by the last name and the first name. So to do that, what you can do is you can just mention select, and then you mention d.tname, right? And then you mention e.lname. We also want the first name, right? So we'll mention e.fname and then p.pname from department. There's a typo. And then we also want employee. We also want works on, right? Now over here we have to mention as W over here, as E over here, as D over here, and then I forgot to mention the project. So project as P. And then you have to mention the condition which says where d.tNumber is equal to e.tNumber and employee.ssn is equal to workson.ssn and workson.pNumber is equal to p.pNumber, and then it is order by d.tName, and then I mention e.lName and e.fName, right? And then if I just end this particular query, let's execute this particular query. You see an error that w.ssn not found because this has to be ESSN, right? So I'll have to mention ESSN over here, and then let's execute this query again. It's a typo error again which says p.pNumber. Right, now let's execute again, and you see an output of dname, lname, fname, and project name. So initially, if you see, the dname is ordered by alphabetically, that is in the ascending order from A to R. And then under administration, Wallace and Jennifer have come. Similarly, headquarters have Borg and James. Research has a lot of values, but underneath that also we have ordered them according to ascending order, by which I mean that it is ordered alphabetically by last name and then the first name. So that's how basically, guys, you can use the order by. Now this was a little bit complicated one. If I just have to explain you with simple one, what you can do is you can consider the query of, let's say we want to find out the salary of all the employees in a descending order. So what we do is we just type in select star from employee order by, and then we mention salary descending order. Right, now if I just execute this particular query, you'll see that we get all the details of all the employees in the salaries of the descending orders. So in the case of descending, if you mention ascending, then you'll get an output of all the details of all the employees in an ascending order based on the salaries. So guys, that was about the order by clause. Now let's move forward with the group by clause. Now let's say we want to find out for each department, we want to retrieve the department number and the number of employees in the department, right? So now to retrieve the number of employees, the aggregate function, we have to use the count function. And then we want to group it by the department number, right? Because we have to do it for each department, right? The question says for each department, we want to retrieve the department number and the number of employees. So to do that, what I'll simply do is I'll mention a select query department number and then a count function of all the employees. And then I'll mention from employee, right? So let me just press on enter so that the keyboard doesn't move. And then I mention group by the number, right? Because we want to find it for each department. We're using this. So for each department, we have a count like, in the department number 5, the number of employees working are 4. In the department number 4, the number of employees working at 4 are 3. And in the department 1, the number of employees working are 1. All right. So that was about the group by clause, guys. I hope that was simple to understand. Now let's look into the having clause. So having, as I mentioned before, is basically used to specify a specific condition. So let's say, having count less than 2, greater than 2, having salary greater than 25,000 or maybe less than 30,000 and so on. Now let's say, we have a scenario where we want to retrieve the data for each project on which, let's say, more than 3 employees work. We want to retrieve the project number and the number of employees who work on the project. Our main condition is that, for each project, where the employee count is more than 3, right? So for that, what I'm going to do is I'm going to mention the condition select P number, that is because of the project number. And then let's say I want to count the employees, right? So I'll mention count star from project works on where P number is equal to P number. And then I group by for each project, right? So when you group by, you basically have to group by project number, and then I mentioned the condition having count greater than, I forgot to mention the asterisk condition over here, 3. So basically I'm mentioning the condition that, we want to retrieve the project number and the count of employees who are working on the project, where the project number from the project table matches the project number from the works on table, and then it is grouped by project number, where the count is more than 3. Now, if I execute this particular query, you see that there's no data returned, right? So that may be because the condition is not satisfied by any of the data that we have. So let's say we want to do it 2. So I'm just mentioning the condition to be 2, and I click on enter, and then you see that we get the project number 2, where you see the count is 3, and then the project number 20, where you see the count is 3. So initially, when I mentioned the condition having count greater than 3, the output did not come because there was no such data present. So that's the reason there was nothing returned. But when we change the condition, you see that, we get an output of 2 project numbers. So guys, that's how basically you can use the group by clause, the order by clause, and the having clause. Next, as I was talking about the limit, offset, and fetch, let me just quickly cover that particular part so that we can go back and learn about SQL joins. Now, talking about a limit, as I told you, if you want to limit the data that you want to fetch, right? So basically, let's say, we want to just fetch 5 rows, right? What you can simply do is you can just type in select star from, let's say, works on, and then we limit 5, right? And now if I execute this particular query, you'll see an output that, only 5 rows of data will be printed out. So that's because, we're limiting the data that has to be written. Now let's say, we want to select 3 rows from, let's say, works on table after the 5th row. So we want the next 3 rows to be printed after the 5th row. So for that, you have to use the offset statement. So what you'll do is you'll mention select star from works on, and then what you'll do is instead of limit over here, you'll mention offset 5, and then over here you'll mention limit 3. So after the 5th row, you want 3 rows to be printed. So that is the reason you'll mention offset 5 and limit 3. So let me just execute this particular query. So if I execute this particular query, you'll see that, I've got the output of 6th, 7th, and 8th row. So basically, guys, that's how you can use the offset statement. Now, let's say, if you want to use the fetch statement. So as I mentioned before, the fetch statement is also used to fetch the records. So let's say, I want to fetch the first 8 rows. So what I'll do is I'll mention select star from works on, and then mention offset 5, and then I'll mention first 8 rows only. So after the 5th row, what I'll mention is I'll mention select star from works on, and then I'll mention fetch first 8 rows only, right? So if I just execute this particular statement, you'll see the first 8 rows. So over here, you can clearly see the output that, when we used limit 5, you saw the first 5 rows. And then when we used offset 5 and then limit 3, we saw the next 3 rows. And now if you're using the fetch command where we say fetch first 8 rows only, you'll see that, we fetch all the 8 rows, right? So that's how, guys, basically you can use the limit, offset, and the fetch commands. So that was about till now. Now let's go back to our PPT, and next let's look into joins in SQL. So all of you might be knowing what are joins, right? Now joins in SQL are commands which are basically used to combine rows from 2 or more tables based on a related column between those 2 tables. So they are predominantly used when a user is trying to extract data from the tables which have one-to-many relationships or many-to-many relationships between them. So if you just have to understand joins in a simple language, then joins in SQL are basic commands which are used to combine rows from 2 or more tables based on a related column between those 2 tables. So basically there are 4 types of joins present, that is the inner join, the left join, the right join, and the full join. So as you can see on my screen, the inner join is the join which is used to return the records which have matching values in both the tables. So whenever you have matching values in both the tables, you use inner join. Coming to the left join returns records from the left table and also those records which satisfy the condition from the right table. The right join returns records from the right table and also those records which satisfy the condition from the left table. And finally, coming to full join, the full join returns all those records which either have a matching value in the left table or on the right table. So guys, these were the mainly 4 types of joins, that is the inner join, the full, the left, and the right join. Now let me just quickly take you back to pgadmin and then let's apply a few joins on the tables that we have. For example, let's say we want to apply left join, right? As I told you before, the left join is basically going to return all those records from the left table and also all those records matching the condition from the right table. What I'll do is I'll mention select, let's say SSN, I'm going to mention first name, and then I mention dependent dot dependent name, and then I'll mention dependent dot relationship, which is a column of the dependent table, and then I'll mention from employee left join, and then I'll mention the table 1, that is basically dependent on employee dot SSN is equal to dependent dot ESSN. So when I execute this particular query, you see an error that the table is not found because we have an error with the column name. So let's just check the column name. Okay, it's underscore. So I'll mention underscore over here. So when you see the output, you can clearly see that we've got all the records from the left table, that is the dependent table, and then all the records which also match the condition from the right table. So that's how, guys, you can apply left join. Now similarly, you can apply right join also. So for the same condition, let's apply the right join and let's see the difference in the outputs, right? So what I'll do is I'll just scroll again and then I'll just change it to right join. And now I'll execute again. So let me just execute this particular query. And once I execute this particular query, you'll see a difference, right? So that's basically how you can play around with joins, guys. This was about left and right. Now, before I conclude the joins part, let me also talk about the inner join and the full join. So the inner join is basically where you have matching values in both tables, right? So let's say, we select SSN and first name, and let's say, we remove this particular section, and then we mention from employee. I'll mention inner join dependent on employed at SSN is equal to dependent. So we'll get all those records which have matching values in both the tables, right? I'll execute this particular query and you'll see the output, right? So these are basically all those values which have a matching values in both the table A and table B. And finally, let's say, if I want to specify the full join, which basically will give me the output of all those records which either have a matching value in the left table or on the right table, what I can do is I can simply mention full join over here. And then I execute this, and then you'll see an output like this, right? So basically, you'll see that, these are all the tuples which have either a matching value in the left table or on the right table. So guys, that was about joins. Next in this session, let's move forward and take a look at the views. So views are really simple, guys. As the name suggests, views in SQL is a single table which is derived basically from the other tables. So for instance, if you consider the example on my screen, I have two tables, right? Now, for example, let's say I want to create a new view, which will basically have few columns or rows from a specific table and few columns or rows from the other table, right? So that is basically my view. So now views are used in industries to basically collaborate with the data of many tables so that the company can understand how to go about the next action step they should take while taking any specific decision. So without wasting any further time, let's take a look at how we can create a view. So to create a view, it's really simple. Either you can use the query tool, or what you can do is you can just go to the view option, right click over here, choose create and choose view. Since I'm writing queries for all of them, I'll show you by writing queries itself. Else you can use this option also. So talking about views. So to create a view, it's really simple. As you create a table, you can similarly create a view like, create view. And then you mention the view name. Let's say we're going to create a view for the works on table. So I'll mention works on 1. And then what I'll do is I'll mention the condition. So if you stop over here, this will simply create a view and this will not store any particular data that you want. But if you start mentioning the condition, then it will have all the data according to the condition that you've mentioned, right? So over here, what I'm doing is I'm going to mention the details of an employee who work on a specific project. So for that, I'm going to do is I'm going to just create a view over here. So as I'm creating, so I'll type in create view works on, and then I'll mention the condition as select first name, last name and project name from employee, project and works on, where SSN is equal to ESSN and project number is equal to project number, right? So that is basically the project number matching from the project table to the works on table and the SSN matching from the employee table to the works on table, right? And then I'll just execute this particular query. Right, once you execute this particular query, you see an output that query returns successfully. Now if I just refresh this particular views, you'll see a view named as works on with the columns that you've mentioned, that is first name, last name and the project name. Now if you want to see the data present in this particular view, what you can do is you can just mention select star from, and then you mention the view name, that is works on 1, right? And then if I execute this, you'll see the output, right? So that is basically the data that is automatically present in a view, and the view is created by deriving data from other tables like the employee table, the project table and the works on table. So that's how, guys, basically you can create a view. Now let's say you want to drop a view. Dropping a view is also really simple, guys. You have to type in drop view and then the view name, right? So if I mention works on 1, and then if I end with a semicolon, you'll see that the drop view is successful. So if I just refresh this particular section, you'll see that there's no view available. So guys, that's how basically you can drop a view also. So guys, that was all about views. I'm not going to go into depth of how you can create more complicated views and all, because I've given you a basic understanding of how views are created and how you can drop the views also. Rest I leave it to you to practice. Please remember the fact that I'm just giving you all the basic concepts so that you get started with PostgreSQL. But if you have to get a good understanding of all the databases, then make sure you have good practice. On that note, let's get started with the next topic for today's session, that is procedures. So procedures are basically a section of code. So basically you can understand procedures as a section of code or functions which you can save, and then you can reuse it, right? So whenever you want to save a section of code or maybe a function and then you want to keep reusing it, that's where stored procedures come into the picture. So for example, let's say, you want to create procedures, right? So what I'm going to do is I'm going to create a new table. Let's stop with the example of employees and works ons and so on. Let's move on with a new example. Let's say, I create two tables. So I'll mention create table, and then I'll mention, let's say the first table to be TBL1, and then I'll mention the column to be TBL1 ID, and then let it be int. Now similarly, I'll create another table also. So let me just change it to TBL2 also, and then now what I'll do is I'll just execute this particular two statements, right? So if I just refresh this section over here, right, so now you will see that instead of 6 tables, now there are 8 tables. So let me just minimize the others so that you have no confusion, right? So we have 2 tables, that is TBL1 and TBL2. Now let's say you want to create a procedure such that you want to insert values. So basically I don't want to write insert into statements 110 times. What I'm going to do is I'm going to just create a simple function through which you can insert values. So to insert values, what you can simply do is I'll mention create procedure, and then let's say mention the procedure name to be insert values. And now let's say, we mention what values have to be inserted. Let's say, value X has to be inserted in table 1 and value Y has to be inserted in table 2. So I'll mention X integer and Y integer. And then what I'll do is I'll mention language SQL, because it is a form of SQL, as $, and then I'll mention insert into TBL1, that is basically my first table, values X, right? And then I'll mention insert into TBL2, values Y. After that, I'll just end this section with $, and semicolon. And then what I'll do is I'll basically call this particular function. So this is basically how you create a procedure. But yes, if you want to reuse a procedure, then you have to call that particular procedure, right? So for that, I'll use the function call insert values, and then I'll mention, let's say 1, 2, right? So these are basically the two values that I want to mention in table 1 and table 2. So the table 1 should be inserted with value 1, and then table 2 should have the value 2. And now what I'll do is I'll execute this particular section completely. Once I execute this particular section completely, you'll see an output that, call query has been returned successfully, right? Now let's just use the select statement to see whether, the value has been inserted or not. So let's say I'll mention select star from table 1, and then similarly I'll mention select star from table 2. So if I just print select star from table 1, you see the value to be 1, right? I hope that you can see. Now similarly, if I mention select star from table 2, you'll see the value to be 2. So that means our values have got inserted. So guys, this is a really simple example. I've just taken 2 tables with a single column. Now you can have any number of columns, and then you can mention any number of columns to be present over here, and then you mention the specific values into the insert statements. And then what you just have to do is you just have to keep changing the values over here. So for example, let's say if I do 3, 4 over here again, and then I execute the statement call insert values, and then let's say I execute the statement select star from TBL1. So you'll see that apart from 1, we also have the value 3. Now similarly, if I do select star from TBL2, you'll see the output that apart from 2, we also have 4. So that's how basically, guys, you can create stored procedures. Well, I think it was really simple to understand how you can create procedures and so on, right? Now in this session, let's move forward with the next topic, that is triggers. Now triggers are a set of SQL statements which are stored in the database catalog. Now these statements are executed whenever an event associated with the table occurs. So a trigger is basically invoked either before or after the data is changed by either the insert statement, the update statement, or the delete statement. And it only invokes whenever there's an event associated with the table. So now let's look into how you can implement triggers in PostgreSQL. So to implement triggers, what I'm going to do is I'm going to create a table first. So let's say I create a table audit, and then let's say I'm going to consider employee ID right, to be of char type and 9 characters, since our SSN is of 9 characters, and then it should not be null. And then apart from that, I'm also going to consider, let's say, we have entry date, right? Let's say joining date or maybe entry date. And then we have text. It's of text data type, right? And there should not be any space because date is also a data type. And then I'll mention not null. Now what I'm going to do is I'm going to create a function, and then I'm going to create a function which returns a trigger as a specific trigger. And then I'll use that particular trigger on the employee table. So let's do the same. Now, once I create this table audit, what I'm going to do is I'm going to create a function, audit log function, which will basically return a trigger as example table, which will begin whenever you wish to insert something into the audit table. Now the trigger example table will be created then. So let's just do the same. So now since I've created the table audit, let me create the function, right? So to create a function, you have to type in create or replace function audit log func. That is basically, the function name that I'm giving. And then I mention returns trigger as, and then I'll mention the trigger name. Let it be example table, right? And then I'll mention begin, right? So it will begin then, and then I'll mention insert into audit, where emp id and entry date will be mentioned, and values will be new.ssn. A new SSN will be generated, and then automatically the current timestamp will be taken as the entry date, right? So that's how basically you can also use timestamps also, guys. So basically what I'm doing is whatever is the current time, I'm using that particular current timestamp. So I'll mention timestamp. And then what I'll do is I'll mention return new and then end. So this is basically the function that I'm creating. So the function basically says that, it will return a trigger as example table whenever you want to insert something into the audit table. Now, as I was talking about the trigger example table, we have to create that also, right? Now, before that, I forgot to mention something over here. That is, you have to mention example table. That is basically in language PSQL, right? So you'll have to mention that particular fact over here. Now, after that, if you wish to create a trigger, you'll mention create trigger. We'll mention example trigger. After insert on, basically whenever you're inserting employee for each row, I'm going to execute the procedure or the function that I just created. So that is basically my audit log function. So I'll just copy from here, paste it over here. And then finally, I'll mention the insert statement. So what I'm going to do is the insert, since we are doing on the employee table itself, I'll just copy this particular fact over here. And then what I'll do is I'll paste it over here. And let's say I mention Sahiti, let's say L, and then I mention Kapagantula. And let's say I randomly put in details, right? And then let's say I change the salary also so that there's no redundancy anywhere, right? So what have I done over here? I've basically created a table audit. So this audit table is basically like, whenever I want to insert into the employee table, a trigger will be created. So basically a trigger will be invoked, which says after execute on, you have to mention the procedure, right? So basically the procedure is basically the function that we created. That's basically, it returns to the trigger example table where, it inserts into the audit table automatically. That is basically the employee ID that I've mentioned over here, and automatically the current timestamp as the entry date. So let's see what happens. So what I'll do is I'll execute from here to here. And let's just check if everything is selected. Yes. And then I execute. All right. It says syntax error at employee ID value current. Oh, it's because the current timestamp spelling is wrong over there. So let's just correct that. Now I'll again execute this particular section again. It still says that, there's an error over here. Yes, that's because, I've missed comma over here, and then I put the brackets. So I have to remove the brackets and then I have to put the comma. And then again, let's try executing this particular section. It says that, the key super SSN is not present in the table employee, right? So that's because we cannot randomly do and we have foreign keys present. So let's just randomly choose any super SSN. Let's say 33344 4 times 5, right? And now I'll go back and now let's execute again. Once I execute again, you can clearly see an output that, query returned successfully, right? So let me just refresh tables and let me just refresh triggers. So once I refresh tables, you'll see that, there's an employee table. And then we also see there's an audit table, and the audit table has the columns employee ID and entry date, right? And then we have a trigger function which says audit log function is basically the trigger function that we just created. Now, if I wanted to see the data from the audit table, I'll just choose select star from audit. And then you'll see automatically the employee ID and the date, which is basically the current time, is generated. So that's how, guys, basically you can use triggers. So with this, we come to an end of the data manipulation commands. I hope you've understood all the commands and the syntaxes and the statements that I just showed you. Now let's move forward with the next set of statements, that is the data control language commands. Now, the data control language commands, as I previously mentioned in the starting of the session, is basically used to provide rights and privileges to the users to access database, views, tables, and so on. So basically, there are only two statements that you need to understand in this particular section. That is the grant statement and the revoke statement. So let's consider the grant statement. So the grant command is basically used to grant privileges to the databases or tables. For example, let's say, we consider the table 1 we created over here. So if I right click over here and go to properties, and let's say I go to securities, you see that, there's no grantee privileges. There's nothing present over here because there are no privileges granted to this particular table. So let's grant permissions to this particular table. So what I'm going to do is I'm going to type in grant select on. Then I'll mention the table name, that is table 1, 2, and I'll mention public. And then I'll just execute this particular query. You'll see that, the query has been returned successfully. And now what I'll do is I'll right click over here, go to properties, and then go to parameters, and then go to security over here. And then you'll see that, automatically we have granted a public privilege to this particular table. Now let's say, we want to grant privileges on basically the command insert on, right? So whenever there's some insert on, we want to grant privileges to the public. So anybody can insert into this particular table. Now let's say, we want to grant insert on privileges to the employee table, right? So basically anybody can insert into this particular table. So that is basically grant insert on employee to public. If I just execute, you'll see the output of query returned successfully, right? So now what I'll do is I'll just go to my employee table over here. Go to properties, go to security, and you'll see public, and then you'll see privileges of A, right? Basically all. So that's how basically you can grant privileges, guys. Now you can also revoke back your privileges. Let's say, you want to revoke back the privilege that you just gave. So for that, you just have to use the statement revoke, right? So you'll type in revoke insert on employee, and then instead of to, you'll mention from. So you'll mention revoke insert on employee from public, right? So you'll just execute this particular query. And then we'll go to properties again over here, go to security, and then you'll see that, there's no more public privilege present over here. So guys, that's how basically you can control privileges and rights for your databases and tables. So guys, that was about data control language commands. Now moving forward, the next type of commands that we have is the transaction control language commands. So the transaction control language commands come into the picture when you want to make sure that, the transaction in the database is meeting all the standards. That is basically the asset properties. So asset properties are basically atomicity, consistency, isolation, and durability. So basically, if you want to make sure that, the database is making sure that the transaction properties are met, then you have to use this transaction control language commands. So to use transaction language control commands, what I'm going to do is I'm going to perform transaction on table 1, right? So let me just see what values are present in table 1. So let me just see. I forgot to mention from over here. So it's select star from table 1, and then you see 1, 3, right? Now what I'm going to do is I'm going to insert around values till 10. So let's insert all the other values. I'm just going to copy it from my doc over here. So since I have already 1 and 3 values present over here, what I'm going to do is I'm not going to insert these values. So I'll just remove these, and then I'll just execute them, right? So you'll see that, data has been inserted into my table. Now let's begin a transaction. When I say begin a transaction, you have to use the syntax known as begin. So you'll type in begin, and then let's say, we want to delete all the values which have the ID greater than 5, right? So basically all the tuple values which have the ID greater than 5 have to be deleted. So for that, we're initializing a transaction, and then I'll mention delete from and table1, where table1 ID. So let me just check the column name. That's tbl1 ID is greater than 5. So I'll mention begin. So basically my transaction will begin, and then what I'll do is I'll delete. So let's just do that, right? So you can see that, the transaction is running on, and then we have deleted till 5. Now let's say, if I want to roll back is basically I don't want it to occur, right? So when I hit on rollback, you'll see that, automatically all the 10 values will come back, right? So if I just use the syntax of select star from table 1, you'll see the output of 1 to 10 again. So what you should understand from over here is basically that, the begin is basically used to begin the transaction, and the rollback is basically used to roll back from the previous transaction. So here what I've done is that I started a transaction and then I deleted the values greater than 5. So all the values got deleted. Now when I hit on rollback, what happened is that, the transaction got rolled back and automatically all the values got retrieved. So that's how basically you can do rollback. Now similarly, you can do commit, right? So what I can do now is I can type on commit over here, and then I can begin a transaction again, right? So once I begin a transaction again, and once I delete all the values greater than 5, and then when I hit on commit, you cannot roll back, right? So all the values will be deleted whose IDs will be greater than 5. So if I just execute this particular statement, you'll see that, you only have 1 to 5 values. Now, similarly, you can also abort the transaction using the statement abort. So guys, that was all about transaction language control commands. Now let's move forward with the next topic, that is how you can export and import data. Well guys, exporting and importing data is really simple. For example, let's say, I want to export and import data of the table 1 values, right? So what I'll do is I'll right click over here and then go to import export option. And then what I'll do is I'll mention the file name, right? So basically I'm exporting, and I'll search for, let's say, demo.csv, right? So now demo.csv is present in my E folder, right? I'll choose that, and then I'll click on create. Once I click on create, you'll see that, if I want to replace, well, I have a pre-existing file, so I'm just allowing it to replace. Well, you can do that, right? And then you'll click on OK. Once you click on OK, you'll automatically see that, the details have been copied, right? So what I'll do is I'll go over here, go to E folder mine, and go to demo.csv. So in the demo.csv, you can see that, we've got the data 1 to 5 because we just had one row column, that is 1 to 5, and we just deleted the other values. So that's how guys, basically you can also export and import data. It's really simple in pgadmin. Now finally, coming to the final topic for today's session, that is the UUID data type. Now the UUID data type is basically the data type which is based to uniquely identify a particular value, right? For example, as I was talking in employee, I said SSN, right? So for every value, I had to insert an SSN. Basically, I had to insert a value. Maybe if you don't want to do it, what you can do is you can just directly use this particular extension, and then you can directly use that particular value. So now let me just shift back to my pgadmin. Now let me close this particular part. Let me scroll back. And now let's say, we want to see first what are the available extensions, right? So I'll just type in select star from pg-available extensions. So I'll mention this and I'll click on execute. Once I click on execute, you'll see that, we have name, we have default value, we have installed version, and we have comment, right? So we have a lot of available extensions. But what I want to use is the UUID OSP, right? So if I scroll down more, you'll see this particular one, right? That is UUID OSP. That's what we want to use over here. So initially, if you do not have this extension, what you can do is you can just create this extension. So you'll type in create extension and mention if not exists, and then you'll mention UUID-OSP. So this has to be in single quotes, and then you'll just execute this. So let me just execute this by dragging this down. So it says it's not fine. Oh yes, it has to be in double quotes itself. That was my bad. So when you create extension if not exists UUID OSP, you see an output of create extension. Now what you can do is you can just directly select from the available extensions. Now once I create the extension and then if I select UUID generate v4, you'll see that automatically a new ID is getting generated, right? Now the next time I execute this particular statement again, you'll see that a different ID will be generated. So that's how basically you can use UUID as a primary key for the table. So for example, in the social security number of employee table, you could have used this. Now in that scenario, you don't have to sit and mention the SSN over there. You can just put the specific function, that is UUID_generate v4, and automatically you'll see that every time you hit the query, you'll see a new ID will be generated, right? So guys, that was all about UUID data type. Now you can use UUID data type as a primary key to uniquely identify your data type. What is database management system and what are its different types? Database management system, or most commonly known as DBMS, is a software application used to access, create, and manage databases. With the help of DBMS, you can easily create, retrieve, and update data in the databases. A DBMS consists of a group of commands to manipulate the database and also acts as an interface between the end users of the database. So if I have to just summarize DBMS for you, then DBMS allows the users to define the data, to update the data, to retrieve the data, and also for the administration of the users. When I say define the data, it allows the users to create, modify, and delete the definitions which define the organization of the database. When I say update the data, what I mean by that is that it provides access to the users to insert, modify, and delete the data from the database. Coming to retrieve data, it allows the users to retrieve the data from the database based on the requirement. And finally, coming to administration of users, it registers the users and monitors their action and enforces data security, maintains data integrity, monitors performance, and deals with the concurrency control. So guys, that was about DBMS. Now there are mainly 4 types of DBMS, that is the hierarchical DBMS, the network DBMS, the relational DBMS, and the object-oriented DBMS. Talking about the hierarchical one, as the name suggests, this type of database management system showcases a style of predecessor and successor type of relationship. So you can consider it to be similar to a tree wherein the nodes of the tree represent the records and the branches of the tree represent the fields. Coming to relational database management system, this type of database management system has a structure which allows the users to identify and access the data in relation to another piece of data in the database. In this type of database management system, the data is stored in the form of the tables. Coming to the network database management system, the network database management system supports the many-to-many relationships wherein multiple user records can be linked. And finally, coming to object-oriented database management system, this type of database management system uses small individual softwares called objects, and here each object contains a piece of data and the instructions for the actions to be done with the data. So if you ask me a few popular database management softwares, then there are MySQL, PostgreSQL, Oracle, SQLite, MariaDB, and Microsoft SQL Server. Now, all these softwares are based on different types of database management systems available in the market. So it's completely based on the user's choice, or I would say your choice, on which type of database you want to work on and what type of DBMS would benefit you more. So I hope that you've understood what is DBMS and what are the different types of DBMS. Now let's move forward with the next topic for today's session, that is SQL. Structured Query Language, or pronounced as SQL or sometimes also known as SQL, is a standard language for dealing with the relational databases. Now to explain you further, let me take an example for you. Now if 2 people want to communicate with each other, then they have to use certain language which is understood by both of them, right? So if we consider these 2 people as one as the user and other as the database, then the language which is used to communicate between these 2 is nothing but the structured query language. So similarly, how a language has a grammar and various rules on how it could be used, even SQL has its own directives. SQL is effectively used to insert, search, update, delete, and modify the database records. And it doesn't mean that, SQL cannot do things beyond that. It can do things beyond that also. It can provide you integrity checking. It can also provide you with embedded DML, which is used for general purpose programming languages. It has various sets of commands to create different kinds of views, tables, and other networks to understand the database effectively, and many such more. So guys, this was about the basics of SQL and DBMS. If you want to learn more about SQL, then you can refer to our session on what is SQL, and I'm sure you'll get a better idea of what is SQL. But since this session is based on SQL Server, let's get into the main topic for today's session, that is what is SQL Server. Now, Microsoft SQL Server is basically a relational database management system which supports the structured query language and comes with its own implementation of the SQL language, which is known as the Transact SQL or the T-SQL. So it basically has an integrated environment to handle SQL databases, which is nothing but the SQL Server Management Studio. Now, the key components of SQL Server are, as you can see on my screen, we have a database engine, and this component is basically used to handle storage, rapid transactions, processing, and securing the data. Coming to SQL Server Service, this service is used to start, stop, pause, and continue the instance of the Microsoft SQL Server. Moving on to the next component, which is the SQL Server Agent. The SQL Server Agent service plays the role of the task scheduler and is triggered by any event or as per the requirement. Coming to SQL Server Browser, this service is used to connect the incoming request to the desired SQL Server instance. Coming to SQL Server Full Text Search, this is used to let the user run full text queries against the character data in SQL tables. Coming to SQL Server VSS Writer, this particular service allows backups and restoration of data files when the SQL Server does not run. Moving on to the next component, that is SQL Server Analysis Services, that is SSAS. This service is used to provide data analysis, data mining, and machine learning capabilities. The SQL Server is also integrated with Python and R for advanced data analytics. Coming to SQL Server Reporting Services, which is SSRS, as the name suggests, this service is used to provide features and decision-making capabilities, including integration with Hadoop. Finally, coming to the last component, that is SQL Server Integration Services, that is SSIS. This service is used to perform the ETL operations for different types of data from multiple sources of the data. So I hope that you have understood what is SQL Server. Now let's move forward with the next topic for today's session, that is features of the SQL Server. So the first one is user experience. So when I say user experience, what I mean by that is that SQL Server can be used on various operating systems like Windows, Linux, and Docker. So you just have to develop once and deploy anywhere with their consistent experience from on-premise to cloud, right? Not only this, but they make sure that you as a user get a consistent experience from on-premise to the cloud, and also provide easy to use tools and the connectors. So you can use the Azure Active Directory and the SQL Server Management Studio to manage your database infrastructure across on-premise SQL Server and also Microsoft Azure. So isn't that great, guys? Now moving on to the next feature is availability. So when I say availability, again, what I mean by that is that, SQL Server makes sure that, it provides high availability and disaster recovery. So with this, you can gain mission critical uptime, fast failover, easy to set up, and load balancing of the readable secondaries with the enhanced SQL Server versions. So you can get unified solutions for high availability and disaster recovery on Linux and Windows. Not only this, but you can also put up an asynchronous replica in the Azure virtual machines for the hybrid high availabilities. So that was about availability, guys. Moving on to the next feature, that is performance. So when I say performance, what I mean by that is you can scale your price and performance in a parallel manner. So SQL Server makes sure that your real world application performance benchmarks are set, and then your application using the SQL Server database is not failed down or is not turned down, right? So you can get great performance for your application, and it is also one of the highest performing data warehouses. Moving on to the next feature, that is analytics. So when I say analytics, what I mean by that is that SQL Server provides the built-in analytics, or you can say the built-in database advanced analytics. So with the help of the built-in analytics and the SQL Server machine learning services using R and Python, you can move beyond the reactive and into predictive and prescriptive analytics by performing advanced analytics directly within the database. So by using multi-threading and massively parallel processing, you'll gain insights faster than using open source R and Python. So guys, that is one major plus point of SQL Server. Now moving on to the next feature, that is security. So security, as the name suggests, I would say that it provides less vulnerable databases. So you can make sure that your data is protected in a proper manner, and it is less vulnerable to any other major attacks. Not only this, but you can also make sure that you have levels of security and compliance for the databases. Now coming to the final feature, guys, that is business intelligence. So obviously, as the name suggests, business intelligence is almost used in today's market in every company, and every company needs a manner to understand and visualize the reports and also gain insights, right? So SQL Server provides you with this feature and allows you to build comprehensive enterprise scale analytic solutions by benefiting from the fast performance of in-memory built into the tabular model. So basically what happens is that it reduces the time to insights using direct querying against tabular and multidimensional models. So guys, that were the features of SQL Server. So I hope that you have understood what is SQL Server and its features. So now that you know the basics of database management systems, SQL Server, let's move forward and install SQL Server. So to install SQL Server, what you have to do is you have to follow the steps that you can see on my screen. Initially, you have to install the SQL Server, and then you have to connect to the SQL Server using SSMS, that is the SQL Server Management Studio. After that, you have to access your database engine. I hope I'm clear with these points. All right, so let's start with the installation of SQL Server. So initially what I'll do is I'll install the SQL Server, then I'll connect to the SQL Server using SQL Server Management Studio, and then I'll access the database engine. Now to install the SQL Server, what you have to do is you have to go to this official website of Microsoft SQL Server download. Right, so I'll just go to this particular page. And once you go to this page, you see these two options, that is SQL Server 2017 on premises and on the cloud. Now what this means is that you can either use SQL Server locally on your system or maybe on the cloud. So now what you have to do is you have to scroll down this particular page and you will see this option of developer and the enterprise edition. So here I'll be downloading the developer edition. So to download, you just have to click on this option of download now. Now you can see that the application is getting downloaded. So once the application is downloaded, what you have to do is you have to double click on this particular file and then you will see a window opening up. So let's just wait for that to happen. So as you can see, our application is opening up. Now once the application opens up, you see various types of installation types, that is the basic type, the custom type, and the download media. So what I'll do is I'll just choose the basic type. So when you choose the basic type, you can select the basic installation type to install the SQL Server database engine feature with the default configurations. Just remember guys, when you're choosing the basic type, you're installing SQL Server with the default configuration. Moving on to custom type. So when you select the custom installation type to step through the SQL Server installation wizard, you choose the features, or I would say you choose the configuration based on your choice, right? So I would say if you're using it on an enterprise level, or maybe your complete company is using SQL Server, then I would say you can go forward with the custom installation, because you may have few features or you may want few configurations which must be same for the complete users, right? So that's when I would say you can go for the custom one. But if you're someone who is just using SQL Server on locally on your machine, and then you just want to get hands-on experience in that, I would say go for the basic one, right? So on that note, I'll just choose the basic one. And then once I choose the basic one, you can see that, we get this page of SQL Server license terms. So what you can do is you can just go through the license terms and then you can just click on accept button. So I'll just directly click on the accept button. And once I click on the accept button, you have to next specify the SQL Server installation directory, right? So that means where you want to install your SQL Server. So I'll just let it be as it is and then I'll click on install. Now once you click on install, you will see that all the required packages and the libraries are getting downloaded. Now let's just wait for the installation to complete. So as you can see, the computer requires a restart. So let me just restart my computer, right? So let's just restart. Now once the installation has completed, what you next have to do is you have to go to this customize option below to basically configure your SQL Server database, right? So I'll just click on this customize option. Now once you click on the customize option, this is a screen that you'll see. So over here, what you just have to do is you just have to click on next. And once you click on next, you'll basically see that the files are getting installed, right? So let's just wait for that to happen. And then you keep clicking on next. I'll tell you when you have to configure for something. So let's just wait for that to happen. All right. Now, once the installation rules are also done, the next thing that you have to do is you have to choose the installation type. So since we are performing a new installation, we'll just choose this option of perform a new installation of SQL Server 2017. But yes, if you had any pre-installed SQL versions, then you'll choose the second option, right? So I'll just choose this option of perform a new installation of SQL Server 2017, and then I'll click on next. Now in the next wizard that opens up, you have to choose basically the type of edition that you had installed initially, that is the developer edition or the enterprise. So since I downloaded the developer edition, I'll just choose developer. And then what I'll do is I'll click on next. Now after that, you have to read this license terms and then just click on this radio button of I accept the license terms and then click on next. Now in the next wizard that opens up, you have to choose the features which you wish to install. Also, you can choose the instance root directory and then click on next. So what I'll do is I'll just choose the features, let's say database engine, and then I'll let the root directory be the same and then I'll click on next. Now after that, what you have to do is you have to name your instance and then this will automatically return an instance ID, right? So I'll just name my instance, let's say Edureka, right? And once I mention my instance name, you'll see that, automatically my instance ID will be Edureka. So after that, what I'll do is I'll just click on next. Now in the server configuration wizard, just click on next. And then once you click on next, you'll be redirected to this database engine configuration. So over here, you have the Windows authentication mode and the mixed mode. So over here, what I'll do is I'll just choose the mixed mode and then I can mention the password, right? So I'll just mention the password and then I'll confirm the password. And then what I'll do is I'll just click on add current user and you'll see that, automatically a user has been added. So this particular user will be the admin. After that, as you saw, I just mentioned the password and then I'll click on next. Now, once we click on next, you can see the summary of the installation, like what are the properties or the features which will be installed. So you can just go through that, and then what you can do is you can just directly click on install. So I'll just click on install over here. And now let's just wait for the installation to complete. Now, once the installation is complete, this is the wizard that you see. That means that our installation has completed. So I'll just click on close, and then with this we finish our installation. Now the next step is to connect our SQL Server using the SQL Server Management Studio. So for that, what we'll do is we'll go back to this particular screen, and then I'll click on install SSMS. Now once you click on install SSMS, you'll see that you'll be redirected to a web page. So let's just wait for that to happen. So guys, this is the screen that you see once you click on install SSMS. Now what you have to do is you have to just click on this download option. So I'll just click on this download SQL Server Management Studio link. And then once I click on the link, you can see that the setup is getting downloaded, right? So let's just wait for that to happen again. All right. Now once the setup has been downloaded, just double click on this particular file. And then you'll see this particular screen. So over here, you can just choose the location or the installation directory for your SQL Server Management Studio. I'll let it be as it is, and then I'll just click on install. Now, once I click on install, you can see that our SQL Server Management Studio is getting installed. So let's just wait for that to happen. And once that is done, what we'll do is we'll basically access our database engine. So let's just wait for installation to complete. Now, once the installation is completed, you see that restart is required in order to do the complete setup. Now, once the SQL Server Management Studio is installed, you just have to open your SQL Server Management Studio from the Windows Explorer. So over here, you can just type in SQL Server, and then you'll see this icon. So you just click on open, and once you click on open, this is basically what you see. Now over here, what you have to do is you have to choose your server name. So you can just go for browse for more and just choose server name, and let's say we choose our desktop ID /Edureka, right? That is because that is the one that we chose. So we gave our instance ID to be Edureka, if you remember. So I'll choose that, and I'll click on OK. And then I'll click on connect. Now, once you log in, guys, this is the screen that you see. Now, the next thing that you have to do is you have to basically start your query editor, right? So before we get into the query editor and start using the commands, let's understand how does the SQL Server architecture look like. So the SQL Server architecture mainly has few components that you can see on my screen. So it has the server, it has the relational engine, the command parser, the optimizer, the query executor, and the storage engine. Coming to the server first, this is where the SQL services are installed and the database resides. Moving on to relational engine, this contains the query parser, optimizer, and the executor, and the execution happens in the relational engine. Moving on to command parser, well, this checks the syntax of the query and converts the query to the machine language. Moving forward with optimizer, this prepares the execution plan as the output by taking statistics query and the algebraic tree as input. Moving forward with the next component, that is query executor. Well, this is the place where queries get executed step by step, and the storage engine is responsible for storage and retrieval of data on the storage system, manipulation of data, managing and locking transactions. So you have a transaction log, and then you have a data file. You also have a storage engine which has the transaction manager, the access methods, and the buffer manager. After that, we have the relational engine. Well, the relational engine has the optimizer and the command parser, and the command parser is connected to the query tree. And similarly, we also have the query executor, which executes the query, and the optimizer optimizes the query. Finally, we also have a protocol layer which has the SNI, and then this is connected to the SQL Server network interface. Well, guys, this was about the SQL Server architecture on a high level. By now, I hope that you've understood and got a good understanding of the SQL Server. Now let's move forward and get into the SQL command categories, where there are mainly 4 command categories that we're going to consider. That is the data definition language commands, the data manipulation language commands, the data control language commands, and the transaction control language commands. Coming to data definition language commands, well, this consists of the commands that can be used to define the database schema. Moving on to data manipulation language commands, well, this deals with the manipulation of the data present in the database. Coming to data control language commands, well, this deals with the rights and permissions and the controls of the database system. And finally, coming to transaction control language commands, and this consists of the commands which deal with the transaction of the database. So I hope that you've understood what are the SQL command categories. So before we move forward with the first command category, that is the data definition language command category, let me talk a little bit about the SQL Server data types. Well, there are various kinds of SQL Server data types present. So when I say data types, I mean what kind of data can be stored in your databases. So you can store exact numeric data types, the approximate numeric data types, the date and time values, the character strings, the Unicode character strings, the binary strings, and many other data types. So talking about the exact numeric data type, well, the exact numeric data type is used to basically store the numbers. So in this data type, you have other data types like the numeric, the tiny int, small int, big int, and so on. Moving on to approximate numerics. Well, approximate numerics are used to store decimal or float value. So you have the float data type and the real data type. Coming to date and time, as the name suggests, this type of data type is used to store the date and time values in the database. So we have date, small date time, date time 2, and so on. Moving on to character strings. Well, this particular data type is used to store the character strings like char, varchar, text, and so on. The Unicode character strings are used to store the nchar, varchar, and text. After that, coming to binary strings, as the name suggests, again are used to store the binary values. So we have binary, var binary, and image values in this particular data type. And in the other data type sections, we have data types like the cursor, the row version, hierarchy ID, unique identifier, and so on. Well, I would say once you get a hands-on practice on how to write queries and how to manipulate data in your database, you'll definitely understand which type of data type you need to use or you need to use to define your columns. So I hope that you've understood. So on that note, let's start with the first language command category, that is the data definition language commands. So to demonstrate the data definition language commands, what I'm going to do is I'm going to write few queries and then I'm going to explain how you can use that. So now what I'll do is I'll just add a query pane. So to do that, what I'll do is I'll just go to this new query option, and then you'll see that, automatically our query pane opens up. Let me just zoom in a little bit. So now that I've zoomed in, let's get started with the session. So initially what I'll do is I'll just create a database. So to create a database, you'll type in a command create database, and then you'll mention the database name, right? So let's say I mention the database name to be students. Now after that, you just have to select this particular statement and click on execute. Now once you click on execute, you clearly see that the commands have completed successfully. So our database has been created. If I just refresh this particular section and then I go to databases, you see that we've got our students database, right? So now to perform any action in a database, you have to first use that database. So for that, you'll just type in use, and then you'll mention the database name to be students, right? And then what you'll do is you'll just execute again, right? And once you execute again, you'll see that the commands have been successful. So that means whatever actions that you're going to perform is going to happen under this particular database. Now after that, what you can simply do is you can just create a table, right? So to create a table, again, you just have to use this command of create table, right? So I'll just mention create table, and then you can mention the table's name. So let's say we just mention it to be students info, right? And then in brackets, what you have to do is you have to mention your column names and its data types. So the column names could be like student ID, let's say it to be of int, right? Next, let's say student name, let's say varchar of 8000. Similarly, we can have parent name, again of varchar, let's say 8000. After that, you can have phone number, let's say big int, because it's going to have a large value. After that, we can have address of a student, right? So I'll just mention address of a student, again varchar. Then I'll mention city, let's say varchar of 8000. Then I'll mention country, again of varchar of 8000. After that, you can just close this, and then once you do, you can just execute this particular statement. So after the statement is executed, what you can do is you can just refresh this particular section, go to databases, go to students, and in students, you'll see that if you go under the tables section, we find a table of students info. So that's how, guys, basically you can create a table also. Now, for example, let's say you want to drop a table. Now, dropping a table is also similar. You just have to use the command drop table, and then you mention the table's name. So that it is students info, right? So I'll just mention students info, right? And then what I'll do is I'll just execute. Once I execute, and then if I refresh, you'll see that our table is gone. So let's just wait for it to happen. If I go to table section, you see that there is no table present. So that's how basically you can create a table and drop a table. Now similarly, you can also drop a database also. So to drop a database, what you have to simply do is you just mention drop database, and then you mention the database name, which was students. So I'll just execute, and then once I execute, you see an error that we cannot drop the database because it's in current use, right? So what you can do is you can just create another database, let's say students1, and then we use students1, and then you can go back and drop this database of students, right? So once you drop this database of students, you'll see that a new database has been created, that is students1, and the students database has gone, right? So let's just wait for that to happen, right? So as you can see, we just have one database, that is students1, right? So that's how, guys, basically you can drop and create the databases and the tables. Now the next command that you need to know in the DDL commands is the alter command. But before we start with the alter command, what I'll just do is I'll just use this particular database, and then I'll just create back this table again, right? And then what I'll do is I'll just write the alter command. So for example, let's say you want to add a column of blood, right? So what you'll do is you'll just mention alter table, then you'll mention the table's name, that is students info, and then you'll mention add blood group. So that is basically a column name that we want to add. And then we'll mention varchar of 8000, right? And then I'll click on execute. Once I click on execute and go to tables, and then once we go to this particular table and go to columns on the left hand side, you clearly see that our blood group column has been added. Similarly, you can drop the same column also. So what you'll do is you'll just copy paste this, right? And then what you'll do is you'll just change the add function to drop function, right? So you'll mention alter table, and then you'll mention the table's name, and then you'll mention drop, and then you'll mention blood group varchar, right? So if I just execute this, oh, I'm sorry, I have to remove this particular data type also because we're not creating the column, right? So I'll just execute this particular statement again. All right, it says blood group is not a constraint. Now this is one of the most common errors, as people just remove the command and then try to remove that column. But what you have to do is you have to mention that it's a column, right? So for that, you'll mention alter table, table name, and then you'll mention drop column and then the column name. After that, you'll click on execute, and then once you click on execute and refresh, you see that our blood group column has gone. So that's how basically, guys, you can add a column or you can delete a column. Now, for example, let's say you want to add a column and then you want to change the data type also, right? So you want to do both. You want to add a column and then you want to change the data type also. So what you'll do is you'll just mention alter table. We'll just copy paste this particular statement, and then we'll mention alter table students info, that is basically a table name. And then let's say we want to add a date of birth column, right? So I'll just mention DOB over here, right? And let's say our data type to be date, right? And then I'll just execute. Once I execute, you see that our column will be added. Now what I'll do is I want to change the data type, right? So to change the data type, what you do is we copy paste the statement again, and then I'll just remove this particular part, and I'll mention alter column, and then I'll mention column name, so that was date of birth, and then I'll mention the new data type, right? So let's say I want it to be date time, right? So I'll just mention date time and close, right? So that's how basically you can play around with DDL commands, guys. It's very easy and it's very interesting to learn with. So guys, that was about the alter command. Now let's say you want to truncate a table. So when I say truncate the table, what I mean by that is that you want to delete the information present in the table, but the table itself is not deleted. But before that, let's just include some information into the table. So to include information, you have to mention insert into, and then you'll mention table's name, right? So that's students info, right? And then you'll mention values, and then let's say I mention few values, right? So I'll just mention, so I'll just execute this particular statement. Oh, it says column name or number of does not match the table definition. We see this error because I forgot to drop the column of DOB. So I'll just drop the column. So to drop the column, I'll just mention alter table drop column, and then I'll mention DOB, right? So let me just copy this particular section from here, and then I'll execute the statement. And once I execute the statement, I'll execute the statement again, and then you'll see that our values have been inserted. Now to truncate the table, what you have to do is you basically have to use the syntax of truncate. So you'll just mention truncate, and then you'll mention the table name. Our table name is students info. So I'll just mention students info, and then I'll click on execute. Once I click on execute, we see that the commands have completed successfully, right? Initially our columns had few values, but now our columns have no values over there, right? Apart from this, if you want to also rename a table or rename a database, you have to use the command of sp_rename. So this is something different from the other databases, as generally the rename command or the query is used. But in SQL Server, you have to use sp_rename, and then you'll mention students1, that is basically our database name. And then you'll mention students info. And now you'll mention what you want to change it to, right? Let's say we want to change it to info students, right? And then let's just execute. Okay, it says it cannot find. So I'll just remove this particular part and execute. And once I execute, you can see that, our table name has changed. So what I'll do is I'll just refresh this left-hand side and I'll go to students 1. I'll go to tables over here. And then you can see that, it has changed to info students. So I hope I'm clear with the DDL commands, guys. Well, these are a few basic commands that you need to know before you start handling and manipulating databases. On that note, let's take a look at the next topic for today's session, that is keys in the database. Now, the different types of keys used in the database are the candidate key, the super key, the primary key, the alternate key, and the foreign key. Now, coming to candidate key. Candidate key is a set of attributes which can uniquely identify a table. So a table can have more than a single candidate key, and out of the chosen candidate keys, a single key is chosen as the primary key. Coming to super key, this is a set of attributes which can uniquely identify a tuple. So candidate keys, unique keys, and primary keys are super keys, but the vice versa isn't true. Coming to primary keys, the primary keys are used to uniquely identify every tuple. So a table can have only one primary key, and that key will identify every tuple uniquely in the table. Moving on to alternate key, the alternate keys are those candidate keys which are not chosen as the primary key. And finally, coming to the foreign key is an attribute that can only take the values present as the values of some other attribute, and that is the foreign key to the attribute to which it refers. So guys, these were the various types of keys in database. So it's completely based on your understanding or how you want to design your database model, that which key should be primary key and which keys together can uniquely identify your table and so on. Apart from this, we also have few constraints which are very popular in the database. So next in the session, let's take a look at the popular constraints available in the database. So the constraints used in the database are not null, unique, check, default, and index. So talk about not null first. The not null constraint ensures that a column cannot have a null value, right? So that is very simple, as the name suggests. It ensures that, a column cannot have any null value. So if you just assign the constraint of not null to any particular column, then automatically you have to mention a value into that particular column to enter that particular tuple into the database. Coming to unique, the unique constraint makes sure that, all the values in the column are different. So basically, when you mention a constraint unique to a specific column, then automatically what happens is that all the values present in the column are unique. So 2 or more values cannot be the same. Coming to check constraint, this constraint ensures that all the values in a column satisfy a specific condition. So whenever you mention the check constraint, you'll mention a condition, and all the values which satisfy the condition can be present in that particular column. Any value which doesn't satisfy the condition cannot be present in that particular column. Moving on to default. Well, this constraint consists of a set of default values of a column when no values is specified, right? For example, let's say while entering values in a column, you forget to mention a few, but yes, while creating the table or maybe while adding a constraint, you add the constraint of default for that particular table, let's say 10. So all the places where you do not mention any value, 10 will be automatically added to that particular places. And finally, coming to the last type of constraint, that is index. This constraint is used to create and retrieve data from the database very quickly, right? If you want to create and retrieve data from the database very quickly, then you have to use the index constraints. So now that I've explained you keys and constraints in database, let me just switch back to my SQL Server Management Studio. And then what I'll do is I'll just execute few commands or queries based on this particular section. So let's get started. So what I'll do is I'll just copy this particular section from over here, right? And then let's say I just add a segment so that it's clear to us. And then I'll copy paste over here. And now let's say we want to use the not null constraint. So for example, let's say we want to make sure that, the student name and the address of the student is definitely present, or maybe when the user is entering values, it's mandate for the user to enter the student name and the address of student, right? So then what we'll do is we'll just mention not null constraint over here, right? And again, I'll just mention not null constraint over here, right? And then what I'll do is I'll just create this particular table, right? Now, once this table is created, what I'll do is I'll just copy paste this insert statement from over here. I'll paste this, and let's say, I just remove the address part, right? So I'll just remove this particular section, and then I'll mention null, and then I'll click on execute. When I click on execute, you can clearly see the error that, cannot insert the value null into the column because, the column does not allow null. That is because we've given the not null constraint to the address column, right? So that's how basically you can use the not null on create table. Now, similarly, if you want to use not null on the alter table, what you basically have to do is you just have to mention the alter table statement, and then at the end you have to mention not null. For example, let's say I want to mention alter table students info, right? And then I'll mention, let's say, alter column, and then I'll mention phone number, right? And let's say I mention int not null, right? And then I'll just click on execute. And once I click on execute, you can see that the command has been successful. So whatever happens, you cannot mention the null values in the phone number column. So guys, that's how basically you can use the not null constraint on the create and the alter table. Now let's move forward with the next constraint, that was the unique constraint. Also, while working on the unique constraint, let's just check how to add the primary key. So what I'll do is I'll just drop this particular table. So I'll just mention drop table students info, right? I'll just execute, right? And then what I'll do is I'll just copy paste this section, paste it over here. So what I'll do is I'll just mention the unique constraint over here, and then what I'll do is I'll mention primary key, and in brackets I'll mention student ID, right? After that I'll just click on execute. And once I click on execute, you can see that the student ID will be unique. So every ID will be unique, and since every ID will be unique, it will uniquely identify every tuple. So that could be the primary key. So that's how basically you can add the unique constraint for a single column. Now let's say you want to add unique constraint for multiple columns, right? So similarly, what I'll do is I'll just drop this table again. I'll copy paste the section, paste it over here, remove the student ID, and remove unique constraint from over here. And then what I'll do is I'll just mention constraint, right? And then I'll mention the constraint name that I want to give. So it could be UC, let's say students info, and then I'll mention unique, and in the brackets I'll mention student ID, and let's say we want the phone number also to be unique, right? So we'll mention a phone number, right? And then what I'll do is I'll just execute again. So once I execute again, you can clearly see that our table has been created. So if I just refresh on the left hand side, right, and then what I'll do is I'll just go to the constraints part over here, or you can go see that if I go to the column section over here, you can see that our constraints are clearly visible on the left hand side over here. Also, if I go to the key section, you can see that our students info constraint, which I just mentioned over here, is clearly present over here. So that's how guys basically you can add unique constraint on multiple columns. Now similarly, if you want to add unique constraint on an alter table, it's very simple. You just have to mention alter table, and then what you do is you mention the table's name as we previously did, and then we'll mention add, and we'll mention the constraint, that is unique constraint, and over here we'll mention the column on which we want to add the unique constraint, right? So I want to add it on my student ID, so I'll mention student ID, and then I'll just execute. Right, so that's how basically you can add a unique constraint on an alter table also. Now similarly, if you want to drop the constraint also, guys, you just have to mention alter table, and then you'll mention students info, and then what you'll do is you'll mention drop, and then you'll mention constraint, and then you'll mention the constraint's name, right? So for example, let's say I'll mention this particular name, and then I'll just execute the statement. Now if I just refresh this left hand side, and let's just open again, so I'll go to tables, I'll go to students info, and then if I'll just refresh, so I'll go to tables, I'll go to students info, and then if I go to keys, we see that there's no UC students info constant present, but then this particular constant that we had just added before on the alter table statement, that is present. So that's how basically you can add the unique constraint. Now let's move forward with the next type of constraint, that is the check constraint. Well, the check constraint, as I previously mentioned, is used to add a condition, right? So for example, let's say you want to add the check constraint while creating the table itself. So to do that, what I'll do is I'll create a table, but before that, let me just drop this table again. And now what we'll do is we'll just copy paste this particular section, put it over here, remove this part, and let's say we want our country to be India. So all the values which could be entered into the table must have the country value to be India, right? So we'll just mention check over here, and then in brackets I'll mention country equal to, I'll mention India, right? And then what I'll do is I'll just execute this particular statement. So after that, let's say if I want to insert a statement, so for that I'll just copy paste this particular section. Let's say I put it over here, and over here, let's say I just mention any value like nice road, right? And let's say we mention over here Germany. right? And I'll just try to execute. And once if I try to execute, you can clearly see the error that, insert statement conflicted with the check constraint. The conflict occurred in the databases because, the column country has to be India, right? And then we have mentioned Germany. So now what you can just do is you can just go back, change the country to India, and then you can insert the value. So that's how you can use the check constraint on the create table. Now let's say you want to use the check constraint on the alter table. Now similar to that of the unique constraint, what you'll do is you'll just mention alter table, and then you'll mention the table's name. And then what you'll do is you'll just mention add check, and in brackets you'll mention country equal to India, and then you'll execute. Now that's how basically you can add the check constraint on the alter table. Similarly, if you want to give the name to the check constraint, well, that's not necessary that you always give the name, but yes, if you're handling on an enterprise level and then you're handling a lot of databases, then giving a name must be a priority, right? So to add the name, what you simply do is you just use this alter table statement again, right? And then you'll mention the table name. And over here, you have to add constraint, right? And then you'll mention the name. So let's say I mentioned the check, let's say constraint name, right? And then what I'll do is I'll mention the check condition, and that is India, right? So if I just execute the statement again, you'll see that it completely works. And if I refresh on the left hand side, go to tables, go to students info, go to constraints, you'll see that a constraint name has been added up, right? Now similarly, you can drop a constraint. Well, dropping a constraint is again same. You have to use alter table students info, and then you just mention drop constraint, and you can just mention the drop constraint name. So I'll just execute this particular statement again, and you'll see that a constraint has been dropped. So guys, that was about the drop constraint. Now let's go forward with the default constraint. Well, the default constraint, as I previously said, is used to add the default value. So what I'll do is I'll just drop this table again, right? And then what I'll do is I'll just copy paste the section, paste it over here. I'll just remove this particular section, and then let's say our default country value is India, right? So I'll just mention default, sorry, spelling mistake, and then I'll mention India. So basically all the values which will be inserted into the table will have the default value India. So whenever there is no value that you enter, for example, let's say you are entering 10 values, and out of 10, 5 you have entered as Germany and 5 you have not entered any of them, then all those other 5 will get the value as India, right? So I'll just execute this particular statement, and then what you can just do is you can just check with the insert statement. So now similarly, if you want to add the default constraint with the alter table, you just have to again use alter table students info, and then what you'll do is you'll just mention add constraint, and let's say you give the constraint name to be, let's say default, let's say country, right? And then you'll mention the condition, that is default, which will be India, and then you'll mention the column name, which is country, and then I'll click on execute. All right, it says that the column is already born. I'm sorry. So what we'll do is we'll add, let's say city, and we'll just change it to city over here, and let's say we change it to HYD, right? And then I'll execute again. Once I execute, you can see that it's clearly working. Now to drop the default constraint also, it's very simple. You'll right click over here and just choose delete, and then once you choose delete, you can just choose the object name and click on OK. Right? So once you click on OK, you'll automatically see that your default constraint has been dropped. Now one more way to drop the default constraint is by using the alter table. You just have to mention alter table students info and then mention drop constraint, and then you'll just execute this particular statement, right? So that's how basically you can drop the constraint, guys. Now let's move forward with the next constraint, that is the index constraint. So the index constraint, as I said, is used for the fast creation and retrieval of the database. So for that, you'll mention create index, and then let's say we mention the index name to be, let's say student name, right? And then I'll mention on which table, that is the students info table, right? And then on which column. So we want student name from the students info table, right? So I'll just create this particular index, right? And then what I'll do is I'll just refresh this particular section. And over here, what I can do is I can go and check on my left hand side. Now, if you want to delete your index constraint, what you'll do is drop index, and then you'll mention the index name. So I'll just mention index name, and then I'll click on execute. It says that we must specify the table name and the index name. So I'll just mention the table name also. So I'll just mention table name dot index name, right? And then I click on execute, and then you can see that our index constraint has been dropped. So that's how, guys, basically you can create, alter, and drop your constraints. I hope you've understood what are keys and constraints and how you can manipulate your data based on those keys and constraints, right? Now let's move forward in the session and go to the next SQL command category, that is the data manipulation language commands. So the data manipulation language commands are used to manipulate, or I would say retrieve the data in the databases based on your requirement, right? So to do that, what I'll do is I'll initially insert the values into the table, and then what we can do is we can just manipulate the data. So what I'm going to do is I'm going to show you the use command, the insert command, the update command, delete, merge, the select commands, the cube, the roll up, offset, fetch, top, and pivot. And apart from that, we'll also discuss the various kinds of operators which can be used. So without any further ado, let's get started. So initially, as I was talking about the use command is used to use a database, right? So to use a database, as I just mentioned previously, you just mention the command use and then you'll mention the database name, that is students1. Now after that, what you have to do is if you want to insert values, then you insert the values using the insert statement. So as you can see on my screen, it's insert into and then you mention the table name, values, and then you can mention the values required. So now what I'll do is I'll just drop this particular table so that all the constraints are removed, right? So I'll just mention drop table students info. And then again, we'll create a table, right? So I'll just copy paste from over here. Right, so once I just create this table, what I'll do is I'll just mention the insert commands, right? So since I've already explained you the insert statement before, I'm not going to do that again. So the insert statement is simply used to insert the values. So there are mainly two ways through which you can insert the values into the table. Either you mention the column names and then you mention the column values, else you can just mention the column values, right? So I'll mention insert into students info and these are the column names and then these are the specific values. Similarly, if you mention insert into values and then we can mention all the values which need to be inserted into the table, right? So I'll select all of them and then I'll execute. And once I execute, you can see that, the table has values. So to check whether the values are inserted or not, what you can simply do is you can just type in select star from, let's say, students info, right? So we'll mention students info and then I'll execute. And once I execute, you can see that, all our values have been inserted. Now, let's say, you want to update some data present in this particular database, right? For example, let's say for student ID with student ID 1, let's say we want to set the student name to be Ahana and then city to be Ahmedabad, right? So what I'll do is I'll mention update and then I'll mention students info and then I'll mention set student name, that is basically a column name, right? And then I'll mention the value, that is, let's say Ahana, right? And then also I'll mention city. Don't forget to put a comma over here. Right, so I'll mention city equal to Ahmedabad, right? And after that, what I'll do is I'll mention the condition where student ID equal to 1, right? And then I'll just execute this particular statement. And once I execute the statement, let me execute this particular statement again. And then you can see that, the student name has changed to Ahana and the city has changed to Ahmedabad. So that's how basically you can update your data, guys. Now, let's say you want to delete data from database. So to delete data, you'll just mention delete from and then you'll mention students info where, and then let's say we want to delete the tuple with the student name Ahana, right? So I'll just mention student name equal to and then I'll mention Ahana. And then if I just execute this particular statement again, you see that our student ID with the student name Ahana has been gone. So guys, that's how basically you can insert, update and delete values present in a database. Now let's say you want to use the merge command. Well, the merge statement is used to perform the insert, update, delete operations on a specific table where the source table is provided. So when you have two tables, let's say table A and table B, and then let's say table A is the target table and table B is the source table, and then we have few matched rows. So when we merge both these tables, we can see that we can perform the insert, update, delete operations on the tables, right? Well, the syntax to perform the merge operation is very simple. You just mention merge and then you mention the target table name using the source table name. And then you mention the merge condition. And then if it matches, then you mention update statement. If it does not match, then you can mention the insert statement. And if it does not match by any source, then you mention the delete statement. So to understand the merge statement, let's just say we create two more tables, right? So what I'll do is I'll just create table, let's say sample source table, and let's say the columns to be student ID of in type, right? And then I'll mention student name of, let's say, varchar 8000 again, right? And then we'll mention the marks column of in type. Now similarly, I'll just create the target table also. So before executing, I'll just change the name to target. right? So I'll just mention sample target table, and then I'll just execute both these statements. Right now, after that, what I'll do is I'll just insert few values into the source table and the target table. So I'll just mention insert into, and then we'll mention sample source table. And then let's say we mention values, and over here we mention, let's say, first person with name Vihan, and let's say the marks to be 87. Similarly, let's just mention 2 more records, right? So I'll just copy paste, right? I'll just change this to 2, 3. Let me change the names and the marks. Now similarly, I'll just insert it to the target table also. So I'll just change the table name to be sample target table. So I'll copy paste from over here. And then I'll let the first record be the same. Let's say 1 Vihan and 87. And let's say we change it to 67. And 3 Saurabh. And let's say we change it to 55. Now what I'm going to do is I'm going to merge both these tables. That means I'm going to merge the sample target table, and then I'm going to merge it by using the sample source table, right? So for that, I'll mention the statement merge sample target table, and then I'll mention target, using, and then we'll mention the source table. So it will be sample source table, and then I'll mention source on, and in brackets I'll mention target dot, let's say we match it to student ID. That is basically a condition must match our source student ID, right? So we'll mention source dot student ID. So when it matches, what we want to do is when matched and target dot student, let's say name is same as source dot student name, right? Or target dot we want marks is same as, let's say, source dot marks, right? Then we want it to update set, we want to update target dot student name equal to, oh, I'm sorry, the target spelling is wrong, source dot student name, right? Comma, we also want to match the marks, right? Target dot marks equal to source dot marks when not matched by target. Then we want to insert, right? So we'll mention insert, and in brackets we'll mention student ID, comma, student name marks, right? And we'll mention values, we'll mention source dot student ID, similarly source dot student name, and source dot marks, right? And after that, when it doesn't match, right? So what we want to do is when not matched, we want to delete, right? So we'll just mention by source, then delete, right? So I hope that you've understood, right? So what I'll do is I'll initially insert the values into the sample source table and the target table, right? And then what I'll do is I'll just show you what are the values present. So I'll just mention select star from sample table, that is our sample source table. So you can see that we have 3 tuples, that is with Vihan, Mansa and Ane having 87, 92 and 74. And then when we have the sample target table, we have again 3 tuples with Vihan, Mansa and Saurabh having 87, 67 and 55 marks. So now what I'll do is I'll just include this merge statement, spelling mistake, right? So I'll just mention when not matched, and then I'll just execute. So when I execute this particular statement, you see that 2 rows have been affected, and then we see completion time, right? So if we just again click on sample target table, we see that we have our target table now having Vihan as 87, Mansa as 92 and Ane as 74. Initially our target table had Vihan as 87, Mansa as 67 and Saurabh as 55, right? So that means our values have changed and our values have come from the source table. So that's how, guys, basically you can merge 2 or more tables. Well, that was about merging column, guys. Now, since I was using a lot of select statement, let me show you a few actions which you can perform on the select statement. So for example, let's say you want to select a few columns, right? You'll just mention select and then you'll mention the column name. So let's say I'll mention student ID and let's say we mention student name, right? So there should be a comma over here from students info, right? So if I just execute this particular statement, you see all the values of student ID and student name from the students info table. Now similarly, if you want to select all the columns, you'll just mention select star from the table name. So that's how you can use the select statement. Now let's say you want to select the top 3 records from the table. So you'll just mention select top 3 star and then you'll mention the table name. So that will be, let's say, students info. And when I execute this particular statement, you see that, we get the top 3 statements. That is the values for the second student, third student, and the fourth student. Now, similarly, you can also find out the distinct values in a specific column also. For example, let's say we want to find out the distinct cities present, right? So we'll just mention select distinct and you'll mention city from and you can mention students info. Right, and then let's execute. If I execute, you can see that we have Mumbai, Bangalore, Delhi, Kolkata as the distinct cities present. Now moving forward, let's say you want to use the order by, group by, and the having clauses in the select statement. Well, to do that, it's really simple, guys. You just have to use those clauses. For example, let's say you want to select all the students from the students info table sorted by the, let's say, parent name. So for that, we'll mention select star from students info and then we'll mention order by parent name, right? And over here, if you do not mention anything, it will be ascending order by default. But let's say if you want it in a descending order, you'll just mention the keyword descending, right? And then you'll click on execute and you can clearly see that, our students are sorted by the parent's name. So it starts with S and then goes to A. And then if you just remove this particular section and then you execute again, you'll see that, our fifth student with the parent name Agarwal will be first on the list. Now that's how you can use the order by statement. Now this was just for one column. Now let's say you want to sort the data present in the table with different columns, right? So let's say we want to sort the students from the students info table by parent name and also the student name. So we'll just mention student name and then what I'll do is I'll just execute. And when I execute, you can see that, since we haven't mentioned anything, whether it should be ascending or the descending order, automatically the parent name comes in the ascending order. So our fifth student comes first on the list and then the order follows. Similarly, if you just replace this, so for example, if you just put the student name first and then you mention the parent name and then you execute the statement, you'll see that the results are different because our student name will be first sorted in the ascending order. Now apart from this, what you can also do is you can sort the data present in the table either in the ascending order or in the descending order for different columns, right? So what I mean by that is that student name can have the ascending order and the parent name can definitely have the descending order. So let's do the same. So I'll just mention ascending over here. And over here, I'll mention descending, right? And then I'll execute. So once I execute, you'll see that, the student names are sorted in the ascending manner and the parent names are sorted in the descending manner. So that's how all the students in the student info can be sorted by the parent name in the descending order and the student name in the ascending order. So guys, that was about the select statement. Now, this is one of the most popular statement which is used while manipulating data in the databases because, this is one of the easiest way to retrieve data. And this statement is used with a lot of commands and other queries to retrieve data in the format the client wants. Now, moving forward in the session, let's say, we want to list the number of students from each city. Now, to list the number of students from each city, what you have to do is you have to take care of the aggregate functions. So the aggregate functions are basically those functions which are used to calculate the sum, the average, the count, and the range, the first, and so on. So don't worry, I'll be talking about them later in the session. But for now, if I just have to implement and show you, you can just mention select count and then you can mention, let's say, student ID, right? And then you can mention city from the table name, that is students info. And then what you can do is you can simultaneously group them by city, right? So because we want to count the number of students from each city, we just group them by city and then we use the count function. And then we execute the statement. You see that, Mumbai has 1 student, Bangalore has 1, Delhi has 1, and Kolkata has 1. So guys, that was about this particular query. Now let's say you want to use the grouping sets. Well, grouping sets were introduced in SQL Server 2008 and were used to generate a result set that can be generated by union all of the multiple simple group by clauses. So the syntax is also very simple, guys. You just have to mention select and then you mention the column names. From the table name, group by, and then grouping set, and in the brackets you mention all those column names which have to come under the grouping sets. So for example, let's say I'll just modify this particular query, right? So I'll just mention select and then I'll remove the count function. Let's say I mention select student ID and let's say I also mention student name, right? And then I count the number of cities from the students info table and then I group by and then I again use the grouping sets. So I'll mention grouping sets and in brackets what I'll do is I'll mention the grouping sets, right? So for example, let our first set be student ID, student name, right? So let me just press on enter so that's clear. And also let's say we have city. Now let's say in the other set we just have student ID, right? And in the next one I just have student name, right? So I'll just put in the bracket. And in the last one, let's say we just have a city, right? So these are various sets that we have created, right? And now we can just execute this particular query. You can see that, student ID, student name, and no column name, that is basically a count of city from students info. And then it's grouped by basically these 4 sets, that is student ID, student name, city in one set, student ID in the second set, the student name in the third set, and the city in the fourth set. For example, let's say for student ID, which is null, and student name is null, the count is 1. So guys, that's how you can use the group by clause and the grouping sets together. Now let's say you want to use the having clause. Well, the having clause is generally used in the scenario where the where keyword cannot be used, right? So if you observe generally in the select statements, we use the where keyword. So in the scenario where the where keyword cannot be used, we use the having clause. So let's say, if you want to use the having clause, let's say we want to count the number of students from a specific city. And let's say, their count should be 1. And should be ordered by, let's say, student ID with descending order, right? So what we can do is we'll do select count and then I'll mention student ID, comma city, and then I'll mention from obviously the table name, right? Students info, and then I'll mention group by city, having count, and then over here I'll mention student ID again equal to 1. Equal to 1 has to come out. And then let's say we order by count, let's say student ID in the descending manner, right? So I'll just execute the statement. We can see that, Mumbai, Bangalore, Delhi, and Kolkata have come with their count having 1. So that's how you can use the having clause, guys. Now let's say you want to create a backup of this table, that is the students info table. So to do that, what you'll do is you'll just mention select star into, and you'll mention the backup table's name. So let's say we mention students backup from, and then I'll mention the table name, that is students info, right? And then I'll just execute and then you'll see that automatically the backup has been created. Now this is where we just included all the columns and the tuples from the students info table to the students backup table. Now let's say you just want to select only few columns from the students info table. Well, to do that, what you'll do is you'll just mention few columns, that is select, and then you'll mention A, B, C column from the table. Apart from this, you can also mention conditions also. For example, let's say you want to retrieve only those students who are from the city Pune. So you'll just mention whatever column values that you want to retrieve, like select student ID, student name, and so on into the table, that is the table name, from students info where the city will be Pune. So for your better understanding, let's just write that. So select star into, let's say we mention Pune students from students info where city is equal to Pune, right? And then I'll just execute. So if I just execute this particular statement, you'll see that, we have no values present because there was no student with the city Pune. So now what you can do is you can just go back and change the city name and then maybe drop the table and create the table again. So that's how you can play around with the select statement, guys. Now let's move forward with the next DML command, that is the 𝐶ube command. Well, I would say that, the 𝐶ube is an extension of the group by clause. So it basically allows you to generate the subtotals for all the combinations of the grouping columns specified in the group by clause. So for example, let's say, you want to use the 𝐶ube statement. So what I'll do is I'll just mention select student ID, right? And let's say we also mention count, we mention city from students info, and then we mention group by, and then we mention 𝐶ube, and I'll mention student ID order by student ID, right? And then I'll just execute. So when I execute, you can see that, we have 4 students. So each student belongs to a single city. Now, similarly to the 𝐶ube statement, you can use the roll-up statement. So the rollup is again also an extension of the group by clause, and this allows you to include the extra rows which represent the subtotals. So these are referred to as the super aggregated rows along with the grand total row. So similarly to that of the cube clause, I'll just mention for the rollup clause. So I'll mention select student ID, count city from students info, group by, and then over here I'll mention rollup, and then I'll just remove this order by statement, right? So you can just click on execute, and then you'll see that the null equal to 4 will come at the bottom of the table. So when you executed the cube statement, what you observe was that the super aggregated value, that was basically the subtotal, came in the first row, but when you execute the rollup statement, you see that it comes in the last row. So that was about the cube and the rollup, guys. Now moving on to the next DML command, that is the offset clause. The offset clause is used with the select and order by statement to retrieve a range of records. It must be used with the order by clause since it cannot be used on its own. Also, the range that you mention must be equal or greater than 0, right? So if you mention a negative value, then it shows an error. So to demonstrate this, let's just create a table, right? So I'll just mention create table, let's say offset marks, and then I'll mention marks int. So that will be our table column, right? And then what I'll do is I'll just insert values into this, right? So I'll just mention insert into, and let's say I'll mention offset marks, and let's say I mention a few random values, right? So initially I'll just execute this particular statement, and after that what I'll do is I'll just execute this statement. But before that, I forgot to mention values over here, right? So I'll mention values and execute this, and similarly I'll execute the other statements. So let me just copy paste, and I'll just change the values over here, and then I'll execute again. Now after that, what I'll do is I'll use the offset statement. So I'll just mention select star from, I'll mention the table name, that is offset marks, order by marks, and then we want to mention offset one row. So that means our first value, which had 61. So when we use this order by marks, we see the table values to be sorted on 61, 62, 64, 65, and 65. And after that, when we say offset 1 marks, the first tuple will be deleted. So that is the reason we get only 62, 64, 65, and 65. So that's how we can use the offset statement, guys. Now let's move forward with the next one, that is the fetch statement. Well, the fetch clause is used to return a set of number of rows. So it has to be used in conjunction with the offset clause, right? So to do that, what we'll do is we'll just mention select star from offset marks, and then we'll mention order by, let's say, marks, right? And then what we'll do is we'll mention, let's say, offset 3 rows, and then fetch next 2 rows only, right? So we'll just fetch the next 2 rows after leaving the first 3 rows, right? So if I just execute this particular statement, we get the 2 rows, that is 65 and 65. Now similarly, you can also select the top 3 records from a table by using the top keyword, as I had mentioned previously also. So if you just mention select top 3 star from offset marks, you'll get the top 3 tuples from the table. So guys, that was about the offset clause and the top clause. Now let's move forward with the next one, that is the pivot. Well, the pivot is used to rotate the rows to column values and run aggregations when required on the remaining column values. Now the syntax of pivot is also very simple, guys. You just mention select non-pivoted column name, and then you've mentioned first pivoted column name as a column name, and then so on till the last pivoted column name as a column name from, and then you mention a select query which produces the data as a pivot, and then in the pivot section you mention the aggregation function for the column name. So what I'll do is, to give you a detailed understanding, I'll consider an example. So I'll just create a supplier table which has a supplier ID, the days of manufacture, the cost, the customer ID, and the purchase ID, right? Our supplier ID should not be null, right? And then what I'll do is I'll just insert few values into it, right? So let me just execute this statement first, right? After that, I'll just go back and then copy paste this section. And then what I'll do is I'll just insert. After the values have been inserted into the table, now what I'll do is I'll just select the customer ID, the average cost, as the average cost of the customer from the supplier table, and then I'll group it with the customer ID, right? So for that, I'll just type in the command select customer ID, comma, average of cost as, and then I'll mention, let's say, average cost of customer from supplier table, group by, let's say, customer ID, right? And then I'll just execute the statement. So once I execute the statement, you see that we have the customer ID 11, and then the average cost of all the customers with the customer ID 11 is 1676. Similarly, all the customers with the customer ID 22 have the average cost of customer as 4654, and similarly for the third one, that is 33, we have 5238, right? Now what we're going to do is we're going to create a SQL pivot table with 1 row and 3 columns. So over here, if you observe, we had 3 rows. Now what we'll do is we'll just create the pivot table with 1 row and 3 columns, right? So for that, we'll just type in the command select, let's say, average cost of customer as, let's say, we just change it to cost according to customers, right? And then we mention 11, 22 and 33, and then we mention from, and in the inner section we mention select customer ID, right? And then we mention cost from supplier table as, let's say, source table. And then what we'll mention is we'll mention pivot, and in brackets we'll mention average cost for customer ID, and in brackets we'll mention 11, 22, 33 as pivot table, right? So I'll just mention pivot table, right? And then I'll just close, right? So I've just mentioned select average cost of customer as customer according to the customers 11, 22, 33. So we have 1 row and 3 columns. We want to select customer ID and cost from the supplier table as source table, and then continue, right? And so I'll just execute. So once I execute, you can see that, the average cost of customers has been named as customer according to the customers, and we have 11, 22, 33. So over here, if I just drag, you can see that, the average has been put over here. So basically in our previous table, which were rows, have now become the columns. So that's how, guys, you can create a SQL pivot table. Now, similarly, you can unpivot it also. For example, let's say I create a table, sample table, and in that I mention supplier ID, let's say int, AAA of int type, let's say BBB of int type, and CCC of int type, right? And then I just type on go, and then I mention insert into, let's say, sample table, and then I mention values, right? In brackets I'll just mention, let's say, 1, 3, 5, 6, right? Similarly, I'll just mention the other values also. So let me just copy paste, right? And then I'll click on go. So I'll just execute the statement, right? And now what I'll do is I'll just show you the value. So I'll just mention select star from sample table, right? And I'll just execute this. Once I execute this, so you can see that, we have 3 rows and 4 columns, right? So we have the supplier ID, and then we have AA, BB, and CC. Now what we'll do is we'll unpivot it. So to unpivot it, what you have to do is you have to mention select, let's say, supplier ID. That is basically a column names, and then we'll mention customers, and let's say products from, and in brackets again I'll mention select supplier ID, and then I'll mention AAA, BBB, and CCC, and I'll mention from sample table, right? So I'll just give a space, give sample table, and then I'll mention unpivot, right? And over here I'll mention products for customers in, and in brackets again I'll just mention the values, that is AAA, BBB, and CCC as, let's say, example, right? And then I'll just put on go, right? And then I'll click on execute. Once I click on execute, you can see that, what we had as 4 columns and 3 rows has now been converted, right? So for every customer that is AAA, the products show 3. The values that we have entered previously are shown. For example, let's say AA, which had value 398, are now put into 3 different rows. Similarly goes for BBB and CCC. So that's how you can unpivot the table also, guys. Well, that was about a little bit section of the DML commands. Now, if you want to know in depth about SQL pivot and unpivot, I'll leave a blog link in the description box below, and you can refer to that. Well, guys, that was about this part of the section. Now let's move forward with the next part of the session, that is operators. Now, I would say operators is a very important part of the session because operators play a very important role to handle and manipulate data, or I would say different ways to retrieve the data, right? So the different operators present in the SQL Server are the arithmetic operators, the assignment operators, the bitwise operators, the comparison operators, the compound operators, the logical, the scope resolution operators, the set operators, the string concat, and the aggregate functions. So talking about the arithmetic operators first, well, the arithmetic operators have the addition, subtraction, multiplication, division, and the moduli sign, right? So you can just add, subtract, multiply, divide, or find the remainder. Coming to assignment, the assignment operators are used to assign a value to the variable. Coming to the bitwise operators, the bitwise operators are used to perform the bitwise and, or, and exclusive or operations. Moving on to the next operators, that is the comparison operators. Well, the comparison operators are the relational operators which are used to perform comparison operations like greater than, less than, equal to, greater than, equal to, not equal to, less than, equal to, and so on. Moving on to the compound operators. Well, the compound operators are used to perform the compound operations of addition, subtraction, multiplication, division, moduli, and function, or function, and the XOR function. Coming to logical operators, well, the logical operators are used to perform logical operations between the data. So these are generally used in the nested queries. So the different kinds of logical operators are, as you can see on my screen, like all, and, any, between, exists, in, like, not, or, and some, right? I'm not going to go into the depth of each one of them because, it's completely based on your understanding of how which operator will benefit you better. But I would say the more you practice, the more you will have an understanding about the different operators. Moving on to the next type of operator, that is the scope resolution operator. Well, this operator is used to define the scope. And after the scope resolution operators, we have the set operators. So in the set operators, we have the union operator, the intersect operator, and the minus operator. So the union operator is used to combine the rows from both the queries. So when you have a left query and right query and you perform union operator, and then you apply the union operator, then automatically you will see that, it will combine rows from both the queries. Coming on to the intersect operator, well, the intersect operator is used to keep the rows which are common in both the queries, right? So for example, there could be few common queries in both the left query and the right query. Then when you apply the intersect operator, only those queries will be taken into account. And finally, coming to the minus operator, the minus or the except operator is used to keep the rows from the left query which are not present in the right query, and the vice versa, right? So when you have two queries or the two tables, let's say left query and the right query, when you say A minus B, then it keeps all the rows from the left query which are not present in the right query. And if you say B minus A, then it keeps all the rows from the right query which are not present in the left query, right? Now coming to string concat operators. Well, the string concat operators are used to perform various actions on the string, like, string concatenation, then wildcard characters to be matched, the wildcard characters which match just a single value or maybe multiple values and so on. And finally, coming to aggregate functions, as I previously spoke about in the session, aggregate functions are used to find the sum, average, count, min, max, first and last values. So all of these operators are very simple to use, guys. For your better understanding, let me give you a few examples, but I would say the more you practice, the more will you benefit, right? For example, let's say you want to use the arithmetic operator additions. You can just mention select 40 plus, let's say 60, and then you can just execute. Once you execute, you see the output as 100. Similarly, for example, let's say you want to use the comparison operators, let's say greater than, equal to, right? So for that, you'll mention select star from, let's say we choose the table offset marks where marks is greater than or equal to, and then you mention, let's say 62. And after that, you'll just execute. So you can see that, you will get all those tuples which have marks which are greater than or equal to 62. Now, similarly, you can also use the compound operators also. For example, let's just declare two variables. So I'll just declare, let's say @var1 of int type, let's say to be of 30, right? And then what I'll do is I'll just set it to be divided by, let's say 16, right? So for that, I'll just use this compound operator and then equal it to 16, right? And then I'll mention select @var1 as example, right? And then what I'll do is I'll just execute. Oh, it says that we must declare it first. I'll just declare it first, and then what I'll do is I'll just mention var1, right? I'll just set as 16. I'll just execute it again, and when I execute it again, you see the example as 1. That is because, when we divide 16 by 30, our quotient is 1. So similarly, if you use the moduli symbol over here, then you'll see the remainder, right? So I'll just execute it again, and then you see the remainder to be 14. So that's how you can use the compound operators. Now let's say if you want to use the logical operators, right? For example, let's say if you want to find out the marks between 62 and 65. what you'll do is you'll just mention select star from, and then you'll mention offset marks where, and then you'll mention marks, which is a column name, and then you'll mention between, and then you'll mention 62, and which is again a logical operator, and you'll mention 65, right? Okay, my bad, this has to be select, and then I click on execute. So we get all the marks between 62 and 65. Now, for example, let's say we want to find out those marks which are greater than 62 or marks which are equal to 67. So what we'll do is we'll just change this statement. So select star from offset where marks, and then we'll use a comparison operators are greater than 62 and, or I would say, or marks equal to, what did I say? It was 67. And then I'll execute again. And then you see that, marks greater than 62 are just 64 and 65. So we get that. And since there are no marks which are equal to 67, we do not get that. Now let's move forward with the next one, that is the like operator. So the like operator is one of the most popular questions asked in your interviews. Now this is since people often get confused between how to use the like operators, right? So for that, I'll just show you a few examples. So let's say, we want to find out all those students' name starts with, let's say, S. We'll just mention select star from, and then we'll use students info, right? Where I'll mention student name like, and then what I'll do is I'll mention S, right? And then I'll mention the percentage symbol. So when I execute, we see that, only one student with the name Shania, because her name starts with S, is in the result set. Well, that was about this query, guys. Now, for example, let's say, we want to find out the student name whose name starts with M and the name has 6 letters, right? So what I'll do is I'll just mention select star from student name like, and then I'll mention M, and then I'll mention 5 underscores and then mention a percentage symbol, right? And then I'll click on execute. When I click on execute, we again see only one query because Mansa's name starts with M and has around 6 letters, including M itself. So the 5 underscores were for the rest 5 letters and M was the starting letter. And percentage symbol represents anything can be there after that, right? So that was about this particular query. Now let's say we want to find out all those tuples whose student name starts with M and then ends with A, right? So I'll just change this particular query only. I'll just remove the underscore and then put a percentage symbol and mention A. What I mean by this particular statement is basically that, the student name should start with M, should end with A, and any number of letters can be present in between. Well, that was about this particular query, guys. Now let's say you want to use the scope resolution operator to access the get root member of the hierarchy ID type. Well, to do that, what I'll do is I'll just declare a variable. So let's just declare @example ID of hierarchy ID type. And then what I'll do is I'll select this particular ID, right? So I'll just mention select @example ID equal to hierarchy ID. And then I'll mention the scope resolution operator, and then I'll mention get root. After that, I'll just print @example ID, that is basically a variable, to string. So basically, I'm just converting it to string, right? And then what I'll do is I'll just execute this particular set of statements. And then once I execute the set of statements, you see this output, right? So that's how you can use the scope resolution operator also, guys. Well, that was about this particular operator. Now let's say you want to use the string concatenation operators. Well, to use the string concatenation operator, let me just consider the example of select. Let's say we take student name, right? So I'll just mention student name, right? And then I'll put a plus mark over here. That is, I'm using the string concatenation operator, right? And then what I'll do is I'll just use single quotes, right? I'll put comma, and then I'll put a plus sign again, and then choose parent name, right? And then I'll just use the aliases function. That is, I'm combining these 2 columns and putting it as another column. And let's say I just mention it to be name from students info, right? And then I execute. So as you can see the output, you can clearly see that, we've got a name column which has the concatenated values of the student name and the parent name. So if you want to give a space, then you have to mention spaces over here, right? And then you click on execute again, and then you can clearly see that, the space is visible. So that's how you can use the string concatenation operators, guys. Now let's say you want to move forward with the aggregate functions. Well, aggregate functions were used before also when we were doing the order by and the group by clauses. For your better understanding, let's say if you want to just calculate the average of all the marks, you'll just mention select, and then you'll choose average marks, right? So that's basically a column name. And then you'll mention the table name, that is offset marks. And then you click on execute. So once you click on execute, we get our average of all the marks present. So that's how you can use the aggregate functions also, guys. Now let's move forward with the set operators. Well, as I explained before, the set operators consist of union, intersect, and the except operations. So what I'll do is I'll just consider another table which is similar to that of our students table. So I'll just create one more table. So let me just scroll up, right? And I'll just copy this particular section. Come down, paste it over here, change it to, let's say, students details, right? And then I'll also insert few values, right? So let me just copy paste from over here so that it's faster. So I'll just execute this particular statement now. And now once our table has been created, I'll just execute these three statements again. And now there are two tables, students info and students details, and both of them have few values. Now let's just perform the union operation, the intersect operation, and the except operation. So I'll just mention select star from students info, and then I'll mention union, and let's say we mention select star from the table 2, that is students details, right? So I'll just search for students details, right? And let's just execute. Now once we execute, you can clearly see that all our table values have been inserted. So we had few values in our first table and a few values in our second table. So all the values got combined into our third table, right? Now, similarly, if we just do the intersect option, so I'll just mention intersect, and then we can see the common values in both the tables. So I'll just mention intersect and execute. And we can see that, the fourth and the fifth record are common in both the tables. When I type in students info except students details, all the tuples which are present in students info and not present in student details are given as output. And similarly, if I just do the reverse, right? So if I just change it to students details except students info. So let me just do that. And then I'll just do it to info over here. You'll see the opposite output, right? So that's how basically, guys, you can use the set operators. I hope that you've understood how to use the different kinds of operators to manipulate and retrieve and handle your databases. Now let's move forward with the next part of the session, that is nested queries. Now nested queries are also one of the most popular concepts that you need to know, because nested queries are SQL queries which have an outer query and an inner subquery. So the subquery is a query nested within another query, such as the select, insert, update, and the delete statements. So this was about the nested query, guys. So as you can see on my screen, we have an outer query and then we can have a subquery. So what will happen is that, the subquery or the inner query will be executed, and whatever output comes, that output will be the input to the outer query, and then we get the final output. That was about the nested queries, guys. So for your better understanding, if I have to give you an example, we can just write a query like, select student name, and let's say parent name from, we mentioned students info, right? And then I'll mention where address of student in, and then we can have an inner query which says select address of student from students backup that we had initially created, where let's say country is equal to India, right? And now we can just execute this particular query and then we get the output. So that's how you can type the nested queries, guys. Now let's move forward with the next part for today's session, that is joins. Now joins in SQL are commands which are used to combine rows from two or more tables based on a related column between those tables. So they're predominantly used when a user is trying to extract data from the tables which have one-to-many or many-to-many relationships between them. Now there are mainly 4 types of joins that you have to understand, guys. That is the inner join, the left join, the right join, and the full join. Now the inner join returns the records which have matching values in both the tables. The left join returns the records from the left table and also those records which satisfy the condition from the right table. The right join returns the records from the right table and also those records which satisfy the condition from the left table. And finally, coming to the full join returns the records which either have a match in the left or the right table. So for your better understanding, what I'll do is I'll just consider an example. So apart from the students info table, let's just consider the subjects table, right? So for that, I'll just create the subjects table. So let me just type in create table subjects. And let's say we have subject ID of in type, right? And let's say we have student ID of in type. Then we have subject name of, let's say, varchar type. And after that, let me just insert few values. So I'll just mention insert into subjects value 10 maths and 211 physics and 312 chemistry. So I'll just execute these statements. Now once the statements are executed, let's apply the join functions. So let's say we want to apply the inner join, right? So we'll just mention select subjects dot subject ID, and let's say students info dot, and we want the student name, right, from both these tables. We want from subjects table, that is our table A, and then we'll mention inner join, that is our join condition, and then we'll mention the second table name, that is students info, and we'll mention on, and after that we'll mention the condition, that is subjects dot student ID must match students info dot student ID, right? And then we'll just execute this particular statement. And once you execute the statement, we see that there are no common values present, so that is the reason we do not get any values. Well guys, that was about the inner join. Now let's say we want to apply for the left join, right? So what I'll do is I'll just select students info dot student name, and let's say we also select the subject ID from the subjects table, and let's say our first table is students info, right? So that is what we are considering over here. And over here I'll mention left join, and after that what I'll do is I'll mention the other table name, that is subjects, and then I'll mention on, and then what I'll do is I'll just match the students info dot student ID equal to subjects dot subject ID, and then let's say we order it by the student name, right? So I'll just mention students info, let's say student name. Right now I'll just execute this particular statement, and then we can see that we get all the values from the left table, that is the students info table, and then also those records which match the condition from the right table. Similarly, if I apply the right join over here, you'll see all the records from the right table and also those records which satisfy the condition from the left table. Now finally, let's apply the final type of joins, that is the full outer join. And then let me just execute, and once I execute, we see that we get all those records which have either a match in the left table or the right table. So guys, this was in short about the different types of joins in SQL. Now if you want to learn in depth more about the SQL joins, you can refer to my session on SQL joins. With that guys, we come to an end to the joins part of this particular session. Now let's move forward to the stored procedures. I'm sure that you might have an understanding of what stored procedures are. Stored procedures are those reusable units that can encapsulate a specific business logic of the application. So it is a group of SQL statements and logic compiled and stored together to perform a specific task. The syntax of stored procedures is as you can see on my screen, right? So you just have to mention create or replace a procedure, and then you mention the procedure name, and after that you'll mention the parameters name, and then you'll use the aliases is or as, and then you say begin. Right, and when you say begin, you declare the section, and then finally you end the procedure. So to demonstrate this, let me just create a procedure for you. So let's say we create procedure, let's say students city, right? And then we choose the parameter name to be scity, and let's say to be of varchar type 8000, right? And after that we choose as, and then we select from students info, and then we can mention where city equal to @ and then we mention it to @ as scity. Then we create go, and after that we mention select star from students info again. Now once it is created, what you can do is you can just execute the statement simultaneously also. So for that you'll just use in the command execute, right? So execute students city, right? And then you'll mention @ scity, because that is the type of the variable that you've created, and let's say it to be of Hyderabad, right? And then you'll click on execute. So once you click on execute, you can see that you select all the students from the students info, and you see that there's no student from Hyderabad. For example, if we mention Kolkata over here, right? So I'll just mention Kolkata, right? And then if I execute it again, you can see that we get an error that there's already an object named student city. So I'll just execute this particular section, and we see that we get only those tuples whose city has Kolkata value. So that's how guys you can use stored procedures. You just write the code once, and then you can keep using it again and again like any other programming languages. So guys, that was about the stored procedures, and with this we come to an end to the DML commands. Now let's move forward with the next section of commands, that is the DCL commands. So as I mentioned before, the DCL commands are used to grant or revoke privileges to a user. So for example, let's say you want to create a user. So to create a user, what you can do is you can just mention create login sample with, we mentioned the password to be Edureka. So this will basically create a user. So I'll just execute the statement. Okay, it says that the sample user already exists. So I'll just mention it to be sample1, right? And then I'll click on execute. And once I click on execute, you can see that my user who's with the name sample1 and password Edureka has been created. Now what you can do is you can just use this user to perform various actions rather than only using the admin login. So this is how you can create a login sample1 with the password Edureka. Now to create a user, what you'll mention is you'll mention create, and then you'll mention user Edureka, right? And for login, and then you'll mention sample1. So to create a user, what you initially have to do is you have to create a login for that particular user, and then you go forward and create a user, right? So I've created a login, and then I'll just create this user. So I'll execute this, and now this particular user can be used rather than just using the admin login credentials. Now what you can do is now you can grant and revoke any kind of privileges to a specific user. Now, for example, let's say you want to grant few privileges for this user Edureka, right? So for that, you'll type in grant select on, and then you'll mention the table name, let's say students info, right? And then what I'll do is I'll mention to, and then I'll mention the username, that is Edureka. So I'm just granting this privileges to this particular user. Now similarly, I can also revoke back the granted privileges. So I'll just go back and choose revoke. So I'll just mention revoke over here, and then I can just go back and execute, right? So once I execute, you can see that no privileges are there. Also, if you want to check, you can go to security, you can go to users over here on the left hand side, and then you can choose Edureka. And then once you choose Edureka, once you double click on that particular user, you can see all kinds of permissions granted to this particular user. So since none are granted, you can't see anything presently. But yes, if you grant some, then you can definitely see over here. So guys, that was about the TCL commands. Now let's move forward with the next section for today's session, that is the TCL commands, or the transaction control language commands. Well, these commands are used to handle the transactions in your database. To demonstrate this, what I'll do is I'll just create a table. So I'll just create a table and insert few values. So let me just copy paste the same. I've just created a table as TCL sample with the student ID, student name, and marks columns, and then these are the values which will be inserted, right? So I'll just click on execute. Now once these values are inserted, now let's just start our transaction, right? So to start a transaction, what I'll do is I'll just mention begin try. So that's a try catch block which I'll come to later in the session, so don't worry. After that, I'll mention begin transaction, right? And then I'll mention insert into TCL sample, that's our table name, and then I'll mention values. And let's say we mention few values, let's say 5, and then I mention the name, and let's say we've mentioned other values, right? So I'll just mention 56. This need not be in quotes, so I'll just remove that, right? And after that, what I'll do is I'll just mention update TCL sample, that's our table name, and then I'll mention set student name equal to, let's say we mentioned the student name to be Akash, where our student ID is 5. Also, we want to update our TCL sample table again and set our marks equal to 67, where our student ID is 5, right? After that, we want to commit this transaction and then print that transaction completed, right? So I'll just want to print on the screen, and then I'll end my try block, right? And begin my catch block now. And over here, I'll mention rollback transaction. And over here, I'll mention again print transaction unsuccessful and rolled back. After that, I'll end my catch block. So if you observe over here, what I've done is I've just started my try catch block, and then I've begun my transaction. After that, I've inserted a value into the table. Now after that, I want the value to be updated, right? So I want to set the student name to be Akash with the student ID is 5, and this marks to be 67 with the student ID is 5. After that, I want to commit the transaction and print transaction completed. And then only if there is no error, the try block will end. But if there is any error found or any exception found, then the catch block will be executed, where it will print transaction unsuccessful and roll back. So what I'll do is I'll just execute the statement. Okay, I'm sorry, I missed a comma over here, right? And now let me just re-execute the statement again. And once I execute this statement, you see an output that, transaction completed. That means that, we have inserted this value into the table, and then we have also updated the values, right? So I'll just show you that. So let me just type in select star from TCL sample, right? So when I execute, you can see that, we have our 5th student with the name Akash and the marks to be 67. Now let's say, you set the marks to 67 by 0. And then let's just execute the section again. Now, once I execute the section again, you clearly see an output that, transaction unsuccessful and rolled back. That is because, we cannot set our marks as 67 by 0, as we have given that, marks column is an int column, and then an int column cannot have this particular kind of values. So that's how, guys, the transaction control language commands works, right? With this, we come to an end to the different SQL command categories that you need to understand about. Now let's move forward with the final topic for today's session, that is exception handling. Well, exception handling in SQL Server is almost similar to that of the other programming languages. It's the same as you handle exceptions in all the other programming languages. You have a throw block, and then you also have a try-catch block. So talking about the throw block first, or I would say the throw clause. This clause is used to raise an exception and transfers the execution to a catch block of the try and catch construct. If you want to see the syntax is as you can see on my screen. You mention throw, and then you mention the error number, and then you can mention local variable, message, and so on. Coming to the try-catch block, the try-catch block is used to implement exception handling in Transact SQL. So a group of statements can be enclosed in a try block. So in case an error occurs in the try block, the control is then passed to another group of statements that are enclosed in the catch block, as we just saw in the transaction control language commands. So the syntax is as you can see on my screen. It starts with begin try, then we mention few SQL statements, then we mention end try, then we mention begin catch, and then we again mention few SQL statements, and then we mention end catch. So that's how you can do exception handling, guys. So for your understanding, let me just give you a quick example. So let's say if you want to use the throw clause, you'll mention throw, and then I said you'll mention the error number, right? So let's say I'll mention 5100, and let's say I mention it as record does not exist, right? And then what we can just do is we'll put a comma and then put on 1. And then when I execute this particular statement, you can clearly see that, message 51,000. And then you can see that, state line is 1, and the message is record does not exist, right? So that's how you can use the throw clause. Now, similarly, you can use the try and catch block as you saw before. So for that, you'll just type in begin try, right? And let's say we select phone number plus student name, right? So if you remember, our student name was of varchar type and our phone number was of begin type, right? So we cannot concatenate both of them. So I'll just mention phone number concatenate student name from students info, and then what I want to do is I want to do end try, then I'll begin the catch block, right? And then I'll mention print not possible, right? And let's say I'll just mention end catch, right? And then we can just execute the statement. So when I execute this particular statement, you see that, no column name. But if I go to messages, you can clearly see that, the message shows not possible, right? So that means our try block did not get executed. Only our catch block got executed and shows the exception of not possible. That indicates the user that, we cannot add these two columns. So that's how you can perform exception handling in Microsoft SQL Server, guys.
Imagine having a massive database filled with valuable insights, but you struggle to extract the right information efficiently. This is where the SQL structured query language becomes a game changer in Power BI. SQL acts as a data gatekeeper, helping you filter, transform, and optimize datasets before they reach your Power BI reports. So whether you're pulling real-time sales figures or analyzing custom trends, SQL ensures your data is clean, fast, and ready for visualization. Now, let us understand what is SQL in Power BI. Well, structured query language in Power BI extracts, transforms, and manages data before visualizing it in reports and dashboards. Power BI connects to SQL databases, allowing users to fetch relevant data, optimize queries, and enhance performance. But why SQL is crucial for Power BI? SQL plays a vital role in Power BI by enabling efficient data extraction, transformation, and optimization before visualization. Since Power BI is a data-driven tool, having clean and well-structured data significantly improves performance and reporting accuracy. SQL helps query large datasets, perform complex joins and aggregations, and optimize data loads before bringing them into Power BI. Now let us see some of the key reasons. So first here we have efficient data extraction. SQL allows you to fetch only the necessary columns and rows, reducing the data loads on Power BI. Also, using join and group by in SQL minimizes data processing inside Power BI. The next key reason is performance optimization. Here, the large data sets slow down Power BI if not optimized. So SQL pre-aggregates data, reducing the need for complex DAX calculations. Indexes and views in SQL help speed up query performance in Power BI. The next key reason is handling complex data models. So SQL simplifies many-to-many relationships and data normalization before loading into Power BI. Using CTEs, subqueries, and window functions, SQL ensures clean data for efficient Power BI modeling. The next key reason is direct query versus import mode benefits. So with direct query, SQL ensures that Power BI always fetches real-time data from the databases. In import mode, SQL pre-processes large tables, reducing Power BI's memory consumption. Alright, I hope now it's clear what is SQL in Power BI and also why it is crucial in Power BI and its key reasons. So now we will see how to import data into Power BI with the use of SQL. So first, let me connect to MySQL and then create a new database. So here I'll select new database and create a database called Power BI DB and then click OK. And if you expand the Power BI DB and right click on it, you will get the following options. So go to new query. We will be using a new query to create the table. So before creating the table, let me show you the dataset first. So this is my CSV file. The columns in this dataset are ID, product, region, sales and profit. So that we will create a table for this dataset now. Now here coming back to SQL, let's type create table sales data. And then I will type the column names and their data types such as ID and its data type int. And then the same way for the product and its data type as varchar 255. Then the next column region varchar followed by sales and its data type as decimal. And finally the profit and its data type again decimal. And now let's close the bracket. Now let us select all and click execute. And you will see that the comments were successfully executed. Now we will insert the values in the columns. So we will type insert into sales data value because we have named our tables as sales data and open the bracket. And then type each column value in and close the brackets. And then let us type select star from sales data and now select the first line and execute it. Followed by let's execute the second line. And you can see that our columns and values have been executed. Let us follow the same step, select and execute it. And to import data into Power BI desktop, click on Get Data and select SQL Server. And in the Database tab, you can add this server name by right-clicking on the server and selecting Properties. Now copy the server name and paste it into Power BI and then click OK. And then click on Connect and then click OK. So the data is now displayed and you can also select and load it into Power BI. So as you can see, this is the data that we have loaded using SQL. And now to view this data set, click on Table View and this is how it is presented. Here it is. So now let us create a chart and present these values. So for that, go to Report View and let's do a small example. So I'm going to select this chart and in this I'm going to drag and drop the columns. Okay. So in the y-axis I'm going to drag and drop the product column and in the x-axis I'll be selecting profit. So that's it. It's simple, right? And I hope it's pretty much clear now. So this is how the Power BI and SQL integration simplifies the data analysis by enabling seamless connectivity and transformation. So here the users can choose between direct query for real-time access or import mode for performance optimization. Also, the strong SQL skills enhance data modeling and querying capabilities. And together, these tools empower businesses with insightful, data-driven decision making.
Let's know first what exactly SQLAlchemy is. It is a popular Python library that provides an object relational mapper and a database abstraction layer. It allows Python developers to interact with databases in a way that is both efficient and expressive. This powerful tool supports a wide array of databases, abstracts complex database tasks, and provides a high-level efficient way to handle data manipulation and retrieval. You must be thinking, why do we need this at all? So, let me clarify it for you. We use it because, first, ease of use. SQLAlchemy allows developers to interact with databases using Python code rather than writing SQL queries. This simplifies database operations and makes the code easier to understand and maintain. Second one is data abstraction. SQLAlchemy provides a high-level abstraction for the databases, making it possible to switch between different types of databases like MySQL, SQLite, etc. with minimal changes to the code. Third one is support for ORM. The SQLAlchemy ORM enables developers to work with databases using Python objects, effectively turning tables into classes and rows into objects. This object relational mapping simplifies complex database operations and makes the code more Pythonic. Fourth, and the last one is efficient and secure. SQLAlchemy provides efficient and secure handling of database operations. It automatically handles connections, pooling, and transactions, ensuring data integrity and efficient use of resources. Just now I mentioned ORM, so what is it? Basically, an ORM, Object Relational Mapper, is an ingenious programming technique that seamlessly bridges the gap between object-oriented programming languages and relational databases. Acting as a virtual translator, it transforms database rows into objects and vice versa, enabling developers to interact with their databases using familiar, language-specific constructs. By abstracting database queries into objects, the ORM mapper simplifies complex database operations, promoting maintainable and efficient code while preserving the full power and flexibility of underlying SQL operations. Now, let's talk about the data abstraction layer. The data abstraction layer in SQLAlchemy is a system that facilitates interaction with various types of databases using a uniform API. It works by abstracting the underlying SQL expressions, thereby allowing developers to write database queries using Pythonic syntax. This high-level abstraction simplifies database operations and promotes code portability across different database systems. Now we will talk about the connection between ORM and DAL. ORM is the backbone of SQLAlchemy. It leverages the Python data model to provide a high-level Pythonic interface to relational databases. This means that tables in a database are treated as Python classes and rows are instances of those classes. The SQLAlchemy ORM provides a mapper which is a bridge between Python classes and database tables. The mapper translates Python objects into rows in a table and vice versa. This allows developers to manipulate database records as if they were Python objects. They can then write queries in Python instead of SQL. In essence, the ORM and the DAL in SQLAlchemy are interconnected. The object relational mapper uses the data abstraction layer to abstract database interactions behind Python classes objects, allowing developers to write database operations in Python, while the abstraction layer makes these operations work across different types of databases. The seamless integration of ORM and DAL in SQLAlchemy simplifies database interactions, making them more Pythonic and database agnostic. Thanks to its Pythonic interface, an ORM tool, it allows developers to use Python syntax to interact with databases. It supports a wide variety of databases and has a consistent API, which means that developers can switch between different databases with minimal code changes. This is why SQLAlchemy is so popular in Python ecosystem and is considered the go-to library for database interaction. In conclusion, SQLAlchemy and its ORM mapper provide a high-level Pythonic interface to SQL databases, allowing Python developers to handle complex database operations with simple Python code. It abstracts the complexities of SQL, making it easier to create, read, update, and delete records in a database, which we often call it as a CRUD operation. It's an excellent tool that makes database operations in Python easier and more efficient. SQLAlchemy is one of the most popular library. To start implementing it, we need to first install PyCharm. For that, first open your web browser and go to the PyCharm website. On the PyCharm website, you will find different editions available, like Community, Professional, and Educational. Choose the edition that suits your needs and click on the download button for the edition. I will prefer the Community one, so here I will click. As you can see, download has started, and after once the download is completed, we can locate the installer file in our system and run it. After the installation is complete, you can launch PyCharm from the Start menu on Windows or the Application folder, and PyCharm may ask you to set up a Python interpreter. You can either use an existing Python installation on your system or let PyCharm download and set up a new Python interpreter for you. So I have already pasted the code here, which I was working on the previous project, so it will be much easier for you to understand all at once, and it will not take much of your time also. So as you can see in the first line, I have put as from SQLAlchemy, import create engine, column, integer, and string. So what is create engine here? It is one of the modules in the SQLAlchemy project, basically. So it is one of the modules that helps to create connections between the databases. And the second line tells you from SQLAlchemy.orm, as we all know, it is a ORM mapper, and import session maker. So what is a session maker here? Session maker is a configurable session factory which we will use to connect the database between different type of sessions. So for that we are using session maker here. And the third line is as SQLAlchemy.extension declarative. And again we will import declarative base, which is a system provided by the SQLAlchemy in order to define classes mapped to relational database tables. So we have to map the relational tables with the classes. For that we need declarative base here. Then we have to create a SQLite in memory database, like a database engine basically. For that we are using engine equals to create engine, create underscore engine, SQLite and memory. Then afterwards we have to create a session factory, as I already mentioned in the session maker. So for that we will write as session is equals to session maker, like a bracket by an engine. After that we will declare the base class for the declarative model as a declarative base. Then we will define the model class by representing a table in the database. You can see we have put three items here, the ID, name, as well as age. So we all know ID will be as an integer value, and here primary key we have set as true. Why it is? Because it will automatically create an ID for the item. So it is a function that creates automatically. And then we will put as name, which will be obviously in string. And then moving forward we will put as age, which is obviously will be integer. Now we have to define the representative self, and then we will return it obviously. So we will keep the return value as user, and here as we can see I have written as name is equals to self.name and age is equals to self.age. Basically these two functions will produce with the name as well as age when you will ask for the print results. Now we will create the tables in the database as base.metadata.create underscore all engine. So what all engine means? Basically it is a container object that keeps together many different features of a single database. So a database has many features, so it will all accumulate here as metadata.create underscore all. So for that I have used it here. And then again we have to mention the session we will be using, so that it will be much easier for the session maker to accumulate all the data at once and give us the output. And here I have taken as three users, user 1, user 2, user 3. And I have given three names also as well as their ages, so that it will print us the output. First name as Aditya and his age is 25. Then second is Ashish and his age is 30. And the third one is Tanya and her age is 35. And as you can see in the last line, I have created, like as already I have created some user objects. So I will now add users to the session. So how I'm gonna do it? I will do at session.add underscore all user 1, user 2, user 3, and you can make it however you want. Like if you are taking as 5 users, so you can mention 5 users here. So it's up to you how many users you are like needing it. And for me, I need 3 users, so I am putting 3 users here. Then we have to commit the session so that the code will be completed. Now we have to query the database for all users, like what exactly we want from the Python database to print as. So for that we are using as users equals to session.query user.all, and then we will print the users to get the output. So let's see if the program is correct or not and if it is running or not. Yeah, so it's running. As you can see, it is printing the three users. First user is Aditya, age 25. Second one is Ashish, 30. Third one is Tanya, 35. So this is how you are using Python database with the help of SQLAlchemy, and it will help you out to print out the results whatever you want.
the first question that we have is, what is the difference between delete and truncate statements? So I'll start by explaining you what is the delete command. Well, the delete command is basically used to delete a row in the table. So you can also roll back data after using the delete statement, and it is a data manipulation command. Coming to the truncate statement, the truncate statement is basically used to delete all the rows from a table, and you cannot roll back the data. This is a data definition language command, and it is faster than the delete command. So if anyone asks you the difference between the delete and the truncate statements, don't forget to mention that the truncate statement is definitely faster than the delete statement, and the truncate statement is from the data definition family and the delete statement is from the data manipulation family, right? Now moving on to our next question, that is, what are the different subsets of SQL? Well, the different subsets of SQL are mainly the data definition language, the data manipulation language, the data control language, and the transaction control language. Now coming to the data definition language, this set of language consists of the commands that can be used to define the database schema. So whenever you want to define the database schema, you can use the commands from this particular language. Coming to the data manipulation language, the manipulation language consists of all the commands that deal with the manipulation of data present in the database. So for example, if you have n number of tables and you want to manipulate the data present in those tables, then you use data manipulation commands. Coming to the data control language, the data control language includes the commands which deal with the write permissions and other controls of the database systems. So for example, you work for an enterprise and the enterprise has a database. Now obviously all the employees will not have the access to the database, right? So data control language mainly deals with how you give the user permissions to access to the database. Now coming to the last type of language, that is the transaction control language. This basically includes the commands which mainly deal with the transaction of the database. Whenever you want to roll back or you want to perform any various kind of transactions, then you use the set of commands from this language, right? So I hope I'm clear. So as I said, there are mainly 4 different subsets of SQL that you should mention. That is the data definition language, the data manipulation language, the data control language, and the transaction control language. Now moving on to our next question, that is, what do you mean by database management systems and what are the different types of it? So now if I have to define the database management system for you, then a database management system is a software application that interacts with the user's applications and the database itself to capture and analyze the data. So the data stored in a database can be modified, retrieved, and deleted and can be of any type like the strings, numbers, images, etc. So you can basically store any kind of data. Now the different kinds of database management systems are the hierarchical, the relational, the network, and the object-oriented database management systems. Now talking about the hierarchical database management systems, this type of database management system has a style of predecessor and the successor type of relationship. So it has a structure similar to that of a tree, wherein the nodes represent the records and the branches of the tree represent the fields. Coming to the relational database management system, this type of database management system uses a structure that allows the user to identify and access data in relation to another piece of data in the database. The network database management system supports many-to-many relations wherein multiple member records can be linked, and the object-oriented database management systems use a small individual software called objects, and each object contains a piece of data and the instructions for the actions to be done with the data. So I hope I'm clear with this point. So now moving on to our next question, that is, what do you mean by a table and a field in SQL? So now the answer to this question is quite simple. A table basically refers to a collection of data in an organized manner in forms of rows and columns, and a field refers to the number of columns in the table. If you have to explain anybody what a table and field mean, so basically in SQL you have a database, and a database consists of n number of tables, right? So that is basically a table, and the tables have few column names, right? So the column names are basically the fields. So you can explain with an example, as you can see on the screen. So over here I have an employee information table, into which the employee information table is a table, and the column names in this particular table are the fields. Now moving on to our next question, that is, what are joins in SQL? Now this is one of the most popular questions that is generally asked in your interviews. So basically a join clause is used to combine rows from 2 or more tables based on related columns between them. It is used to merge 2 tables or retrieve data from there. And there are mainly 4 types of joins in SQL. That is the inner join, the full join, the left join, and the right join, right? Now moving on to our next question, that is, what is the difference between char and varchar2 data type in SQL? Now this is one of the most confusing questions that is generally asked in your interviews, since generally people get confused between what is char and what is varchar data type. Now both char and varchar2 are used for character data type, but varchar2 is used for character strings of variable length, whereas the char is used for strings of fixed length. So whenever you have strings of fixed length, then you use the char data types, and whenever you have strings of variable length, then you can use the varchar2 data type. Now for example, char10 can only store 10 characters and will not be able to store a string of any other length, whereas the varchar210 can store any length that is either 6, 2, 8, it completely depends on the variable, right? Now moving on to our next question, that is what is the primary key? Now when you're working in a database field, obviously a company can have n number of databases having n number of tables inside it. Now each and every table in a database has to be connected with the other table, right? Now for that we need to uniquely identify a table, or you can say you need to uniquely identify a column. So basically primary key is a set of attributes that can be used to uniquely identify every tuple. So if there are around 3 to 4 candidate keys present in a relationship, then out of those, one can be chosen as the primary key. Now, as you can see on the screen, we have an employee information table which has columns like, employee number, employee name, employee country, and the employee age. Now, obviously, you can uniquely identify each and every employee with the employee ID, right? So basically, that will be our primary key. So over here, employee number will be a primary key. Now, let's move on to our next question, that is, what are constraints? So constraints are basically used to specify the limit of the data type of the table, right? So whenever you're creating a table, then you can use the constraints to set a limit of the data type of the table. It can be either specified while either creating the table or, while you're altering the table statements. So it can be basically specified in both the ways. Now, there are mainly 5 constraints that you need to understand about. That is the not null constraint, the unique constraint, the check constraint, the default constraint, and the index constraint. Now, the not null constant basically ensures that a null value cannot be stored in a column. So whenever you mention this particular constant into a column of your table, then this particular constraint will make sure that no null value can be stored for that particular column in the table. Moving on to the next constraint, that is the unique constraint. This constraint makes sure that all the values in the column are basically different. So if you need to make sure that in a column you have unique values for each and every row, then you can use this particular constraint. Now moving on to the next constraint, that is the check constraint. The check constraint basically ensures that all the values in a column satisfy a specific condition. So if you have a condition and you need to make sure that only the values which satisfy the condition are stored in the column, then you can use this particular constraint. Now talking about the default constraint consists of a set of default values for a column when no value is specified. So for example, in a table of 10 rows, you have a column in which you do not specify all the values for all the 10 rows. Then you can make sure that you set a default value, and the default value will be automatically stored whenever you don't mention a value in that column. Now moving on to the last type of constraint, that is the index constraint. The index constraint is used to create and retrieve data from the databases very quickly. So I hope I'm clear with the different types of constraints that you need to answer about when you're asked this question about what are the constraints that you know. Now let's move on to the next question, that is, what is the difference between SQL and MySQL? Now, this is one of the most popular questions that is generally asked, because since people generally get confused between what is SQL and what is MySQL. So let me just explain you the simple difference between both of them. So SQL is basically a standard language which stands for Structured Query Language based on the English language, whereas the MySQL is a database management system. So SQL is basically the core of relational database which is used for accessing and managing the database, whereas MySQL is a relational database management system which works on many platforms. So basically this provides multi-user access to support many storage engines and is backed by Oracle. So that's the basic difference between SQL and MySQL, guys. SQL is basically the core of relational database which is used for accessing and managing a database, and MySQL is an open source relational database management system. Now let's move forward to our next question, that is, what is a unique key? Now unique key basically identifies a single row in a table. This basically allows multiple values per table, and also the null values are allowed. So you'll have to make sure that whenever you're using the unique key, you need to have an idea that it identifies a single row in the table. Multiple values are allowed per the table, and also null values are allowed, but yes, duplicate values are not allowed. Alright, now moving forward to our next question, that is, what is a foreign key? A foreign key basically maintains referential integrity by enforcing a link between the data in two tables. The foreign key in the child table references the primary key in the parent table, and the foreign key constraint prevents actions that would destroy the links between the child and the parent table. So if you have a database and if you have around 10 tables in that particular database, and then if you want to maintain relations between all these tables in the database, then you need to use the primary key foreign key concept so that you identify the relation between both these tables with the help of foreign key. Now moving forward to our next question, that is, what do you mean by data integrity? Now data integrity basically defines the accuracy of the data as well as the consistency of data stored in the database. It also defines the integrity constraints to enforce business rules on the data when it is entered into an application or a database. So if you have to answer this question, then you can answer by saying that data integrity basically defines the accuracy and the consistency of data. Now let's move forward to our next question, that is, what is the difference between the clustered and the non-clustered index in SQL? The clustered index is basically used for the easy retrieval of the data from the database and is faster than the non-clustered index. The clustered index alters the way records are stored in the database as it sorts out the rows by column, which is said to be the clustered index, and only one table can have a clustered index. Coming to the non-clustered index, the non-clustered index is also used for the retrieval of data from the database, but yes, it is slower than the clustered index. The non-clustered index does not alter the way it is stored, but yet it creates a separate object within a table which points back to the original table rows after searching. And also one table can have many non-clustered indexes. The main difference between both of them are both are used for easy retrieval of data, but yes, the clustered index is faster than the non-clustered index, and only one table can have only one clustered index, but yes, a single table can have many non-clustered indexes. Apart from that, the third difference between both of them is also that the clustered index alters the way records are stored in the table, and the non-clustered index does not do that. Now let's move forward to our next question, that is, write a SQL query to display the current date. Now when you attend the interviews for a database administrator, let me just tell you that not only the theoretical questions are asked, but yes, you're sometimes asked to write the queries also. So they can give you some scenario based questions, or they can just ask you few simple queries that you need to make sure that you know them. So that's the reason that this question could be asked, that write a SQL query to display the current date. Now in SQL, to display the current date, we have a function known as the getDate. So basically with the help of this function, you can return the current date and timestamp. So the syntax of the function is really simple. It's just getDate, and it applies to SQL Server 2017, 16, 14, 12, 2008, R2, 2008, and 2005. Now if you just have to give an example to the interviewer about how to write a query to display the current date, you can just mention the query like, select getDate. So when you execute this particular query, you would see an output that, the current date and time would be displayed as out, right? So that's how you can write a query to display the current date. Now moving forward to the next question, that is, what are the different types of joins? So as I mentioned before, there are mainly 4 types of joins that you need to talk about. That is the inner join, the full join, the left join, and the right join. So talking about the inner join, this join basically returns those records which have matching values in both the tables. Now consider 2 tables, table A and table B. Now when you apply the inner join on both of these tables, you'll observe that the output would be all those records which have matching values in both the tables, that is table A and table B. Now talking about the full join basically returns all those records which either have a matching value in the left or the right table. So whenever you apply full join on both of these tables, you'll see that you'll get an output of all those records which either have a match in the left or the right table. Now talking about the left join returns the records from the left table and also those records which satisfy the condition from the right table. So if you have table A and table B and you apply a left join to both of these tables, then the output would be all those records from the left table and the records from the right table which satisfy the specified condition. Similarly, the right join is just the vice versa. The right join basically returns the records from the right table and also those records which satisfy the condition from the left table. So whenever you apply the right join to table A and table B and consider that the table B is right table, you'll get all those records from the table B and also matching records from table A which satisfy the condition. So these are the various types of joins that you need to talk about, guys. Now moving forward to the next question, that is, what do you mean by denormalization? Now denormalization basically refers to a technique which is used to access the data from higher to lower forms of database. It increases the performance of the entire infrastructure as it introduces redundancy into the table, and it also adds the redundant data into a table by incorporating database queries that combine data from various tables in a single table. So if you have to just explain denormalization, you can just say that it is a technique which is used to access data from higher to lower forms of database, and it basically adds redundant data into the table by incorporating database queries that combine data from various tables. So I hope I'm clear with this point. Now moving forward to the next question, that is, what are the entities and relationships? So let me just explain you what entities are first. So entities can be anything like a person, place, or a thing in real world about which data can be stored in a database. So tables store data that represent one type of entity. So for example, a blank database has a customer tables to store the customer information. Now the customer table stores this information as a set of attributes, that is basically the columns within the table for each and every customer. So if you consider, a customer table has around 5 parameters like customer ID, customer name, customer phone number, customer email ID, and so on. Then all these customer ID, customer name, customer phone number are basically the column names, that is the attributes for the entities, and customer information will be the entity. Now talking about relationships, relational links between the entities that have something to do with each other is basically relationships. So for example, the customer name is related to the customer account number and the contact information, right? Now this might be in the same table or it could be in any other table also, right? So if you have two tables out of which one table has the customer name and the other table has all the other information like the customer ID, customer name, and so on. Now these two tables will be related to each other with a relationship so that the customer details could be retrieved. Now that particular information is basically relationships. Now moving forward to our next question, that is, what is an index? In the previous questions, I talked about the non-clustered index and the clustered indexes, right? But what exactly is an index? Now, index basically refers to a performance tuning method of allowing faster retrieval of records from the table. So as I mentioned before in the clustered and the non-clustered indexes question, both of the indexes are basically used for easy retrieval of data, right? So that's what an index does. This is basically a performance tuning method to allow faster retrieval of data from the table. And also an index creates an entry for each value. So to allow the faster retrieval of records from the table, it basically creates an entry for each and every value. Now let's move forward to the different types of indexes. So I've already explained you about two types of indexes, that is the clustered and the non-clustered index. But yes, let's understand again about both of them and also an additional index, that is the unique index. So mainly there are three types of indexes that is used, that is the unique index, the clustered index, and the non-clustered index. The unique index basically does not allow the field to have duplicate values if the column is unique indexed. So if a primary key is defined, a unique index can be applied automatically. So unique index is mainly used when you do not want any duplicate values to be present in the column. Now moving to the clustered index, the clustered index basically reorders the physical order of the table and searches based on the basis of key values. So each table can have only one clustered index. Coming to the third type of index, that is the non-clustered index. The non-clustered index does not alter the physical order of the table and maintains a logical order of the data. So each table can have many non-clustered indexes, right? So basically, guys, there are three types of indexes that you need to explain about. That is the unique, the clustered, and the non-clustered index. Now moving forward to our next question, that is, what is normalization and what are its advantages? So normalization is basically the process of organizing data to avoid duplication and redundancy. So it's basically the opposite of denormalization that we just talked about in one of the previous questions. So if you just have to define normalization, then you can say that it is a process of organizing data to avoid duplication and redundancy. Now the advantages of normalization are, as you can see on the screen. It offers better database organization, more tables with smaller rows, efficient data access, greater flexibility for queries, quickly finds the information, easier to implement security, allows easy modification, reduction of redundant data and duplicate data, more compact database, and ensures consistent data after modification. So guys, these are few advantages of normalization. Now let's move forward to our next question, that is, what is the difference between the drop and the truncate commands? The drop command basically removes the table and it cannot be rolled back from the database. Whenever you use the drop command, just remember that you completely drop the complete table and it cannot be rolled back from the database. And the truncate command removes all the rows from the table and also cannot be rolled back into the database. So the drop command and the truncate command differ by this. So whenever you use the drop command, you drop the complete table. And whenever you will use the truncate command, you will remove all the rows from the table. The syntax of both the commands are almost same. The syntax of drop command is basically drop, object, and object name. That is basically the table and table name. And the syntax for truncate command is truncate, table, and table name. So guys, that was about the drop and the truncate command. Now let's move forward to the next question, that is, what are the different types of normalization? So there are mainly 4 types of normalizations, that is 1NF, 2NF, 3NF and BCNF. Now let me explain you the different types of normalization with an example. So guys, this is the table that we're going to consider for the example. Now you basically have to apply normalization to this particular table. Now to apply normalization to this particular table, you'll clearly observe that there is Alice Johnson who has a particular address and has rented few movies from a specific category, and the category action is mentioned twice over here. Similarly, David Allen's address has been divided into 2 different records, and the movies rented and the categories have also been divided into 2 different records, right? Now to apply normalization to this particular table, you first have to apply the 1NF, that is the first normalized form. So for a table to be in 1NF, you need to make sure that each table cell should have a single value. So basically all the records must be unique. So as you saw in this particular table, we had redundant values in the same record, right? So we're going to have each cell with a unique record. So we'll have records such as, Miss Alice Johnson, First Street, house number 3, Mission Impossible, and the second record as Miss Alice Johnson, First Street, house number 3, Clash of Titans. Similarly, we'll have Mr. David Allen, 3rd Street, 45 with Interstellar, Mr. David Allen, 3rd Street, 45 with Edge of Tomorrow, and similarly, Mr. David Allen, 7th NU, Mission Impossible Fallout. So that's how basically you get your table into 1NF. You have records with unique value in the complete table. Now, as you can see on the screen, this is our table for 1NF. Now, you have to divide this table to 2NF. So when I say 2NF, that is the second normalized form, you can divide this table into 2 different tables. So to have a table in 2NF, you need to make sure that the database should be in 1NF and should also have a single column primary key. Since our table is in 1NF that we considered, that's applicable to our situation. Now let's move forward to the 2NF. Now in the 2NF, you'll clearly see that we have salutation, full name, address and movies rented, right? Now to divide this table into 2 different tables, you can clearly see that I've added an ID to both the tables. So I've added ID, salutation, full name and address, and ID, movies rented. So Miss Alice Johnson, staying in First Street, house number 3, must have rented Mission Impossible. Similarly, she must have rented Clash of Titans. Mr. David Allen, staying in 3rd Street, 45, has rented Interstellar and Edge of Tomorrow. And Mr. David Allen, staying in 7th Avenue, has rented Mission Impossible Fallout. So that's how I've divided the table into 2NF. Now moving forward to 3NF. Now, a database to be in 3NF, you need to make sure that your database is first in 2NF and must not have any transitive functional dependencies. So for that, what you're going to do is you're going to further divide the 2 tables into 3 tables, as you can see in the screen. So we're going to have an ID, full name, address, and salutation ID, and also another table with ID, movies rented, column attributes, and the 3rd table with salutation ID and salutation. So basically, we're going to identify Mr. with 1, Miss with 2, Mrs. with 3, and Doctor with 4. So that's how we're going to get our tables to 3NF. Well, guys, with this, we come to an end of this particular example that, our table has been completely normalized and the highest normal form available for this particular table is 3NF. Now, moving forward to the final type of normalization, that is BCNF. Now, if your database is in 3rd normal form and there would be some scenarios where anomalies would be present, and if you have more than one candidate key, then BCNF comes into role when you further divide your table so that there would be only one candidate key present. So guys, these are the various types of normalization, that is 1NF, 2NF, 3NF and BCNF. So in 1NF, there is no repeating groups within the rows. In 2NF, every non-key column is dependent on a whole primary key. In 3NF, it is completely dependent on the primary key and no other non-key column values. And in BCNF, you have to make sure that there's only one candidate key present in the table. So guys, these were the different types of normalizations that you need to understand about. Now let's move forward to our next question, that is, what is asset property in database? The asset property mainly stands for atomicity, consistency, isolation, and durability. It is basically used to ensure that the data transactions are processed reliably in a database system. So if you have to define asset property in a database, then you have to define all these terms individually. A stands for atomicity. So atomicity refers to the transactions that are completely done or failed, where transaction refers to a single logic operation of a data. It means if one part of any transaction fails, then the entire transaction fails and the database state is left unchanged. Coming to consistency, consistency ensures that the data must meet all the validation rules. In simple words, you can say that your transaction never leaves the database without completing its state. Third part, that is isolation. The main goal of isolation is the concurrency control. And the last part, that is durability. Durability means that if a transaction has been committed, it will occur whatever may come in between, such as power loss, crash, or any sort of error. Now let's move forward to our next question, that is, what do you mean by a trigger in SQL? So triggers in SQL are a special type of stored procedures that are defined to execute automatically in place or after data modifications. It allows you to execute a batch of code when an insert, update, or any other query is executed against a specific table. So guys, there are mainly 6 types of triggers that you need to understand about. That is the before insert, before update, before delete, and after delete. So basically the 2 main key terms that you need to understand are the before and the after. So these are completely applied on the insert, update, and the delete commands. The before insert is basically activated before the data is inserted into the table. The after insert is activated after the data is inserted into the table. The before update is activated before the data in the table is updated, and the after update is activated after the data in table is updated. The before delete is activated before data is removed from the table, and after delete is activated after the data is removed from the table. So guys, this is what a trigger in SQL is. It is basically a type of stored procedures that is defined to execute automatically in place or after data modifications. Now let's move forward to our next question, that is, what are the different types of operators available in SQL? So there are mainly 5 types of operators available in SQL. That is the arithmetic, bitwise, comparison, compound, and the logical operators. So guys, these are the main 5 types of operators available in SQL. So now let's move forward to our next question, that is, are null values same as that of 0 or a blank space? A null value is not at all same as that of a 0 or a blank space. A null value mainly represents a value which is unavailable, unknown, assigned, or not applicable, whereas a 0 is a number and a blank space is a character. So if anybody asks you if null values are same as that of 0 or blank space, please say it's no. Because the null values is basically anything which is unavailable, unknown, and is assigned or not applicable, whereas a 0 is a number and a blank space is a character. Now let's move forward to our next question, that is, what is the difference between a cross join and a natural join? The cross join produces the cross product or Cartesian product of 2 tables, whereas the natural join is based on all the columns having the same name and data types in both the tables. The main difference between both of them is that the cross join basically produces the cross product of both the tables, and the natural join is completely based on all the columns having the same name, data types in both the tables. Now let's move forward to our next question, that is, what is a subquery in SQL? A subquery is basically a query inside another query, where a query is defined to retrieve data or information back from the database. So subqueries are always executed first, and the result of the subquery is passed on to the main query. So as you can see on my screen, I have an outer query inside which I have a subquery or an inner query. So basically this query is assigned to retrieve data from the database, and then this query will be executed first. So if there are any errors in this query, then the complete query would not be executed. Only when the subquery is completely executed, then the outer query will be executed. Now let's move forward to our next question, that is, what are the different types of subquery? Now there are mainly 2 types of subqueries, that is the correlated and the non-correlated subquery. The correlated subqueries are basically those queries which select the data from a table referenced in the outer query. It is not considered as an independent query, as it refers to another table and refers to column in a table. The non-correlated subquery is an independent query where the output of the subquery is substituted in the main query. So you'll have to understand the difference between both of them. If you do not understand by definition, you can definitely go and execute the commands, write the 2 different types of queries in your SQL, and you'll get to know what I'm talking about. Basically, non-correlated type of subquery, the output of the subquery will be substituted into the main query. And in correlated type of subquery, the queries select the data from a reference table in the outer query. Now let's move forward to our next question, that is, can you list the ways to get the count of records in a table? Now to count the number of records in a table, you can use various kind of queries. So there are mainly 3 queries that I've mentioned over here, that is select star from table 1. Star means basically select all, right? When you want to select all the rows, all the records from a table, you can use star. Next, when I say select count star from table 1, that is basically you select all the records from the table 1 and then you count them. And coming to the third query, that is select rows from system indexes, where ID, object ID of table 1 and indeed is less than 2. That means it basically counts the number of records in a table with system indexes. These are the various ways to count the number of records in a table. Now let's move forward to our next question, that is write a SQL query to find the names of employees that begin with the alphabet A. Now to display the name of employees that begin with A, you can type in the command like select star from table name where you mention your table name, where employee name, because I'm considering an employee table in the scenario, like A% in quotes. So when I say A%, all those names starting with A and having any letters or any characters after that would be selected. So guys, that's how you can write a query to find the name of employees that begin with A. Now suppose if you want to write a query to find the names of employees that end with A, what you can simply do is you can again write the similar query like select star from table name, where employee name like percentage A, right? So where the percentage comes forward, that means all the names that start with any alphabet but end with the A will be considered. Now let's move forward to our next question, that is write a SQL query to get the third highest salary of an employee from an employee table. Now to get the third highest salary of an employee from an employee table, you can write a query as you can see on the screen. You can just mention select top 1 salary from, and then write a subquery which says select top 3 salary from employee table, order by salary in a descending order as emp, and then again order by salary in ascending order for the outer query. So you can write a query like this, guys. Now let's move forward to our next question, that is what is the need of group functions in SQL? Now group functions work on a set of rows and return one result per group. So basically some of the most commonly used group functions are the average, count, max, min, sum and variance. So when you say what is the need of group functions in SQL, the need is basically because the group functions work on a set of row and return one result per group. Now let's move forward to our next question, that is what is a relationship and what are the different types of relationship? So relation or links between entities that have something to do with each other can be basically termed as relationships. So relationships can be also defined as the connection between the tables in a database, right? Now the different types of relationships are the one-to-one relationship, the one-to-many relationship, many-to-one relationship, and the self-referencing relationship. When you have a relationship between two tables, that is table A and table B. So when I say one-to-one relationship between both the tables, table A and table B, a single record in table A will be related to a single record in table B. Coming to one-to-many relationship, a single record in table A can be related to many records in table B. Next, coming to the many-to-one relationship, many records in table A can be related to one record in table B. Coming to self-referencing relationship, the self-referencing relationship basically means that you can have a single table out of which two columns are related to each other with a relationship. Now let's move forward to our next question, that is how can you insert null values in a column while inserting data? Now to insert null values in a column while inserting the data, you mainly have two ways. That is either by implicitly by omitting columns from a column list or explicitly by specifying null keyword in the values clause. So guys, these are the two ways through which you can insert null values in a column while inserting the data. Now let's move forward to the next question, that is what is the difference between the between and the in condition operators? The between operator is basically used to display rows based on a range of values in a row, whereas the in condition operator is used to check for values contained in a specific set of values. So if you have to explain with an example for between and the in condition operators, then you can use the example on the screen. You can just write a query like select star from students where roll number between 10 to 50. So all those records from the students table would be selected whose roll number stands between 10 to 50. Coming to the in condition operators, you can use a query like this, like select star from students where roll number in 8, 15, 25. So all those records from a student table would be selected where the roll number would be either 8, 15 or 25. So guys, that is the main difference between the between and the in condition operators. Now let's move forward to our next question, that is why are the SQL functions used? The SQL functions are used to perform some calculations on the data, to modify individual data items, to manipulate the output, to format dates and numbers, and also to convert the data types. So if you want to perform these activities or if you want to perform these actions, then you need to use the SQL functions. Now let's move forward to our next question, that is what is the need of merge statement? This statement is basically used to allow conditional update or insertion of data into a table. So it performs an update if a row exists or an insert if the row doesn't exist. So basically the need of merge statement is that it allows conditional update or insertion of data into a table. Now let's move forward to our next question, that is what do you mean by recursive stored procedure? Recursive stored procedures refers to a stored procedure which calls by itself until it reaches some boundary condition. This recursive function or a procedure helps the programmers to use the same set of code n number of times. So basically you'll first mention the boundary condition and then you'll use the recursive stored procedure to check if it calls by itself till it reaches the specified boundary condition. Now let's move forward to our next question, that is, what is a clause in SQL? Now SQL clauses basically helps you to limit the result set by providing a condition to the query. A clause helps to filter the rows from the entire set of records. So for your better understanding, the example is basically where and having clauses. So when you write a query having these two particular clauses, you basically mention a condition into these particular clauses, right? Like where student number is equal to 2 or having, roll number greater than 5 and so on, right? So that's how you can use a clause in SQL. Now let's move forward to our next question, that is, what is the difference between the having clause and the where clause? Now the main difference between having clause and where clause is basically that, the having clause can be only used with the select statement. It is usually used by the group by clause, and whenever group by is not used, having basically behaves like a where clause. Coming to the where clause, the where clause is applied to each row before they are a part of the group by function in a query. So having clause is basically used with the select statement and it is usually used in the group by clause. When the having clause is not used with the group by clause, the having clause behaves like a where clause. So guys, that was about the difference between the having clause and the where clause. Now let's move forward to our next question, that is, list the ways in which dynamic SQL can be executed. The ways in which dynamic SQL can be executed are by writing a query with parameters using exec and by using sp-execute SQL. So there are basically three ways in which dynamic SQL can be executed. That is by writing query with parameters using exec and using sp-execute SQL. Now moving forward to the next question, that is, what are the various levels of constraints? Now constraints, as I mentioned before, are basically the representation of a column to enforce data entity and consistency. So mainly there are two levels of constraints, that is the column level constraint and the table level constraint. Now let's move forward to our next question, that is, how can you fetch common records from two tables? Well, you can fetch common records from two tables by using the intersect statement. So the syntax of intersect statement is, as you can see on the screen, it's basically select column 1, column 2 and so many columns from the table name where condition, basically you mention the condition over here, then you mention the keyword intersect and then again mention another table name, right? So that is again you mention select the columns from a specific table where the condition matches. So that's how you use the intersect command. So for your better understanding, you can see the example on the screen. You can see, that I have used select student ID, that is basically a single column from student, then use the intersect command, and then again I've mentioned select student ID from a different table, that is exam. So that's how you can fetch common records from two tables. Now let's move forward to our next question, that is, list some case manipulation functions in SQL. So there are mainly three case manipulation functions in SQL, that is the lower, upper and the init cap. Now talking about the lower function, this function basically returns the string in lowercase. It takes a string as an argument and returns it by converting into a lowercase. The syntax of this particular function is basically lower and in brackets you mention strings in quotes. Now moving forward to the next function, that is the upper function. This function returns the string in uppercase. It takes a string as an argument and returns it by converting it into an uppercase, right? So the syntax for this particular function is upper and in brackets you mention the string within the quotes. Moving forward to the third function, that is the init cap. This function returns the string with the first letter in uppercase and the rest of the letters in lowercase. So the syntax for this function is basically init cap and in brackets you mention the string with quotes. So guys, these were the three case manipulation functions in SQL. Now let's move forward to our next question, that is, what are the different set operators available in SQL? So the different set operators available in SQL are union, intersect and the minus operators. So let's talk about union first. So when you consider two queries, that is the left query and the right query, and you apply the union operation, you will see that it will combine rows from both those queries. You'll get an output of all those records from the left table, that is basically the left query, and also from the right query, that is the right table. Moving forward to the next operation, that is the intersect operation. So when you apply the intersect operation to the left query and the right query, you'll see that you'll get only those rows which are common in both the queries, right? So for example, you have 10 rows in the first table and 10 rows in the second table, but the common rows in both these tables are just 2 rows. So you'll get only those 2 rows as an output to this particular operation. Moving forward to the third type of operation, that is the minus operation. So when you apply left query minus right query, you'll see that you'll get only those rows from the left query which are not included in the right query as an output. And when you apply the operation of right query minus left query, you'll see that you'll get only those rows as an output from the right query which are not included in the left query. So guys, these were the different set operators available in SQL. That is the union operator, the intersect operator, and the minus operator. Now let's move forward to our next question, that is, what is an alias command? Now alias name can be given to any table or any column. So this alias name can be referred in where clause to identify a particular table or a column. So that's basically an alias command. So for example, if you see on the screen, you see a query, right? Like select m.employee.id department.result from employee emp department as dep, where m.employee.id is equal to department.employee.id. So what I've given over here is that I've given an alias name to the employee table as emp, and for the department table, I've given an alias name as dept. So that's how you can use the alias command, guys. Let's move forward to the next question now. That is, what are aggregate and scalar functions? The aggregate functions are used to evaluate mathematical calculation and return a single value. These calculations are done from columns in a table. So for example, if you need to consider the aggregate functions, then you can consider the max function and the count function as an aggregate function. Now coming to the scalar functions basically return a single value based on the input value. So if you need an example for scalar functions, then you can consider the u, ks, and now as scalar functions as they're calculated with respect to the string. So guys, this is what aggregate functions and scalar functions mean. Let's move forward to the next question, that is, how can you fetch alternate records from a table? When you answer this question of how you can fetch alternate records from a table, please make sure that you mention a point that you can fetch alternate records, that is both the odd and the even row numbers. Now to display the even row numbers, you can use the command like select student ID from select row number, student ID from student again, where mod row number comma 2 equal to 0. So we're using this function of where mod row number comma 2 equal to 0, right? So when you divide the row number with 2, and if you get the remainder as 0, then that particular row number would be an even number. And similarly, if you get a remainder as 1, then that particular row number would be an odd number. That's how you can segregate the alternate records, that is the even number records and the odd number records. You just have to mention the condition mod row number comma 2 equal to 0 for even, and mod row number comma 2 equal to 1 for odd. Now let's move forward to the next question, that is, name the operator which is used in query for pattern matching. The operator which is used in the query for pattern matching is basically the like operator. So in like operator, you can use either the percentage sign or the underscore sign. The percentage sign basically matches to 0 or more characters. If you use the percentage sign in the query, like select star from students where student name like a percentage, so all those student names whose name starts with A and ends with any character will be taken into account, and all the information related to all those records will be retrieved. And coming to when you use the underscore sign basically matches exactly one character. So when you use the underscore sign in the query, like select star from student where student name like ABC underscore, so all those records, whose student name has a characters which match the pattern ABC, and any character present after that will be taken into account. So guys, that's how you can use the like operator for pattern matching. You can either use the percentage sign with it or an underscore sign with it. Now let's move forward to the next question, that is, how can you select unique records from a table? Well, you can select unique records from a table by using the distinct keyword. So for your better understanding, you can write a query like, select distinct student ID from student, right? So with the help of this query, all the unique records from the student table will be selected. Let's move forward with the next question, that is, how can you fetch first 5 characters of a string? Now there are obviously a lot of ways to fetch the characters from a string. So for your understanding, I've mentioned 2 examples over here. That is, either you can use the substring command or the write command. So when you use the substring statement, you can use the statement like, select substring student name 1 to 5 as student name from student. The first 5 characters of student name will be retrieved from the student table. Now similarly, when you use the write statement, you can use the statement like, select write student name comma 5 as student name from student, right? So with this query, again, all the first 5 characters of each and every student name from the student table would be retrieved. So that's how, guys, you can fetch the first 5 characters of a string, that is either by using the substring statement or the write statement. Now let's move forward with the next question, that is, what is the main difference between SQL and PL/SQL? Now, SQL, as I mentioned before, is a query language that allows you to issue a single query or execute a single insert, update, delete, whereas PL/SQL, that is basically Oracle's procedural language SQL, allows you to write a full program of loops, variables, etc. to accomplish multiple operations such as select, inserts, updates, and deletes. So guys, that is the main difference between SQL and procedural language SQL. In SQL, you just have to write a single query to execute, insert, update, and delete. And in procedural language SQL, you have to write full program with loops and variables to perform multiple operations like insert, update, delete, and select. Now let's move forward to our next question, that is, what is a view? A view is basically a virtual table which consists of a subset of data contained in a table. Since views are not present, it takes less space to store, and views can have data of one or more tables combined based on the relationship. So as you can see on the screen, I have two tables of n number of rows and columns. Now once I execute a query to form a view, you can clearly see that it has combined the columns and the rows from both the tables and has created a view of both of these tables into a single table. That's what a view is. Now let's move forward to the next question, that is, what are views used for? So views, as I just explained, basically refer to a logical snapshot based on a table or on any other view. It is used for restricting the access to data, making complex queries simple, ensuring data independence, and also providing the different views of the same data. So that's what views are used for. Now let's move forward with the next question, that is, what is a stored procedure? A stored procedure is basically a function which consists of many SQL statements to access the database system. Several SQL statements are consolidated into a stored procedure and are executed whenever and wherever required, which obviously saves time and we can avoid writing code again and again. So with the help of stored procedure, you can make sure that several SQL statements are executed again and again, and you don't have to write the query for it again, because if you just have a stored procedure for it, it will automatically execute the queries for you. Now let's move forward with the next question, that is, list some advantages and disadvantages of stored procedure. Let's talk about the advantages first. So a stored procedure can be used as a modular programming, which means create one, store, and call for several times whenever it is required. This supports faster execution, and it also reduces network traffic, which provides better security to the data. Coming to the disadvantages of stored procedure, the only disadvantage of stored procedure is that it can be executed only in the database and utilizes more memory in the database server. So guys, that was about the advantages and disadvantages of stored procedures. Now let's move forward with the next question, that is, list all types of the user-defined functions. So there are mainly three types of user-defined functions, that is the scalar functions, the inline table valued functions, and the multi-statement valued functions. So you mainly have to mention these three functions when you're asked about the different types of user-defined functions. Next, let's move forward and understand what do you mean by collation. So collation is defined as a set of rules that determine how data can be sorted as well as compared. So character data is sorted using the rules that define the correct character sequence along with the options for specifying case sensitivity, character width, and etc. So that's what a collation is, guys. It is basically a set of rules that determine how data can be sorted as well as compared. Now let's move forward with the next question, that is, what are the different types of collation sensitivity? So the different types of collation sensitivity are the case sensitivity, the kana sensitivity, the width sensitivity, and the accent sensitivity. So guys, these are the mainly four types of sensitivities of collation. So I hope that you've understood till now. Next in this session, let's understand what are the local and the global variables. Now talking about local variables first, these variables can be only used or exist only inside the function. These variables are not used or can't be referred by any other function, right? So whenever you want to use local variables, then you need to understand the fact that they can be only used or exist inside a single function, and they can't be referred by any other function. Coming to global variables, these variables are the variables which can be accessed throughout the program. So global variables cannot be created whenever the function is called, but yes, they can be accessed throughout the program. So guys, that was about the local and the global variables. Next, let's move forward and understand what is auto increment in SQL. Auto increment keyword allows the users to create a unique number to get generated whenever a new record is inserted into the table. So this keyword is usually required whenever primary key is used, and auto increment keyword can be only used in Oracle, whereas the identity keyword can be used in the SQL Server. So that was about auto increment in SQL, guys. Next, let's understand what is a data warehouse. Data warehouse refers to a central repository of data where the data is assembled from multiple sources of information. Those data are consolidated, transformed, and made available for the mining as well as the online processing. Warehouse data also has a subset of data called the data mart. So data warehouse can be understood as a central repository of data where the data is assembled from multiple sources of information. So guys, that was about data warehouse. Now let's move forward and understand what are the different authentication modes in SQL Server and how it can be changed. The different authentication modes in SQL Server are basically the Windows mode and the mixed mode. So these two modes are basically used in SQL Windows. And to change the authentication modes in SQL Server, what you can simply do is you have to follow the steps that I've mentioned on the screen. That is, you have to first click on Start, then go to Programs and go to the Microsoft SQL Server and click SQL Enterprise Manager to run SQL Enterprise Manager from the Microsoft SQL Server program group. Now to change the authentication modes in the SQL Server, you can follow the steps that I've mentioned on the screen. That is, you have to click on Start, go to Programs, go to Microsoft SQL Server and click SQL Enterprise Manager to run SQL Enterprise Manager from the Microsoft SQL Server program group. Then select the server from the Tools menu and select SQL Server Configuration Properties and choose the Security page, right? So that's how you can change the authentication mode in the SQL Server, guys. Now let's move forward with the final question in this session. That is, what are stuff and replace function? So talking about the stuff function first, this function is basically used to overwrite existing characters or insert a string into another string. So the syntax for this function is basically stuff, string expression, start, length, and replacement characters, where the string expression is basically the string that will have characters substituted. Start represents the starting position. The length refers to the number of characters in the string which are substituted, and the replacement string are the new characters which are injected in the string. Coming to the replace function, this function is basically used to replace the existing characters of all the occurrences. So the syntax for this particular function is that replace string expression, search string, replacement string, where every search string in the string expression will be replaced with the replacement string. I hope I'm clear with the stuff function and the replace function. So guys, these were the questions that could be asked in your interviews. Let's look at the first question for today's session, that is, mention the differences between SQL Server and MySQL. Now this is one of the most popular questions asked, as you know both of them are relational database management systems. So if you have to give the differences between SQL Server and MySQL, then I would say SQL Server is developed by Microsoft and MySQL was developed by Oracle. SQL Server is a licensed product, so you do not have the free edition for it, and MySQL is an open source software, right? So if you want to know how to install both of them, I'll leave the links in the description box below. But let me tell you over here that you can easily install MySQL in very few steps, but when it comes to SQL Server, you have to enable few ports and name pipes, and then you have to follow a proper step to configure the databases. So I would say if you have to compare the installation step between both of them, then I would say installing MySQL is very easy comparative to that of SQL Server. Coming to the next difference, SQL Server supports C#, Java, C++, PHP, Visual Basic, Perl, Python, and Ruby. Coming to MySQL, MySQL also supports various programming languages like PHP, Perl, Python, Ruby, and so on, right? So both of them offer quite good amount of support to build various kinds of applications using different technologies. Coming to the next difference, I would say SQL Server doesn't allow any kind of database file manipulation while running the database, whereas MySQL allows database file manipulations while running. SQL Server allows query cancellation midway in the process, but this is not the scenario in MySQL, as MySQL does not allow query cancellation midway in the process. Moving on to the next difference, while backing up the data, SQL Server doesn't block the database, but when it comes to MySQL, it blocks the database, right? And coming to the next difference, you can say that SQL Server takes a large amount of operation storage space, whereas that's not the scenario in MySQL, as it takes a less amount of operation storage space. Coming to the last difference, that SQL Server is available in the Express and the Custom mode, and MySQL is available in the MySQL Community Edition and the Enterprise Edition. So guys, these are a few differences between SQL Server and MySQL. Apart from that, also you can answer the interview by talking about your personal experience while using SQL Server and MySQL, right? You might have created databases in both of them, and maybe you have manipulated data using both of them, right? So you can talk, what happens when you want to do a specific set of actions in MySQL and SQL Server. So with this, we come to an end to the first question. Now let's move forward with the second question, that is, what do you understand by SQL Server agent? Now, SQL Server agent is one of the most popular component of SQL Server, right? So basically, if you have to explain SQL Server, then you can just say that, SQL Server agent is a Windows service which is used to schedule and execute the jobs. So here, each job contains one or more steps, and each step can contain a task. So what happens is that the SQL Server agent uses the SQL Server to store the job information and run a job on a schedule. Now, the main components of SQL Server agent are basically jobs, schedules, operators, and alerts. So if you have to explain with an example over here, you can just consider the example like, if an enterprise wishes to take the backup of the company servers at 9 p.m. on every Friday. Now, what you can do is you can just automate this task and let the task happen at the scheduled time. But in a scenario where a backup encounters an error, the SQL Server agent records the events and notifies the corresponding team. So that's how you can use the SQL Server agent, guys. Well, this was one of the simple usage. You can do it in a very complicated way also. So I would just say that, SQL Server agent is one of the most important concept, or you can say the most important component that you need to understand about Microsoft SQL Server. So moving on in this tutorial on Microsoft SQL Server, let's look at the next question, that is mention the different authentication modes in SQL Server. Now, before I tell you the different authentication modes in SQL Server, let me tell you that the authentication mode is used for authenticating a user in the SQL Server. So the authentication mode is selected while setting up the database engine, and the different authentication modes offered by SQL Server are basically the Windows authentication mode and the mixed mode. Now, the Windows authentication mode is used to connect the server through a Windows account. So what basically happens over here is that, the server takes the computer's username and password for authentication purposes. And also the SQL Server authentication mode is disabled in this mode. Coming to mixed mode, the mixed mode is used to connect with an instance of SQL Server using either the SQL Server authentication or the Windows authentication. So in this mode, basically there's a username and a password set by the user for the database. And then when you want to log into your SQL Server, you have to mention those username and passwords. So guys, these were two authentication modes, that is the Windows mode and the mixed mode. Now let's move forward with the next question, that is mention the differences between local and global temporary tables. Now, the local tables are basically those tables which only exist for the duration of the connection or the duration of that particular statement which is executing. But when it comes to global temporary tables, the global temporary tables exist permanently in the databases, and only the rows get deleted when the connection gets closed. Right? So over here, you have to remember that, the structure does not get deleted, only the rows get deleted. So if you have to talk about the syntax between both of them, then I would say the local temporary variable, you can write a syntax as, create table and then put a hash mark and mention the table name. Coming to global temporary tables, the only difference in syntax is that, you have to mention two hashes. So you'll mention create table hash and then again an hash, and then you'll mention the table name. So guys, these were the differences between local temporary table and global temporary table. Now let's move forward with the next question, that is how can you check the version of SQL Server? Now I would say you could be asked this question just to check whether you have a good hand on the commands or not. So to check the version of SQL Server, you just have to mention the command that you can see on my screen, that is select and then @ version. Now this particular command will basically give you the version of the SQL Server that's installed onto your system, and this gives an output as one nvarchar string. Now let's move forward with the next question, that is what is single user mode and what are the steps you should follow to start SQL Server in a single user mode. Now, as the name suggests, the single user mode, this particular mode is basically used when you only want a single user to be active on your SQL Server. So single user mode is a mode where only single user connects to the server. Now you might be wondering, when do we use it, right? Now let me tell you that, it may often happen that you would want to start an instance of a SQL Server in the single user mode. And you would want to do this either when you want to recover the data from other database system, or maybe you want to change the server configurations. So basically there are two scenarios where you would want to use the single user mode. That is, either you want to recover data from the other database system, or you would want to change the server configurations. So when you start the SQL Server in single user mode, then any member of the computer's local administrators group gets connected to the instance of SQL Server as the system admin. Now once you start the SQL Server in a single user mode, what happens is that, a single user connects to the server, and the checkpoint process is not executed since it is executed by default at the startup. Also, note that you have to stop the SQL Server agent service before connecting to an instance of the SQL Server in the single user mode. Now this is a little bit of an extra information that you can give to an interviewer, but I would say it would be nice if you answer like that. Now to start the SQL Server in single user mode, you basically have to use the command of SQL command -m, right? So you just type in SQL cmd-m and then you can start the SQL Server in the single user mode. Now to connect through a query editor in the management studio you can just mention -m and then you can mention the Microsoft SQL Server Management Studio query. That query is completely on your basis that how you want to connect, but these are the two ways through which you can start the SQL Server in a single user mode. So guys, that was about this question. Now let's move forward with the next question, that is, what is the SQL Server Profiler? The Microsoft SQL Server Profiler is an interface used to create and manage traces. So basically what it does is that, it analyzes and replays the trace results. So here, the events are saved in a trace file which are later analyzed or are used to replay a specific series of steps while debugging an issue. Now you can use the SQL Server Profiler for activities as you can see on my screen, like finding the root cause of the problem, monitoring the performance of SQL Server to handle workloads, diagnosing the slow queries, capturing a series of SQL statements causing a problem to further replicate the problem on the test server while debugging the issue, and also correlate the performance counters to debug the issues easily. So guys, this was about SQL Server Profiler. Now let's move forward with the next question, that is, what is the TCP/IP port on which SQL Server runs? Now this is one of the most interesting questions that is asked in interviews. That is because it's a number that you have to guess exactly and then your answer cannot be wrong, right? So well, the answer to this particular question is that the TCP/IP port on which SQL Server runs is 1433, right? So that's 1433 that you have to keep in your minds. Now let's move forward with the next question, that is, what are subqueries in SQL Server, and then can you mention few properties of it? So if I have to explain you what a subquery is, a subquery is a query inside another query where a query is defined to retrieve data or information back from the database. So in a subquery, the outer query is called the main query, whereas the inner query is called the subquery. Subqueries are always executed first and the result of the subquery is passed to the main query. Now subqueries can be nested inside a select statement, update statement, or any other query. A subquery can also use comparison operators like greater than, less than, or equal to. Now if you have to mention few properties of subqueries, then you can say that it must be enclosed in parentheses as it must be executed first before the main query. More than one query can be included, and a subquery should not have the order by clause but can definitely include the where, group by, and the having clauses. The subquery must be on the right hand side of the comparison operator of the main query and must include a select clause and a from clause. So guys, these are a few properties of subqueries. Now let's move forward with the next question, that is, how do you start single user mode in clustered installations? Now in clustered installations, the SQL Server basically uses the DLL available connections and thus blocks any other connection to the server. Now in this state, if you try to bring the SQL Server agent resources online, then it may fail the SQL resources to a different node as it could be configured to a group. So to start a single user mode in cluster installations, you have to follow the steps that you can see on my screen. You have to first go to the advanced properties and then remove the -m startup parameter. After that, you have to put the SQL Server resource offline and then issue the command from the command prompt and make sure that you're at the current owner node of the group. So the command is basically net start MySQL server /m. After that, you have to verify from the cluster administrator or failover cluster management console that a SQL Server resource is still offline or not. And then you have to connect the SQL Server by using the command SQL cmd-e-s and then do the required operations. Once an operation is complete, you have to close the command prompt and then bring back the SQL Server and other resources online through cluster administrator. So guys, these are few steps that you have to follow to start single user mode in cluster installations. Now moving on to the next question, that is, what do you understand by replication in SQL Server and what are the different types of replication that are present in SQL Server? Now replication in Microsoft SQL Server is a process to synchronize the data across multiple servers. Now this is generally done by the replica set, and these sets provide multiple copies of data with redundancy and high availability on different servers. Not only this, but replication also provides a mechanism to recover from the failures. So it basically removes the dependencies from single server to protect the loss of data from that particular server. Now the different types of replication available in SQL Server are merge replication, transactional replication, and snapshot replication. Now the merged replication basically groups the data from various sources to a single centralized database and is used in the server to the client information. Coming to transactional replication, this particular replication is basically a process of distributing data from publisher to subscriber and is used in the server-to-server environments. Moving on to the final replication, that is a snapshot replication. The snapshot replication basically distributes data exactly as it appears at a specific moment and is used for replicating data which changes infrequently. So guys, that was about replication and its type. Now let's move forward with the next question, that is, what are the differences between Microsoft SQL Server and Oracle? Now, if you have to mention the differences between Microsoft SQL Server and Oracle, then MS SQL Server basically provides simple and easy syntax, whereas Oracle consists of complex and comparatively more efficient syntaxes. The MS SQL Server uses basically the Transact SQL or the T-SQL, whereas Oracle uses the PL SQL. Moving on to the next difference, that is, SQL Server does not support query optimization, but Oracle supports query optimization and uses the star query optimization. Moving on to the next difference, in SQL Server, rollbacks are not allowed in the transaction processes, but in Oracle, rollbacks are definitely allowed during the transaction processes. SQL Server allows incremental, partial, and full backups, whereas Oracle allows incremental, full, file level, and differential backups. SQL Server does not support clustering, whereas Oracle offers support for clustered configurations. In SQL Server, statements such as insert, update, delete are executed serially, whereas in Oracle, statements such as insert, update, delete, and merge are executed parallelly. And finally, coming to the last difference, jobs are scheduled via the SQL Server agent in SQL Server, whereas jobs are scheduled via the Oracle scheduler or the OEM in Oracle. So guys, these were a few differences between SQL Server and Oracle. So as I said before, you can also talk about your personal experience while using both of them. Now let's move forward with the next question, that is, what do you understand by intent logs? Now Microsoft SQL Server uses a log hierarchy whenever the data is read or something is changed in the data. So whenever a row is read, the SQL Server acquires a shared log, and whenever you change a row, the SQL Server acquires an exclusive log. So these logs are basically incompatible with each other, and this is where the intent logs come into the picture. So the intent logs are basically used to indicate at a higher level which logs are applied within a log hierarchy. Now there are mainly three kinds of intent logs, that is the intent shared log, the intent update log, and the intent exclusive log. Now as the name suggests, the intent shared log is basically used when you have a shared log at the row level. Coming to intent update log, the intent update log is used when you have an update log at the row level. And finally, coming to intent exclusive log, this particular log is used when you have an exclusive log at the row level. Now let's move forward with the next question, that is, what are the steps you must follow to hide SQL Server instances? Now the steps that you must follow to hide SQL Server instances are as you can see on my screen. Initially, you have to open the SQL Server Configuration Manager, and then you have to go to the SQL Server Network Configuration. After that, in the SQL Server Network Configuration, go to Protocols and choose the instance of the SQL Server. Later on, you just have to right-click on the instance and select the properties. After that, you'll see a dialog box which opens up. So go to the Flags tab in that particular dialog box, and then you see an option of Hide Instance over there. So over there, you just have to go to that particular option of Hide Instance and just say yes. And then open the drop down and choose yes. So once you choose yes, you just have to finally click on OK, and then automatically your instance will be hidden. So guys, these were the steps to hide the instance in SQL Server. Next in this tutorial on SQL Server, let's move forward with the next question, that is, what do you understand by data quality services in SQL Server? So the data quality services in SQL Server is basically a knowledge-driven data quality product, right? So the SQL Server data quality services enable the user to build a knowledge base and thereafter use it to perform tasks such as correction, deduplication, enrichment, and standardization of data. Apart from this, the data quality services also provide profiling and enable you to perform data cleaning with help of cloud-based data services. Now, the DQS services or the data quality services basically consists of two components, that is the data quality server and the data quality client. Now, talking about the server first, so the data quality server is basically a SQL Server instance feature consisting of 3 SQL Server catalogs with data quality functionality and storage. Coming to data quality client, it is also a SQL Server feature which users can use to perform computer-assisted data quality analysis and manage the data quality interactively, right? So guys, that was about the data quality services. Now let's move forward with the next question, that is, explain magic tables in SQL Server. Now magic tables are tables which are automatically created in SQL Server and are used to internally store the inserted, updated values for DML operations such as select, delete, insert, update, and so on, right? So basically guys, magic tables are just automatically created tables in SQL Server used to basically store values, maybe inserted, updated or deleted. And you can understand that, magic tables are used on a temporary basis. Now let's move forward with the next question, that is, what do you understand by change data capture? So change data capture, or most commonly known as CDC, is used to record, insert, update, delete activities applied on the tables. So as the name suggests, the change data capture is used to capture the data that has been changed recently. So the column information and the metadata required to apply the changes to the target information are captured for the modified rows and are eventually stored in the change tables. So these change tables are the mirror images of the original column structure. So guys, that was about change data structure. Now let's move forward with the next question, that is, what do you understand by triggers, and mention the different types of it. So if you have to explain triggers, then triggers are used to execute batches of SQL code whenever insert, delete or update commands are executed against a table. So basically triggers are automatically executed whenever the data is modified based on the data manipulation operations, or you can just understand that triggers are triggered when there's an event happening. So the different types of triggers are basically insert, update, delete and instead of. So guys, that was about triggers. Now let's move forward with the next question, that is, what do you understand by recursive stored procedures? So recursive stored procedure is basically a problem solving method through which you can arrive at the solution again and again and again. Right? So in programming also we see recursive functions, right? So you can just keep calling back the function, and with the help of that you can keep getting solution again and again and again, right? So that's the same in SQL also. Recursive stored procedures is basically a method through which you can arrive at the solution again and again. So that was about recursive stored procedures, guys. Let's move forward with the next question, that is, explain log shipping and its advantages. Now, log shipping is basically the process of automation of backup to restore databases from one standalone server to another standalone standby server. So you can understand log shipping as one of those disaster recovery solutions, as it makes sure that even if one server fails, the standby server will have the same data as that of the server itself. So the advantages of log shipping are, as you can see in my screen. It needs low maintenance and is easy to set up. The secondary database created is used for read-only purposes only, and you can also create multiple secondary standby servers. Not only this, but it also allows a delay specified by the user for the time between the primary servers back up the log of the primary database and when the secondary servers restore or apply the log backup. So guys, these are a few advantages of log shipping. Now let's move forward with the next question, that is, what are trace flags, and mention a few common trace flags that you might have faced. So the trace flags are basically those flags which are used to alter server behaviors or set server characteristics. Now, few common trace flags that all of us use or encounter are basically 1204, 1205, 1222. So all the three of them are used for deadlock information. The 174 trace flag is used to increase the SQL Server database engine plan cache bucket count from 40,009 to 1,60,001 on 64-bit systems. Coming to 1118. So 1118 forces uniform extent allocations instead of mixed page allocations. Moving on to the next one, that is 652. Now the 652 is basically used to disable the page prefetching scans, and 2566 is used to basically run the dbcc check db command without the data purity check unless the data purity option is specified. So guys, these are few trace flags that I've encountered or I've used. Now this answer is not something that you have to give only these trace flags. There are hundreds of trace flags present. So whatever you have encountered or maybe whatever you have used, you can mention that, right? Now let's move forward with the next one, that is, mention the differences between substring and character index in SQL Server. Substring is basically used to return a specific portion of the string in a given string, but whereas the character index is used to return a character position in a given specified string. Right? So for example, if you have substring Edureka 1, 4. So what the syntax mentions is that Edureka is a string, 1 is a starting value from where the characters have to be extracted, and 4 is the range till where the characters have to be extracted. So if you count Edureka on your fingers, we have 7 letters, right? So we've mentioned 1 to 4, so our output should be EDUR, right? So it starts with E, that's our first letter, then D, second one, U, third one, and R, fourth one. But when it comes to character index, as I mentioned before, is used to return a character position in the given string, right? So for example, if you mention an example character index R, Edureka, 1, R is basically the character for which we want to find out the position. Edureka is a string and 1 is the starting range of the string. So if you again count Edureka on your fingers, then you see R is at the 4th position. So we see output as 4. So guys, these were the differences between substring and character index in SQL Server. Now let's move forward with the next question, that is, what do you understand by analysis services in SQL Server? So analysis services in Microsoft SQL Server is an analytical data engine used in business analytics and decision support. So this service basically provides enterprise-grade semantic models for client applications and reports such as Power BI, Microsoft Excel, and other visualization tools. So the analysis services is basically available in platforms like Azure Analysis Services, Power BI Premium, and SQL Server Analysis Services. So guys, that was about analysis services in SQL Server. Now let's move forward with the next question, that is, what do you understand by mirroring, and mention few advantages of it. So mirroring in SQL Server is basically designed to maintain a hot standby server that is consistent with the primary server in terms of the transaction. Also, the transaction log records are sent from the principal server to the secondary server. Now the advantages of mirroring are, as you can see on my screen, it consists of an automatic failover mechanism. It is more efficient than the log shipping and is more robust, and the primary server is synced with the secondary server in real time. So guys, that was about mirroring. Now let's move forward with the next question, that is, when do you think a developer should use SQL Server based cursors? So SQL Server based cursors are used when you wish to work on a record at an instance of time rather than taking all the data from a table as a bulk. However, cursors are not preferred to be used when large volumes of data is present, as it affects the performance. So in a scenario where it is not possible to avoid the cursors, then I would suggest try to reduce the number of records to process by using a temporary table and then eventually build the cursor from this. So I think guys, this is one of the most practical questions that could be asked, where the interviewer checks whether you have practical knowledge of where SQL can be used and how you can use different commands or different functionalities based on the scenarios. Now let's move forward with the next question, that is, what part of database design do you think affects the performance of a SQL Server based application? Well, I would say the physical and the logical design plays an important role in the performance of SQL Server based applications, and we need to ensure that the correct data is captured in the proper tables, the data items have proper relationships between them, and the data redundancy is reduced. I would also suggest that, while you're designing a database, make sure that it is an iterative process to achieve all the required system goals and is under constant observation to make sure, all the client requirements are added and the database satisfies the requirement. Now I'm saying this because, once the database design is set, it's very tough to change the database design according to the requirements that come later on. So you cannot change the basic entities of the databases, but you can only add new relationships and data items. So I would say, if something affects the performance of a SQL Server based application, then I would say the physical and the logical design of the database affects the most. Now let's move forward with the next question, that is, what do you understand by user-defined functions in SQL Server? And then what are the steps to create and execute the user-defined function in a SQL Server? Well, a user-defined function, as the name suggests, is a function written as per the needs of the user by implementing a specific logic. Now, in these kinds of functions, the user is not limited to any predefined functions and simplifies the complex code of a predefined function by writing a simple code. Apart from this, let me also tell you that, the user-defined function returns a scalar value or a table. Now, to create a user-defined function, you can refer to the example that you can see on my screen. I've just created a function sample func, and then in the brackets, I've put @num_int. So basically, it's an integer, and then it returns a table as return select star from customers, where customer ID equal to @num, right? We're trying to basically return all the customer IDs from a customer table and store it in a table. Now, after that, to execute the function that we had just created, you just have to mention the command select star from sample func, that is basically the function's name. And in brackets, you'll mention the customer ID. So for example, I'd mentioned 10 over here. So that's how, guys, you can create a user-defined function and also execute it. Now let's move forward with the next question, that is, how can you ensure that the database and SQL Server-based applications perform well? Well, I would say to ensure that the database and the SQL Server-based applications perform well, a developer must check the types of information stored, the volumes of data, and what data will be accessed. So in a scenario where you're upgrading an existing system, you should analyze the present data, the existing data volumes occur, and then check the method through which the data is accessed to help you understand the problem areas for the design. But on the other hand, if you're creating a new system, then you have to keep the information about what data will be captured, what are the constituents of data, and the relationship between the data items. So like that, the developer can make sure that, the database and SQL Server-based applications can perform well. Now let's move forward with the next question, that is, what are relationships in databases and what are the different types of it? Well, I would say a relationship in database management system is a scenario where two entities are related to each other. So basically, if you have two tables, table A and table B, then the table consisting of the foreign key references to that of the primary key of the other table. So the different types of relationships in DBMS or database management systems are one-to-one relationship, one-to-many relationship, many-to-many relationship, and self-referencing relationship. Coming to one-to-one relationship, so this is basically used when a single row in table A is related to single row in table B. Coming to one-to-many relationship, this is used when a single row in table A is related to many rows in table B. Coming to many-to-many relationship, this is used when you have many rows in table A related to many rows in table B. And finally, coming to self-referencing relationship, this is used when a record in table A is related to the same table itself. Now let's move forward with the next question, that is, what are joins in SQL and what are the different types of joins? A join clause is basically used to combine rows from two or more tables based on a related column between them, and it is used to merge two tables or retrieve data from there. So there are mainly four types of joins in SQL: the inner join, the right join, the left join, and the full join. Right, so I'm not going to go into depth of them. So if you want to know how to use SQL joins, you can refer to my session on SQL joins. On that note, let's move forward with the session and let's look into the next question, that is, what is the command dbcc checkdb used for? So the command dbcc checkdb is used to basically check the physical and the logical integrity of all the objects in the mentioned database. So to do that, it basically performs the operations that you can see on my screen. It runs the dbcc check-alloc on the mentioned database, and on every table and view in the database, the dbcc check table command is executed. It also runs the dbcc check catalog on the database, and then it validates the contents of every index view in the mentioned database. After that, it also validates the link level consistency between file system directories and table metadata while storing var binary max data in the file system using FileStream. Finally, it validates the service broker data in the database. So if you observe clearly, you just have to execute the dbcc checkdb command, and automatically the dbcc check-alloc, the check table, and the check catalog command gets executed. Also, note that dbcc is supported on databases that contain memory optimized tables but does not provide repair operations. So basically, this implies that you must regularly backup databases and test those backups. So guys, that was about the dbcc checkdb command. Now let's move forward with the next question, that is, what do you understand by check constraint in SQL Server? So the check constraint in SQL Server is basically used to limit the values or the type of data stored in a column. Now once you apply the check constraint on a single column, you can go forward and apply specific values for that particular column. See the example on my screen. I've created a table customers with few columns like customer ID, first name, age, and city, and then I've applied the check constraint, and then I've given the name to be check_customer, and the condition that I've applied is basically age should be greater than 20 and city should be Hyderabad. So guys, that is basically how you can use the check constraint. Now let's move forward with the next question, that is, what do you understand by coalesce in SQL Server? Now the coalesce function is used to basically return the first non-null expression within the arguments. So the coalesce command is basically used to return a non-null value from more than a single column in arguments. So to use the coalesce command, you can refer to the example that you can see on my screen, that is select coalesce, and then I've mentioned customer ID, customer name, amount from customers, right? So basically customers was our table, and customer ID, customer name, amount are basically our column names, right? So I'm basically trying to return the first non-null expressions from customer ID, customer name, and amount. Now let's move forward with the next question, that is, explain the usage of floor function in SQL Server. Now the floor function is used to round up a non-integer value to the previous least integer value. This function returns a unique value after rounding of the digits. Now the syntax is, as you can see on my screen, it's basically floor and then you mention the expression. And if you also want to know how to use it, you can see the example on my screen. I've just mentioned floor and then I've mentioned in brackets 7.3. So it will basically round up the value to 7. So guys, that was about the floor function. Now let's move forward with the next question, that is, what is the command used to check logs in Microsoft SQL Server? So to check logs in a database, you have to use an inbuilt stored procedure, that is sp_log. So the syntax is, again, as you can see on my screen, it's sp_log and then you mention @SPID equal to 1 and session ID 1. You can go forward and mention the session ID 2 and so on, right? You can also go forward and explain the command to the interviewer by giving them an example, right? So for example, if you want to list all the logs currently held in an instance of a database engine, you can use the command sp_log, as you can see on my screen. I've mentioned use sample database, that is basically my database name. And then I've mentioned go execute sp_log and then go again over there. So that is basically how I want to list all the logs currently held in an instance of the database engine. Now let's move forward with the next question, that is mention the 3 ways to get a count on the number of records in a table. Now the 3 ways through which you can get a count of the number of records in a table are, as you can see on my screen. You can initially write a query like select star from table name. This will basically retrieve all the data from the table, right? So and over there you can clearly get a count of the number of records in the table. The second way is basically you use the count function, right? So for that, you'll write a query like as you can see on my screen, that is select count, and in brackets you'll mention star from table name, right? So you'll basically count all the row values and then you'll mention. And the third one is basically select rows from indexes where ID equal to object underscore ID. You mention the table name and index ID is less than 2, right? So guys, these are the 3 ways through which you can get a count of the number of records in a table. Now let's move forward with the next question, that is what is the usage of the sign function? Now the sign function is basically used to determine whether the mentioned number is 0, positive or negative. So it will either return 0, +1 or -1. So the syntax is as you can see on my screen, it's just sign and in brackets you mention the number. And if you want to see the example is again on my screen, like if you mention sign 0, then it will return 0. If you mention sign, let's say 21, then it will return 1, and if you mention sign, let's say -21, it will return -1. So guys, that was about the sign function. Now let's move forward with the next question, that is write a SQL query to find the first weekday of the month. Now to find the first weekday of the month, you can write a query like as you can see on my screen, that is select date name, and in brackets you'll mention dw, date add. In the brackets again you'll mention dd, date part, and then in brackets again you'll mention dd, get date, that is basically used to get the current date, +1, get date as first day, right? So that's how you basically get the weekday of the month. Now date add, date part, get date are all predefined functions that you can use. Now let's move forward with the next question, that is mention the command used to rename the database. Now the command used to rename the database is sp_rename db. So to know how to use this command, you can look at my screen. You basically have to mention sp_rename db, and then you have to mention the old database name and then the new database name. So for example, if you have customers initially and then you want to change it to customers information, you mention sp_rename db, customers, and then customer information. So that's how guys you can rename the database. Now let's move forward with the next question, that is write a query to find the 5th highest amount paid from the customers table. Now to find the 5th highest amount paid from the customers table, you can write a query as you can see on my screen, that is select top 1 amount from, and then in a brackets you'll mention select distinct top 5 amount from customers, order by amount in a descending order, and then close the inner brackets and then come out of the brackets and mention order by amount. So basically in a query, we're basically trying to find out the top 5 distinct amounts paid by the customers in the customer table, and then we'll order it by descending order. And when the output comes to the main query or the outer query, in the outer query it is ordered by the amount and then it is in a descending order already, so you just pick up the first amount. So guys, that's how you can write a query to find the 5th highest amount paid from the customers table. Now let's move forward with the next question and understand how can we delete a table in SQL Server. Well, to delete a table in SQL Server, you basically have to use the delete command. So the syntax is as you can see on my screen, you just mention delete and the table name. So for example, if you have to delete the customers table, then you mention delete customers. So guys, that was about how you can delete a table in SQL Server. Now let's move forward with the next question, that is what is the purpose of update statistics and scope identity function. The update statistics function is basically used to update the information used by the indexes, such as the distribution of key values for one or more statistics groups is mentioned in the index view or the table. Coming to scope identity function, the scope identity function is used to create identity values for tables in the current execution scope. Now let's move forward with the next question, that is what do you understand by physical only option in dbcc checkdb command. Well, the physical only option is used to limit the checking to the integrity of physical structure of the record headers page and also the allocation consistency of the database. The physical only check is used to provide a small overhead check of the physical consistency of the database, and this option also causes a shorter runtime for dbcc checkdb on large databases. So it's generally recommended for frequent use on production systems. Now let's move forward with the next question, that is can you explain how long are the logs retained with repeatable read and serializable isolation levels during a read operation with row level locking? Well, with repeatable read and serializable isolation levels, the logs are held during the transaction. Answer to this particular question is that the logs are held during the transaction, But if you consider the read committed, then the logs are held for the isolation level. So guys, that was about this question. Now let's move forward with the next question, that is mention the differences between having and where clause. Well, the having clause is basically used only with the select statement, whereas the where clause is used in a group by clause. The having clause is used with a group by function in a query, whereas the where clause is applied to each row before they are a part of the group by function in a query. Also, note that whenever group by function is not used, having behaves like a where clause, right? So guys, these were the differences between having and where clauses. Now let's move forward with the next question, that is what do you understand by integration services in SQL Server? Well, integration services is a platform offered by Microsoft to build enterprise-level data transformation solutions and integration. Now, these services solve complex business problems by loading data warehouses, perform data wrangling, copy or download files, and manage SQL Server objects. Also, integration services can extract and transform data from a wide variety of sources such as relational data sources, XML data files, load the data into more than a single database. So basically, you can use the integration services to create solutions without coding, or maybe code complex tasks, program the extensive integration object model to create objects. Not only this, but the integration services include a good set of built-in tasks and transformations and graphical tools used for building packages, and also contain the catalog database to store, run, and manage packages. So guys, that was about integration services in SQL Server. Now let's move forward with the next question, that is what do you understand by hotfixes and patches in SQL Server? So hotfixes are single cumulative software packages applied to live systems. So basically this includes one or more files used to address a problem in a software product. The patches are a program installed on the machines to rectify the problem occurred in the system and ensure the security of that particular system. So basically hotfixes are a kind of patch offered by Microsoft SQL Server to address specific issues. Now let's move forward with the next question, that is can you name a few encryption mechanisms in SQL Server? Well, few encryption mechanisms in SQL Server to encrypt the data in database are, as you can see on my screen, that is transparent data encryption, symmetric keys, asymmetric keys, transact SQL functions, and certificates. Right? So these are few encryption mechanisms through which you can protect your data, or you can encrypt the data in a database. Now let's move forward with the next question, that is what are the options which must be sent to allow the usage of optimistic models? Well, the options that must be set to allow the usage of optimistic models are the read_committed_snapshot option and allow_snapshot_isolation option, right? So basically these two options are used, that is the read committed snapshot and the allow snapshot isolation option. So the read committed snapshot option is basically used to read the committed optimistic model, and the allow snapshot isolation is used for the snapshot isolation levels, right? So guys, these are the two options that you must keep in mind. Now let's move forward with the final question for this particular session, that is what are the common performance issues in SQL Server? Now this is one of the most practical questions I would say that could be asked, because it's completely on your experience basis on how much you have used the databases and how many issues that you have faced. So the most common performance issues in SQL Server are fragmentation, input-output bottlenecks, blocking queues, deadlocks, and unused indexes. So these are few common performance issues that I had seen. But if you think you've also seen any other issues, you can definitely go forward and mention it. So I would say in this particular question also, please explain with examples on which scenarios did you see the performance issues and how did you resolve it.
And with this, we have come to an end to this full course on SQL. If you enjoyed listening to this course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists, and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.